will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
In the last video, we showed you a class that had no encapsulation principles. And we saw this created several problems. Allowing direct access to data on an object can bypass checks and operations. It encourages an interdependency or coupling between the calling code and the class. This interdependency makes it hard to change the class without impacting the calling code. For the previous example, we showed that changing a field name broke the calling code. And we also showed that the calling code had to take on the responsibility for properly initializing a new player. Encapsulation solves all three of these problems. Now that we've shown you what not to do, let's create a new class that actually has got proper encapsulation and show you the right way of doing it. Open the project panel, right-click on the SRC folder, select New Java Class, and enter Enhanced Player. The difference here is we're going to create our three fields as private. Private string, name, semicolon. Private int, health, semicolon. Private string, weapon, semicolon. And here we have the name of the player, the health and the weapon, and they are all declared as private. Next, we do want to create a constructor. Placing the cursor below those fields will first create a constructor with three parameters, so select, code, generate, constructor, and pick the three fields. And what we're going to do is use this constructor to make sure the health field stays in the range of 1 to 100 with an if-else statement. Let's edit this constructor a bit. If a user passes a value that's less than 1, we'll just make the health 1. And if we get a value greater than 100, that doesn't make sense either. In that case, we'll make the health just be 100. If opening parentheses, health less than or equal to 0, closing parentheses, opening curly brace. This.health equals 1, semicolon. Closing curly brace, else, if opening parentheses, health greater than 100, closing parentheses, opening curly brace. This.health equals 100, semicolon. Closing curly brace, else, opening curly brace. This.health equals health, semicolon. Closing curly brace. This constructor gives us a little more control about how a new player is created. Now, we could put more validation in there to check the length of the name or to make sure the name we get isn't null, for example, and likewise for the weapon. In other words, we could do some additional validation to make sure that it's valid. And actually, let's create an overloaded constructor that doesn't have health or weapon because we'll set these to some default values. Positioning the cursor above this constructor, select, code, generate, constructor, and then just pick only name this time. We'll edit the generated code and instead chain constructors by calling the three parameter constructor and pass some default values. This will make creating a new player easy, and we can make the default value for health be 100, meaning the player starts out completely healthy. And we'll make the starting weapon a sword. This opening parentheses, name, comma, 100, comma, double quotes, sword, closing parentheses, semicolon. With this constructor, we can create a new enhanced player by just passing the name of the player. And we're guaranteeing now that the name, the health, and the weapon are initialized when the class is created. Now, let's just copy the three methods we had for player. We'll copy lose health, health remaining, and restore health methods from the player class and paste them in the enhanced player class. Okay, then we have a better player class, which we're calling enhanced player. And if we go back now to the main class and main method, we can create a new enhanced player. Enhanced player, Tim, equals new, enhanced player, opening parentheses, double quotes, Tim, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, initial health is plus Tim.health remaining, opening and closing parentheses, semicolon. Now, obviously, if we run that, we should get initial health is 100. But what if we use the other constructor and pass 200 as the health and sword as the weapon? Let's do that and see what happens. If we run that, we can see that even though we pass 200 as health, the health is still 100. Hopefully you can see straight away we've got more control. There's no other way for the calling code to change the health except to call enhanced players methods to do it. This gives all the control back to the enhanced player class. And just to be clear, this is encapsulation. This is what we're doing by making our fields private. We're making sure that the fields within the class aren't accessible to any classes that are outside. And now, let's say I wanted to change the field we use for the player's name, changing it to full name from name, like we did with player. But this time, I want to show you another feature of IntelliJ that's really cool and enables you to do a quick rename. If you actually click on what you want to rename, name in this case, and right-click, go to Refactor, and choose Rename. And now if I go back and change this, the part that's in blue, I change that to full name, you see it turns pink. Before hitting the Enter key, we can scroll down and see every instance of name has been replaced with full name. And if we press Enter, we get a pop-up that asks us if we want to change the parameter names of the constructors, and this really is up to you. But this time I'll select all and hit OK, and it changes the name to full name in our code. And for good measure, let's change the name of the field health to health percentage. This is because that's what we're really talking about, a percentage. A player that's totally healthy means he has 100% health, but near death is 1%. Again, we can select Refactor, Rename, and change that field to health percentage. And press Enter. This time we won't update the parameter in the constructor. And we want to do that this time because I want you to see that the parameter name has no effect on how the code works. The point is, we've now changed two field names. But check out the code in the main method of the main class. It didn't have to change at all. It runs exactly as it did before. The structure to create a new player hasn't changed, and the method name to get the health didn't change. This means the code here, the calling code, has no idea what the internal naming was for the fields. And it doesn't need to. We're just calling this health remaining method, and it's doing the rest for us. This is another cool feature of encapsulation, which is we can make all these changes to this enhanced player class. We can create private fields and private functions that we don't want to be exposed to any other class. And we can change those names at any time in this code without affecting any other code. That's really one of the huge benefits of encapsulation, is that you're not actually affecting any other code. It's sort of like a black box in many ways. What we're saying here is the only way to create an enhanced player object is to call the constructor with these parameters. And we've also got some rules in there for what health can be. But the other thing is we can't bypass the enhanced player's method and change the health field directly. We haven't provided a mechanism to change the health by any other means except to use the methods lose health or restore health. We can pass the initial amount of health in the constructor, but we can't change it after that like we did in the other class. Using the player class, we could set the value, and we actually change the value midpoint when we shouldn't have. But the enhanced player class has more control over its data. This is why we want to use encapsulation. We really want to protect access to our object's data. We protect the members of the class and some methods from external access. This prevents calling code from bypassing the rules and constraints we've built into the class. In this case, as I said, we're using it to make sure that the enhanced player, when we create a new instance, it's initialized with valid data. But likewise, we're also making sure that there's no direct access to the fields. That's why you want to always use encapsulation. It's something that you should really get used to. To create an encapsulated class, you want to create constructors for object initialization, which enforces that only objects with valid data will get created. Use the private access modifier for your fields. Use setter and getter methods sparingly and only as needed. Use access modifiers that aren't private only for the methods that the calling code needs to use. You definitely don't want to be creating code like the player class when you're creating public fields. In the majority of cases, you don't want to give access to other classes because, as you saw, it's more work to make those changes when you create or when you change a field name or something of that nature. Now, we did show you a case in the inheritance video where we use the protected access modifier instead of private. This lets subclasses have direct access to these fields for functions they need to perform, but even this should be used carefully and with a thoughtful, planned approach. Okay, that covers encapsulation. In the next video, we'll go ahead and give you a challenge to give you some practice on using encapsulation. I'll see you in that next video. Welcome to the encapsulation challenge exercise. This is the challenge to create a class and to demonstrate proper encapsulation techniques, such as you've learnt in the previous two videos. In this challenge, you need to create a class name printer. It's going to simulate a real computer printer, a laser printer. The fields on this class are going to be toner level, which is the percentage of how much toner level is left, pages printed, which is the count of total pages printed by the printer, and duplex, which is a Boolean indicator. If true, it can print on two sides of a single sheet of paper. On the printer class, you want to create two methods which the calling code should be able to access. These methods are add toner, which takes a toner amount argument. Toner amount is added to the toner level field. The toner level should never exceed 100% or ever get below 0%. If the amount being added makes the level fall outside that range, return a -1 from the method. Print pages, which should take pages to be printed as the argument. It should determine how many sheets of paper will be printed based on the duplex value. The sheet number should be added to the pages printed variable. If it's a duplex printer, print a message that it's a duplex printer. In this challenge, we want to demonstrate proper encapsulation techniques with this class. Try that out, and when you're ready to come back and see my solution, start the video again and I'll go through it with you. Pause the video now. Okay, how did you get on? Did you create a solution for the printer class using good sound encapsulation techniques? Now, let's give this a go together. I've already created a new project called Encapsulation Challenge with the usual main class and main method. Leaving that for a minute, we want to create the printer class, so right-click on SRC, New, Java Class, and just call that class Printer. And we want to start with our fields, adding toner level, pages printed, and duplex. Private, int, toner level, semicolon. Private, int, pages printed, semicolon. Private, Boolean, duplex, semicolon. And the important thing here for encapsulation is to make all of these fields private. Okay, then we want to do the constructor. We only want to have two fields in the constructor parameters, the toner level and also whether it's duplex. We'll leave pages printed out of the constructor because that would normally be managed by this class and not passed in when we create a new printer. Putting our cursor below those three fields, let's generate the constructor. So select, code, generate, constructor, and pick toner level and duplex. Now, we don't have to set pages printed to 0 because that's the default value for a class variable that's an integer, but you can always specify it for clarity. And we'll do that, but we also don't want to set the toner level to whatever we get passed to us on the constructor. Remember, we don't want to allow the toner level to ever be less than 0 or greater than 100. We're going to set the variable toner level to the result of a ternary operation. This dot pages printed equals 0 semicolon. This dot toner level equals opening parentheses toner level greater than or equal to 0 logical and operator toner level less than or equal to 100 closing parentheses question mark toner level colon -1 semicolon. This code says that if the toner level falls in the range of 0 to 100, we use that value, otherwise we'll set toner level to -1. Okay, now we've created a controlled way to initialize the printer. Next, let's add the methods we want the outside world to use, the add toner method and the print pages method. Starting with add toner, we'll add this method before the closing bracket of the class. Public int add toner, opening parentheses, int toner amount, closing parentheses, opening curly brace. Toner level plus equals toner amount semicolon. Return toner level semicolon. Closing curly brace. Here, we're starting out just adding the value of the argument, toner amount, to the current toner level. but this doesn't address the problem that this could make the toner level go beyond 100% or below 0. Let's type this out and we'll review it afterwards. Int temp amount equals toner amount plus toner level semicolon. If opening parentheses temp amount greater than 100 logical, or operator temp amount less than 0 closing parentheses opening curly brace. Return -1 semicolon closing curly brace. You can see here we're setting a local variable to toner level plus toner amount. Then we test if this variable is outside of the 0 to 100 valid range. If it is, we want to return from the method with a -1. This means that if we get a -1 from this method, there was an error. And if that's the case, we're not actually setting anything, we're not going to change the value of our toner level. Okay, we're almost done. Let's add the last method, the print pages method. We'll type this one out and again discuss it in a bit. Public int print pages opening parentheses int pages closing parentheses opening curly brace. Int job pages equals opening parentheses duplex closing parentheses question mark opening parentheses pages divided by 2 closing parentheses plus opening parentheses pages modulo 2 closing parentheses colon pages semicolon. Pages printed plus equals job pages semicolon. Return job pages semicolon closing curly brace. Here again, we're using a ternary operator which tests if this is in duplex mode. Think about what duplex means for a moment. 2 pages will get printed on 1 sheet of paper, but 3 pages will need 2 sheets of paper. This means the calculation we need doesn't just divide the number of printed pages by 2, but we need to add in an additional page if it's an odd number. We do this with this formula that first divides the requested pages by 2 and then adds the modulo value of that same divisive action. The result of the modulo operation will only ever be a 0 or 1. This means when it's an odd number of pages, an extra sheet of paper is included. If it's not duplex, the result is just equal to the pages argument. And we assign this to a local variable we're calling job pages. Then we add these job pages to the field pages printed. But we return the job pages from this method because we want to report how many pages were actually printed for the current request. And that's the print pages method. The last thing we want to do is to add a getter so that we can actually retrieve the number of pages printed to check that the value was correct. With our cursor before the closing class bracket, we can select code, generate, getter, and pick pages printed. And there's our getter created. And that's our basic class, and we can now go and try using this class. We'll go to the main class, main method, and create a new printer. We'll start it out as a duplex printer with 50% toner level. Printer equals new printer, opening parentheses, 50, comma, true, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, initial page count equals plus printer.getPages printed, opening and closing parentheses, semicolon. Here again, we're using encapsulation with this constructor and also with our getter, meaning we're not accessing the field directly, which is correct. And running that tells us that the initial page count is 0. Next, let's do some work. We'll print some pages, an odd number of pages, to test our calculation for duplex printing. Int pages printed equals printer.printPages, opening parentheses, 5, closing parentheses, semicolon. System.out.printf, opening parentheses, double quotes, current job pages, colon, %d, comma, printer total, colon, %d%n, comma. Pages printed, comma, printer.getPages printed, opening and closing parentheses, semicolon. In this code, we're using printf because we have 2 values we want printed, and we're ending that format string with a %n, which adds a line separator after. And we pass the pages printed variable, which is the pages printed for the job that just ran, and then we use the getter method on printer to print the total number of pages printed. And running that, we get that the current job pages was 3 and the printed total is also 3. Okay, that's good and it's working, so now we'll test printing a few more pages. And we can copy those last 3 lines and paste them. I'm not going to copy the in type because we don't want it in the next statement. And we want to change 5 to say 10. And running that, we get the last output as the current job. From this output, you can see that the last job printed 5 pages because we printed 10 pages in duplex mode, and then the printed total is 8 because we ran 2 jobs, and this keeps a count of total pages printed. And we can repeat these tests with duplex mode set to false. We'll just change the value when we create the printer object. And running that, we can see that the pages have increased and the numbers are the same as the requested pages. After the last job, we see 10 pages printed with a total of 15 calculated on the printer after both jobs were run. And there you have it. That's the printer class using encapsulation. It's a good object-oriented sound programming practice to use encapsulation to hide that functionality from your other classes. In this case, you can see that we're not accessing any fields directly, and we've got proper methods that are actually doing the appropriate calculations of adding and subtracting numbers and doing validation hidden away from the user. Okay, that was the encapsulation challenge. I hope you got a lot out of that. Let's move on now to the next video where we'll be talking about polymorphism and what that is. In the previous video, we finished off our encapsulation challenge. In this video, we'll make a start on polymorphism. We've said it before that simply stated, polymorphism means many forms. And you might be wondering, how does this apply to code? Well, polymorphism lets us write code to call a method, but at runtime, this method's behavior can be different for different objects. This means the behavior that occurs while the program is executing depends on the runtime type of the object. And the runtime type might be different from the declared type in the code. The declared type has to have some kind of relationship to the runtime type, and inheritance is one way to establish this relationship. There are other ways, but in this video, we'll talk about how to use inheritance to support polymorphism. We've given you a taste of this in the inheritance videos, but this time we're going to look at polymorphism specifically. Hopefully by now, you're getting more comfortable with class diagrams. This time, we're going to look at a polymorphism example using movies. We'll have a base class of movie, which has the title of the movie. And movie will have one method, watch movie. We'll have 3 subclasses, each a different kind of movie. We'll have an adventure film, a comedy, and a science fiction movie. These are the different categories, so we'll use these as the subclasses. All of these will override and implement unique behavior for the watch movie method. I've already created a project called polymorphism with the usual main public class and main method. And we'll now create the class called movie by right-clicking on src, new, Java class, and we'll give that the name movie. And we'll add our one field, title, as a private field. Private string, title, semicolon. And next we'll generate a constructor, placing our cursor under that field, and select code, generate, constructor, and pick title, and we get the constructor. And now let's add the watch movie method. This is the public method that's going to be called from the outside world or the calling code. And this is the method that we'll be using to demonstrate polymorphism. Public, void, watch movie, opening and closing parentheses, opening curly brace. String, instance type, equals this .get class, opening and closing parentheses, .get simple name, opening and closing parentheses, semicolon. System.out.println, opening parentheses, title plus, double quotes, is a plus, instance type plus, double quotes, film, closing parentheses, semicolon. Closing curly brace. Now here, on the first line of this method, is something new. You've seen the use of the keyword this before, which refers to the current instance, and now we're calling a method on that called getClass. The method getClass is on java.lang.object, which we've talked about. This method returns class type information about the runtime instance on which this method is executing. And from that, we can get the name of the class using the getSimpleName method. And here again, we're just using method chaining for convenience. This prints out the class, which will be movie if we execute this method on a runtime movie object. But when we implement the subclasses and run this method, the runtime object could be an instance of one of those classes, the adventure class, for example. This will hopefully make more sense when we run this code. Next, in this code, we print out the title of the movie and the type of the movie runtime instance. And that's the movie class. Let's go to the main method on main class and test out the watchMovie method. Movie, the movie, equals new movie, opening parentheses, double quotes, Star Wars, closing parentheses, semicolon. The movie.watchMovie, opening and closing parentheses, semicolon. And running this, we get the output that Star Wars is a movie film, and that's because the runtime instance of the movie variable is the movie class. It's the object we created here in the main method, and we did new movie, which means it's really an instance of a movie. Here, we've created the object using the new movie statement and passed it the title Star Wars. And then we assigned our movie instance to a movie reference variable, and here we just called it the movie. Okay, so no surprises there, I hope. What we'll do next is add some subclasses of movies that represent different genres or classifications of movies. You can think of these as the way a streaming company would group different movies. And we'll start with the adventure movie type. We'll add this class to the movie.java source file, and we won't give it an access modifier, meaning it has package or default access. But we're going to have it extend movie. Class, adventure, extends, movie, opening curly brace. Closing curly brace. This doesn't compile yet because we need to add a constructor. Placing the cursor before the closing bracket, select, code, generate, constructor, and we get the generated constructor, which uses movie's field, title, as a parameter and makes a call to super using that argument. Now we've got the constructor, and an adventure movie will get created with just the title of the movie. Next, we want to implement or override the watchMovie method. When you're overriding a method, it's a pretty good idea to start with IntelliJ's override generation tool. This ensures that your method signature is right, so let's do that for this class. Placing the cursor below the constructor, select, code, override methods, and select the watchMovie method on movie. And that gives us the IntelliJ's default generated code, which includes the override annotation, which we've seen before. And this method simply calls the method on the movie class, which is the super or base class for adventure. That's good. We want to do that, but we want to include extra functionality that's specific to the adventure class, like some of the major plot stages of an adventure film, for example. And we'll just use the printf method as well as the repeat method on string to print out the plot stages, 3 stages on 3 lines. System.out.printf, opening parentheses, double quotes, dot%s%n, dot repeat, opening parentheses, 3, closing parentheses, comma. Double quotes, pleasant scene, comma. Double quotes, scary music, comma. Double quotes, something bad happens, closing parentheses, semicolon. Let's talk about this code a minute, because here we're using the format specifiers %s and %n. The format specifier, %s, is used to replace any string, which is not as commonly used as others we've shown you, but it will work well here. And we've said before that %n puts in a new line there. Now this string gets repeated 3 times with this repeat method before the formatting takes place. This means that all these stage plots gets printed, each on its own line. Now let's go back to the main method and test out the makeMovie method on an adventure object this time. And what we can do here is simply replace this new movie statement with new adventure instead. We don't have to change the type of the movie variable. It can stay as movie. And this is because adventure is really a type of movie, a subclass. And inheritance lets us say adventure is a movie, and it's okay, we can do this, we can assign an adventure object to a movie variable. This code compiles, and we can run it. And now look what happened. The code ran the watchMovie method on the adventure class. That's because at runtime, the method that gets run is determined by the Java virtual machine based on the runtime object and not this variable type. And there's our first taste of polymorphism in this code. We've declared a variable of type movie and assigned it an object that's really an adventure type of movie. And when we called watch movie on that, the behavior was the adventure movie's behavior. It wasn't just the base class's behavior. Now, the method that's on the adventure class first calls movie's method, which is why we see that first statement, Star Wars is an adventure film. But this time, we get the text that this is an adventure film there, and this is the actual type of the object at runtime. And then we have the plot stages for an adventure film, pleasant scene, scary music, and the last one, something bad happens. And that's a really simple example of polymorphism. Let's keep going and building on this. Getting back to the movie.java source file, we'll create the comedy subclass next. And what we'll do is copy the adventure class and paste it directly after that class. If you close the class node, copy and pasting is a little easier. And we can expand the pasted class node. We'll change the name of the class to comedy. We'll change the constructor to comedy. And we also want to change some of the stages for the plot to some that make more sense for a comedy. Maybe the first stage is something funny happens, and the second one could be something even funnier happens, and maybe the next and last stage could be happy ending. We can really do whatever we want in this method, but right now we're keeping it simple. But we could call other methods, have many more stages to the plot, or whatever. Okay, we have 2 of our movie subclasses built, but let's do the last one, which we're calling science fiction. Again, let's just paste the adventure class below the comedy class, and then change the name of the class to science fiction, and change the constructor to science fiction. And then we'll change these 3 stages to make more sense for a science fiction movie. So let's say Bad Aliens Do Bad Stuff is the first stage, then Space Guys Chase Aliens after that, then finally Planet Blows Up. And that's the science fiction class, which means now we've built the movie class and all of its subclasses. Let's just expand the adventure class so we can see its code. Since this video is starting to get a bit long, we're going to stop it here. We've created an inheritance hierarchy with movie and 3 subclasses. We've assigned an adventure movie instance to a movie variable reference and saw that when it ran, Java figured out which method to run, not on the compile time code, but on the runtime instance's method. In the next video, we'll pick up from here and show you what you can do with polymorphism. In the last video, we set up our inheritance tree for movies with 3 subclasses. In this video, I want to show you something a little different. Up until now, we've always had the main method or calling code create instances of the object. But this time, we'll create a method on the movie class that the calling code can execute that will return a movie instance for us. We'll make this method public and static, which means anybody can call this method to get a movie instance based on the parameter type being passed in and a title. Let's type this method out partially. Public static movie get movie opening parentheses string type comma string title closing parentheses opening curly brace. Return switch opening parentheses type dot to uppercase opening and closing parentheses dot chart opening parentheses 0 close both parentheses opening curly brace. Default return type new movie opening parentheses title closing parentheses semicolon closing curly brace semicolon closing curly brace. In this code, the parameters of this method are the type of the movie and the title. And we're going to return an instance of the movie class or a subclass of a movie. And this gets returned by the switch expression. But what are we really doing here with the switch expression? Well, we're taking whatever was passed to us, making it uppercase, then just getting the first letter. In our case, each of our subclasses has a unique letter for its class name, so we can use that to figure out the right kind of movie to create. And just for now, we're returning a generic movie instance. Now let's go back to the main method and test that out. We'll call the static method on movie to get an adventure movie. Movie, the movie, equals movie.getMovie, opening parentheses, double quotes, adventure, comma, double quotes, Star Wars, closing parentheses, semicolon. Now, notice if we run this, it works, but we're still not really getting an adventure movie. The output is just Star Wars as a movie film. That's because we haven't really completed the getMovie method. Going back to the movie class, we want to add the code to return the different subclasses based on the type argument. Case, single quotes, return type, new, adventure, opening parentheses, title, closing parentheses, semicolon. Case, single quotes, C, return type, new, comedy, opening parentheses, title, closing parentheses, semicolon. Case, single quotes, S, return type, new, science fiction, opening parentheses, title, closing parentheses, semicolon. Here, our switch expression is really evaluating a char, a single character. We get this character from the string method, char, that we're using in the switch expression. That's going to give us the first letter of the type. And if that's an A, we'll return a new adventure instance. If it's C, we'll return a comedy. Lastly, if it's an S, that means we want to create a new science fiction movie. If it's not an A or C or S, then we'll just return the base class, an instance of movie. By providing this method, the code in the main method, the calling code, doesn't really need to know anything about any of movie subclasses. It can just pass in the type and get a different type of movie subclass. This kind of method that returns a new instance object is known as a factory method in software programming design patterns. Factory methods give us a way to get an object without having to know the details of how to create a new one or specify the exact class we want. Actually, if we run this code now from the main method, we see that we really do get an adventure object back because you can see adventure film there on the first line. The getMovie method returned an instance which we maybe didn't know what it was and maybe we don't really care. But because the runtime object was an instance of the adventure class, the method on that class was executed. And now we can see the output for an adventure instance with the title Star Wars that it's an adventure film. And then we also get the 3 plot stages for the adventure class, pleasant scene, etc. Okay, next we'll change the main method, passing science fiction, because really Star Wars is more of a science fiction movie. And really, we don't have to type in the full class name, we can just put in science or even S if we wanted. And then we see Star Wars is a science fiction film and we get some different plot stages like bad aliens do bad stuff, space guys chase aliens, and finally, the planet blows up. With this method, the calling code doesn't need to know about each subclass or how to create different instances of movies. We can just call this method, passing the type and name, and the right object type is instantiated and returned, but it's assigned to a variable with the movie type. So this code will work for any movie or any of its subclasses, including subclasses that haven't even been created yet. This keeps all the information about movie and its subclasses in the control of the movie class and simplifies the work that needs to be done by the calling code. That sounds like a good encapsulation technique, doesn't it? Okay, go back to our main class and main method. We'll use polymorphism to watch a variety of movies. This time, we'll make the code interactive using the scanner class we've seen before. We'll let the user enter the type of movie and then the title of the movie they want to watch. First, we'll comment out the first 2 lines of code, then add the code for a new scanner. Scanner S equals new scanner opening parentheses system.in closing parentheses semicolon. In the exception handling video in section 6, I showed you how to manually add import lines. Because I still have auto imports enabled, you just saw how IntelliJ added the import for me automatically. Pretty nice, right? Let's go back to the code and demonstrate that, and then move on with the code. I'll temporarily comment out this scanner line. And as you can see, IntelliJ removed the import line for scanner. Why? Because it determined that the scanner class was not being used and as a result the import was no longer needed. Let's try entering another line of code that needs an import statement. I'll type list equals new array list less than string greater than opening and closing parentheses semicolon. Ignore this code for now. I'm using it purely to demonstrate auto import. You can see that IntelliJ has added 2 different imports because of what was typed. I'll delete that line I just added. Note the two import lines got deleted. And now I'll uncomment the scanner line. And you can see that IntelliJ has added back the scanner import. Essentially, IntelliJ adds and manages the imports for you as much as it can with the auto import option turned on. So that's auto import. These are the types of little automations that collectively make you a much more productive programmer. Right, moving on. Okay, next we'll create a loop, so we'll keep getting information from the user until they quit out of the loop, while opening parentheses, true, closing parentheses, opening curly brace. System.out.print, opening parentheses, double quotes, enter type, opening parentheses, A for adventure, comma, C for comedy, comma, plus. Double quotes, S for science fiction, comma, or Q to quit, closing parentheses, colon, closing parentheses, semicolon. String type equals S.next line, opening and closing parentheses, semicolon. Closing curly brace. In this code, we're using a while loop with a condition that's always true. That's really an infinite loop, and you definitely don't want to run this code yet. But first, we'll prompt the user for the type of movie, enter for adventure, C for comedy, S for science fiction, or enter Q to quit. After that, we'll get the user's response using next line method on scanner. We want to get all the data they entered up to and including the new line. The next line method gets the type of the movie they want to watch, but we're not doing anything with it yet except assigning it to type. If we ran this now, we'd be stuck in an infinite loop. We need to add the code to break out of the loop next. If opening parentheses, double quotes, qq.contains, opening parentheses, type, close both parentheses, opening curly brace. Break, semicolon, closing curly brace. Okay, what is this code doing? This if statement uses the contains method on a string, which we've covered briefly in the string videos. Here, we have a string literal that has an uppercase and lowercase q in it, and we're using contains to test what the user entered. This means if the user enters a single character, either an uppercase or lowercase q, then the code will break out of the loop. The contains method will determine if the string literal qq contains the single letter q and returns true. Now that we can get out of the loop, we next want the code to get the title of the movie. And after that, we use the factory method on the movie class to get the right kind of instance. System.out.print, opening parentheses, double quotes, enter movie title, colon, closing parentheses, semicolon. String title equals S.next line, opening and closing parentheses, semicolon. Movie equals movie.getMovie, opening parentheses, type, comma, title, closing parentheses, semicolon. Here again, we prompt the user to enter the movie title, and we'll read that in using the next line method on scanner. After that, we can call movie.getMovie to get an instance of a movie, passing the type and title that the user entered. And regardless of what comes back from this method, we're going to assign it to a variable with a type that we've set as movie. So as long as whatever is being returned from the getMovie method is a movie or a subclass of movie, we can assign it to a movie variable. And because it's a movie variable, we can call any of movie's methods on it. And that method is watchMovie. Movie.watchMovie, opening and closing parentheses, semicolon. And running this code now, we get prompted to enter the type, so let's just enter an S for science fiction and press enter. And now we'll put in the title, and I'll type in Star Wars, but you can enter anything you want there. And look at the output for the Star Wars science fiction movie. The code called the method watchMovie using a movie reference variable. But at runtime, the movie wasn't really a movie, it was an instance of the subclass, the science fiction class. And it was the method watchMovie that's actually declared on the science fiction class that really got executed. This is polymorphism in action. Our compiled code in the main method of the main class never knew anything about the science fiction class or any of the other subclasses. But at runtime, we got an object of type science fiction back from the factory method. And when the method watchMovie was called on that, it called watchMovie on the science fiction class. I hope you agree with me that that's pretty neat. And don't forget, the watchMovie method on science fiction first called the method on movie, and we can see that first output statement, Star Wars is a science fiction film. This got printed out because we called super.watchMovie when we overrode that method on the science fiction class. Let's try another example since we're still in the loop here. This time I'll enter an A for adventure and then Jaws for the title. And here you can see that Jaws is an adventure film. And now the stages are printed out and they're different from the ones before: pleasant scene, scary music, and something bad happens. And finally, let's test out a comedy movie by entering C, and I'll enter airplane as the title. And there you have it. We have the stages of a comedy: something funny happens, something even funnier happens, and happy ending. And we've tested out all three of our subclasses. If we wanted to, we could even put in a type that's not in this list. Let's try that. We'll put in D for documentary and link in as the title, for example. And since there was no subclass for a documentary type, the code just returned a movie instance. But what happens if we decide now to support the documentary as a new subclass? Well, the code in the main method wouldn't have to change at all. We can change the factory method getMovie on the movie class to return additional movie subclasses as we create them. When we do that, this code in the main method would still work and work with the new subclasses. It wouldn't have to change. This is the beauty of polymorphism as well as encapsulation. Okay, we'll quit out of our loop now by just entering Q. And since we're looking at this code in the main method, you can see that call there, movie.watchMovie. That one statement is actually doing quite a bit of work. Java uses the runtime object type to see if that object has got its own version of the watchMovie method. And you can see in this case, if you look at the first case, which gave us the science fiction movie. And now Java is smart enough to execute this method watchMovie. And it calls the watchMovie method on the parent class first because of the super.watchMovie, that it prints these three stages of the plot that are specific to the science fiction class. Now, in this case, it's a simple method. But you can imagine that we could have far more complex functionality built into that if we wanted to. Okay, that was polymorphism in action. It's the ability to execute different behavior for different types which are determined at runtime. And yet we did it with just two statements in the main method as shown here. Polymorphism enables you to write generic code based on the base class or a parent class. And this code in the main method is extendable, meaning it doesn't have to change as new subclasses become available. This code can handle any instances that are a movie or a subclass of movie that are returned from the factory method, even ones that don't exist yet. Let's end this video here, and in the next video we'll be talking a little more about reference types and casting with reference types. And we'll introduce you to a fairly new Java concept which uses the var keyword called local variable type inference. I'll see you in that video. In the last video, we showed you an example of polymorphism in action, and we're showing the code here that uses it. There are two lines in this code that are really important for you to understand. These are on lines 20 and 21. To make this discussion simpler, let's create a new class. I'll open the project panel, right-click on SRC, select New, Java class, and we'll call this class NextMain, and we'll create a main method in this one as well. We can type in the shortcut PSVM, and that'll give us the main method. And what I want to do is copy those two lines of code from main to NextMain, and we'll just hard code the arguments in that call to getMovie. We'll pass it for an adventure movie and Jaws as the title. Now let's talk about these two lines of code because there are several things happening here. First, we're creating a variable with a movie type and we've called it movie. We then assign the result of this static method, movie.getMovie, to that variable. We know we could have done this several other ways. Let's use that method and try to assign it to an adventure variable, since we know that we'll really get an adventure movie if we call it this way. Adventure, Jaws, equals movie.getMovie, opening parentheses, double quotes, a, comma, double quotes, Jaws, closing parentheses, semicolon. Now, this code doesn't compile. IntelliJ tells us that the required type is adventure and provided is movie. Why is this a problem? First of all, the compiler isn't going to run the code to figure out what will really happen. it has to be satisfied with making assumptions about the code based on how we write the code. In this case, we declared that the method getMovie is going to return a movie class. We didn't say it was going to return an instance of the adventure class. The compiler asks the question, can every kind of movie, which is the return type of this method, be called an adventure, meaning can every kind of movie be assigned to an adventure variable? And here, the answer is no. The adventure reference, JAWS, would not be able to handle a comedy movie if that got returned, for example. That's because we can't say a comedy is an adventure. But we absolutely know that when we pass the letter as the type, that we'll get an adventure movie back. But the compiler can't figure that out without executing code, and it's not going to do that. Now, we can give the compiler more detailed instructions to get around this issue. One way to do this is casting. Like casting with primitives, we can cast instances, so let's do that here. We'll cast the result of the movie.getMovie to an adventure type. And we'll also have the call to watch movie here. JAWS.watchMovie, opening and closing parentheses, semicolon. Okay, now this code compiles, and we can give it a go and run it. And we can see that it runs just like it did in the 2 lines above these. But what happens if we make a mistake and we pass AC as the type? We know that doing that should give us a comedy movie. But let's not change anything else and just see what happens. We've told the compiler with this cast that we're smarter than it and to just leave this line alone. So this code compiles, but if we run it, we get a special kind of exception, a class cast exception. And the message is pretty informative that we got a comedy object when an adventure object was expected. This is a bad situation to have your code compile but then get exceptions at runtime. Okay, maybe you're asking, when can you assign an object of one type to a reference with a different type? Well, first of all, you can assign any object to a reference that is of type object. We'll try that next. First, we'll revert that last change. And then we'll create a comedy instance but assign it to an object reference. Object comedy equals movie.getMovie, opening parentheses, double quotes, C, comma, double quotes, a plain, closing parentheses, semicolon. Comedy.watchMovie, opening and closing parentheses, semicolon. Here, now we've created a variable called comedy, but we've set its type as object. And this code doesn't compile, but not on the first line where we're doing the assignment, but on the second statement. Can you figure out why? The compiler won't use the method return type to figure out what comedy really is after you make this assignment. It just assumes it's an object, and this variable only has access to objects functionality. This is because, at any time in the code, an instance of object itself could be assigned to this variable. And the code has to work for whatever object gets assigned to this variable. This means that when you try to call a movie method on this object reference, you'll get an error. This is because the compiler can't locate that method, watchMovie, on the object class. Let's pause here a minute to add a method on each of the subclasses, and we'll make each method unique to the class. Going back to the adventure class, we'll add a simple method that's only on that class. Public void watchAdventure, opening and closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, watching an adventure, closing parentheses, semicolon, closing curly brace. And let's copy that method. We'll paste it in the comedy class. And we'll change the name to watch comedy and then change the text to watching a comedy. And we'll repeat that for science fiction, so I'll paste that method in the science fiction class. Change the name. And change the text, this time making it watching a science fiction thriller. Now, let's get back to the code in the next main class. And if we try to run watch comedy on that object variable, we have the same problem that we had with watch movie. It doesn't see that method watch comedy on the object class, and it's not going to compile. Let's revert that back for the moment. Now, you could assign every instance to an object reference like this, but you wouldn't be able to do much with them without casting them to other type references. In other words, to run watch movie on comedy, which has the type object, we'd have to cast it to a movie. And we can do that. We'll cast the object reference to a movie reference, and then we'll execute watch movie on that new reference variable. movie, comedy movie equals opening parentheses, movie, closing parentheses, comedy, semicolon. What I want you to see by this is that using references that are too generic, like object, means you'll be doing a lot of casting. But even now, since we cast to a movie, check out what happens if I want to execute one of the methods we just added, watch comedy. This doesn't compile either. For the same reason we couldn't execute watch movie on an object reference, we can't run watch comedy on just a movie reference. The compiler will only look at the reference type to determine if that method is on that type, and watch comedy is not on the movie class. In this case, we'd need to actually cast to a more specific type, comedy. And let's do that. And now all of that works, so that's good. For good measure, let's try one other thing. var appline equals movie.getMovie, opening parentheses, double quotes, c, comma, double quotes, appline, closing parentheses, semicolon. Appline.watchMovie, opening and closing parentheses, semicolon. This code compiles, but here is something new. We haven't used this before, and you're probably asking, what does this var word mean? Well, var is a special contextual keyword in Java that lets our code take advantage of local variable type inference. By using var as the type, we're telling Java to figure out the compile time type for us. Since the movie class was declared as the return type of the static method getMovie, then Java can infer that the type of this variable, airplane, should be a movie. You can see that in the hints if you've configured IntelliJ to show them. Now, why didn't it infer that it was a comedy class? Nothing about the signature of the method indicated that a comedy instance might be returned from the method, only that a movie would be. Okay, let's try another example of using type inference, this time by just assigning a new instance. var plain equals new comedy, opening parentheses, double quotes, appline, closing parentheses, semicolon. Plain.watchComedy, opening and closing parentheses, semicolon. In this case, the compiler had an easier job to infer the type because we're simply assigning a new instance of comedy to this variable, plain. But you can see now that using this plain variable, we can execute methods specific to comedy without compile time errors. Local variable type inference was introduced in Java 10. One of the benefits is to help with the readability of the code and to reduce boilerplate code. We'll look at this feature in a lot more detail in the section on generics later in this course. It's called local variable type inference for a reason, because it can't be used in field declarations on a class. It can't be used in method signatures, either as a parameter type or a return type. It can't be used without an assignment because the type can't be inferred in that case. It can't be assigned a non-literal, again because a type can't be inferred in that case. Are you still confused about the difference between runtime and compile time typing? You can think of the compile time type as the declared type. This type is declared either as a variable reference or a method return type or a method parameter, for example. In the case of LVTI, we don't declare a type for the compiled reference type. It gets inferred, but the bytecode is the same as if we had declared it. In many cases, the compile time type is the declared type to the left of the assignment operator. What is returned on the right side of the assignment operator from whatever expression or method is executed sometimes can only be determined at runtime when the code is executing conditionally through the statements in the code. You can assign a runtime instance to a different compile time type only if certain rules are followed. In this course, up to now, we've looked at only one rule that applies, and that's the inheritance rule. We can assign an instance to a variable of the same type, or a parent type, or a parent's parent type, including java.lang.object, the ultimate base class. Why are runtime types different than compile time types? Because of polymorphism. Polymorphism lets us write code once in a more generic fashion, like the code we started this lecture with. We saw that those 2 lines of code, using a single compile time type of movie, actually supported 4 different runtime types. Each type was able to execute behavior unique to the class. Okay, I hope that helped clear up some of the questions you might have had. We're going to end this video here, and in the next video, we'll talk about different ways to test what the type of a runtime object really is. I'll see you in that next video. In the last video, we discussed the differences between the runtime type and the compile time type. We've said that you can always assign an expression to a type without casting if you're always assigning it to a parent class or a base class type. In this video, we're going to show you how to test what the runtime type of an object really is. And how do we test what the runtime type of a variable really is at runtime if the declared type is something else? We can test to see what type the actual object is at runtime in several different ways. First, we can use an if statement to see what the class name of the object coming back from that method is when this code is running. Getting back to the main method on the next main class, we'll add another call to the movie.getMovie method. We'll assign that to an object reference called unknownObject. Object, unknownObject equals movie.getMovie, opening parentheses, double quotes, C, comma, double quotes, airplane, closing parentheses, semicolon. If opening parentheses, unknownObject.getClass, opening and closing parentheses, .getSimpleName, opening and closing parentheses, equals, double quotes, comedy, closing parentheses, opening curly brace. Comedy, C equals, opening parentheses, comedy, closing parentheses, unknownObject, semicolon. C.watch comedy, opening and closing parentheses, semicolon. Closing curly brace. Here, in this if statement, we're using a method called getClass. We've used this getClass method before in the movie classes watchMovie method. But in that case, we used it with the keyword this, whereas here, we're simply calling it on the local variable reference unknownObject. This method is available to any instance because it's a method on object. The getSimpleName is a method that returns the class name of our instance here. This means we're testing if the object coming back from that factory method has a class name that's comedy. And if it does, we can cast the object to comedy and assign it to a comedy variable. Then we can call any method on comedy. The reason to cast to a comedy class here is we want to execute the method that's specific to comedy, watch comedy. Without casting to a comedy class, we couldn't execute that method. And you'll remember that we didn't have to cast airplane to comedy class on line 15 to run watchMovie, and what I mean is running the comedy class's own version of watchMovie. This is because of polymorphism, which works in this case through the use of overridden methods. Without polymorphism, you'd be in this world of having to test at runtime what your object really is every time to execute code. This code shows you one way to test for the runtime type, but it's not the best way. Let's look at another way, testing if the object coming back might be an adventure type. We'll insert a couple of statements before that last closing bracket for the if statement. Closing curly brace, else, if opening parentheses, unknownObject, instance of adventure, closing parentheses, opening curly brace. Opening parentheses, adventure, closing parentheses, unknownObject, closing parentheses, .watch adventure, opening and closing parentheses, semicolon. Closing curly brace. Okay, again, here's something new, and this is the instance of operator. The instance of operator lets you test the type of an object or instance. The reference variable you are testing is the left operand. The type you are testing for is the right operand. It's important to see that adventure is not in quotes, meaning we're not testing the type name, but the actual type. This operator returns true if unknownObject is an instance of adventure. In our code here, we're testing if unknownObject is really an adventure object, and then if it is, if that's true, we want to cast unknownObject to adventure and call watchAdventure, a method that's only on the adventure class. And this next statement is different from anything I've shown you before, but perfectly valid. This setup outer parentheses is the result of the cast to the adventure type, and we can chain a method directly on that as we do here. In other words, we don't have to assign the result of the cast to a local variable. Okay, now lastly, let's look at one more way to do this. Closing curly brace, else, if opening parentheses, unknownObject, instance of science fiction, sci-fi, closing parentheses, opening curly brace. Sci-fi.watch science fiction, opening and closing parentheses, semicolon. Here, we can see we're using a slightly different version of the instance of operator that became officially part of Java in JDK 16. This is called pattern matching support for the instance of operator. If the JVM can identify that the object matches the type, it can extract data from the object without casting. For this operator, the object can be assigned to a binding variable, which here is called sci-fi. From our example, the variable sci-fi, if the instance of method returns true, is already typed as a science fiction variable. You can see in our code, we don't have to create the variable in the block statement, and we don't have to cast it. Let's run this code through a couple of tests. First, we'll run this code as is. We're interested in the last statement of the output. And you can see with C as the type and airplane as the title, we get the output watching a comedy. Next, we'll change that line there to be an adventure movie and Jaws as the title. And that gives us the last output statement watching an adventure. Now, let's test the science fiction movie, making the type an S and the title Star Wars. And that gives us the output watching a science fiction thriller. Okay, those are a few ways to test the runtime type of an object in our code. You can see that this newest feature in Java makes the job a lot easier. There are a few additional nuances to this particular feature, which we'll have plenty of time to explore in the code ahead. Let's end this video here, and in the next video, I'm going to give you a polymorphism challenge.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome to the polymorphism challenge video. We've said several times that polymorphism really just means many forms. What we want to do in this challenge is have our runtime code execute different behavior for different objects. Let's talk about what I want you to do in this challenge. This diagram shows a base class, car, with one field, description, and three methods, start engine, drive, and run engine. The first two methods should be declared as public. The method run engine, however, is protected and it will only get called from the drive method in car. And here, we've given you three types of subclasses or three types of cars that you might find on the road. We have the gas-powered car, the electric car, and the hybrid car. You can imagine that these three subclasses might have different ways to start their engine or drive depending on their engine type. And each of these classes might have different variables or fields that might be used in those methods. We show you a few of the fields here, but you should try to be creative in your own design. Maybe you might be interested in the top speed of the cars or how fast they can accelerate or some other way you want to compare these cars' performances. It's your job to create this class structure in Java and override some or maybe all of these methods appropriately. And you'll write code in a main class and main method that creates an instance of each of these classes and that executes different behavior for each instance. At least one method should print the type of the runtime object. Okay, so go ahead and try to build that, and when you're ready, come back and we'll go through my solution together. Pause the video now. We're going to start with a new project called Polymorphism Challenge, and we'll have the main class with the main method. But before we do anything in the main method, let's work on our base class and the subclasses. I'll expand the project panel, right-click on the SRC folder, New, Java Class, then Car. And we want a field description, which will be the full description of the car instead of creating it in parts like make, model, year, and color. This will just be simpler for our purposes. And we want that to be private. Private, string, description, semicolon. And now we'll generate the constructor by placing our cursor below this field, select code, generate constructor, and select description. And that gives us our constructor. And now we'll add our three methods real quick. First, the start engine method, public void start engine, opening and closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, car, dash greater than, start engine, closing parentheses, semicolon, closing curly brace. And now let's add run engine. This time, we'll make the access modifier protected. This means our subclasses can override it, but any other classes not sharing the same package, can't. Don't worry, we'll be diving into packages in just a few lectures. Protected, void, run engine, opening and closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, car, dash greater than, run engine, closing parentheses, semicolon, closing curly brace. And lastly, we'll add the driving method. Public, void, drive, opening and closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, car, dash greater than, driving, comma, type is, plus, get class, opening and closing parentheses, dot get simple name, opening and closing parentheses, semicolon. Run engine, opening and closing parentheses, semicolon. Closing curly brace. In this method, we're going to print out the runtime type. Now, here you can see we didn't have to include this .get class, that this keyword is implied, meaning we don't have to specify it. This statement here calls the method on the currently executing instance, even without the use of the this keyword. Okay, that's the base car. And now let's go to the main class and create a method which will take a car parameter. Let's call it runRace, and it will execute two methods on the car class, start engine and drive. Public, static, void, runRace, opening parentheses, car, closing parentheses, opening curly brace. Car.startEngine, opening and closing parentheses, semicolon. Car.drive, opening and closing parentheses, semicolon. Closing curly brace. Now, let's create an instance of the base car in the main class's main method and test this out. Car equals new, car, opening parentheses, double quotes, 2022 blue Ferrari 296 GTS, closing parentheses, semicolon. Run race, opening parentheses, car, closing parentheses, semicolon. And running this code, we see the output. And this is telling us that the methods on car were called first start engine, then driving. And the current instance type is just car because we did use new car to create an instance of car. And the driving method in turn called the run engine method. Okay, that's the base class or the generic car class. Now, we want to extend that and create three subclasses. We'll start with gas-powered car and we'll create this class in the car.java source file. Placing the cursor after the closing bracket for the car class, we'll add this class with its two fields manually. Class, gas-powered car, extends, car, opening curly brace. Private, double, average kilometers per litre, semicolon. Private, int, cylinders equals 6, semicolon. Closing curly brace. And now let's generate some constructors. Placing the cursor after those fields, we can use shortcut keys, in my case for Windows, that's Alt Insert, then select Constructor, and for the first one, we'll hit the button, Select None. That gives us a constructor that's the same as the car classes and calls that one with the call to super as the first statement. And let's add an additional constructor. Again, positioning the cursor below that first constructor and using the shortcut keys, Alt Insert for Windows, then Constructor. And this time I'll pick both fields. And now we can pass the number of cylinders and the average kilometers per litre for a gas or petrol-powered car. Now let's go to the main class and main method and create an instance of this kind of car and execute the runRace method on it. Car, Ferrari, equals new, gas-powered car, opening parentheses, double quotes, 2022 blue Ferrari 296 GTS, comma. 15.4, 6, closing parentheses, semicolon. Run race, opening parentheses, Ferrari, closing parentheses, semicolon. This time, we're still declaring the type of the variable which we're calling Ferrari as a car. We could have made a gas-powered car and that would have worked the same. And we're using the constructor on gas-powered car that takes a description, the average kilometers per litre and the number of cylinders. And if we run that, we actually get the same output as we did when we created a new car, except now the runtime type in the driving method is a gas-powered car. This output is telling us that cars methods were executed, but even though cars methods were called, the actual runtime type is gas-powered car. And cars methods were executed because we didn't override any of those methods yet. Going back to the gas-powered car, we'll override some methods. Positioning the cursor before the closing bracket of this class, we can use shortcut keys to override methods too, and for Windows this is Ctrl-O. This brings up the override methods window. And we'll pick just two of the methods to override. Which would you pick? Well, I'm going to pick Start Engine and Run Engine. I'll explain why I decided not to override the driving method in just a little bit. The default option that IntelliJ gives us there is super.startEngine, and that's a way to call the super functions. In some cases, we may want to do that. We might want to include the processing that's in that base class here for Start Engine, but then we want to provide functionality over and above that. But in this case, we're going to replace each of these calls with some different behavior. For a gas-powered engine, when we start an engine, we might fire up the cylinders in the engine or something like that. System.out.printf, opening parentheses, double quotes, gas, dash greater than, all %d cylinders are fired up, comma, ready, %n, comma, cylinders, closing parentheses, semicolon. And when we run the engine, we might want to report back how well the engine is running compared to the average. System.out.printf, opening parentheses, double quotes, gas, dash greater than, usage exceeds the average, colon, %.2f, %n, comma, average kilometers per litre, closing parentheses, semicolon. Okay, let's see what happens now if we execute the code in the main class. We see that Start Engine on the gas-powered car is executed because it tells us that all 6 cylinders are fired up. But then we still run the driving method on the car class because we never did override that method. Our runtime type is a gas-powered car, and we know the driving method calls the run engine method. What's really cool, which you can see on this next line, is the gas-powered car's run engine method. This happened even though the method that called it, drive, wasn't overridden on gas-powered car. The polymorphism doesn't just happen on methods we call directly. It also happens on methods we call indirectly. This means that in essence, you can implement different behavior on just portions of a car's behavior. We'll be looking at this more when we start talking about other modifiers we can use on class members. But for now, this is a good stopping place, and we'll end this part of the challenge here. In the next video, we'll finish the challenge by implementing our other subclasses and then giving them all a test ride. I'll see you in that next video. We show you the challenge slide again here. In the last video, we built the car and the gas-powered car classes. And we overrode the Start Engine and Run Engine methods on gas-powered car, but we didn't override the drive method. Let's continue with this challenge. We're working in the project called Polymorphism Challenge. And what we want to do next is create the other two subclasses, electric car and hybrid car. Let's close the gas-powered car node because we want to copy this node, which really copies the whole class, and then paste that node below it. Highlight the duplicated class node and then select, edit, find, replace. Ctrl-R on Windows is the shortcut for this replace feature. Now, when we have everything highlighted, we'll change all references of gas-powered car to electric car in the highlighted code, then hit the Replace All button. And that replaces all the references to gas-powered car to electric car. Let's make a couple of changes to the electric car class. We'll change the average kilometers per litre to average kilometers per charge. We can next highlight that field, select refactor, then rename, and change litre to charge. And select to change the parameter name as well there. And we'll go through the same process for cylinders. Highlight it, refactor, rename, then change it to battery size. And again, we'll check to change the parameter name in the constructor. Finally, we want to change the way the Start Engine and Run Engine methods work. We'll call this BEV for short in these statements, which stands for Battery Electric Vehicle. System.out.printf, opening parentheses, double quotes, BEV, dash greater than, switch %d kilowatt hour battery on, comma, ready exclamation mark %n, comma, battery size, closing parentheses, semicolon. System.out.printf, opening parentheses, double quotes, BEV, dash greater than, usage under the average, colon, %.2f, %n, comma, average kilometres per charge, closing parentheses, semicolon. And let's repeat that process once again, but for the hybrid car. First, we'll close the electric car node and paste the gas-powered car again. And highlighting that last pasted gas-powered class, which should still be a closed node. And we'll use the replace functionality to change gas-powered car to hybrid car and select the replace all button. Okay, there's our third subclass. The fields are the same for a hybrid car as a gas-powered car, which actually is what we want, but we also need an electric vehicle battery size, so let's add it. Private int battery size, semicolon. And we'll add it to the constructor code. We'll do this manually and just include it as a parameter to the constructor first. Int battery size. This dot battery size equals battery size, semicolon. And now let's change the over-in methods for the hybrid car. First, we'll edit the start engine method, and for a hybrid, we need to fire up cylinders and switch the battery power on. System.out.printf, opening parentheses, double quotes, hybrid, dash greater than, %d cylinders are fired up %n, comma, cylinders, closing parentheses, semicolon. System.out.printf, opening parentheses, double quotes, hybrid, dash greater than, switch %d kilowatt hour battery on, comma, ready exclamation mark %n, comma, battery size, closing parentheses, semicolon. And next, we'll edit the run engine method, and we're just going to have it run basically the same way as a gas-powered car. System.out.printf, opening parentheses, double quotes, hybrid, dash greater than, usage below average, colon, %.2f, %n, comma, average kilometres per litre, closing parentheses, semicolon. You might want to write more code here with something using battery if the battery is greater than 10% or something. And you might want to include fields for that and so on. But to keep this simple, we'll just have it run like a gas car for now and just print the hybrid keyword. Now, we want to go back to the main method and create some of these instances. First, we'll create an instance of an electric car and we'll make it a 2022 Tesla Model 3 and say that it can go 568 kilometres on a battery that has a size of 75 kilowatt hours. Car, Tesla, equals new, electric car, opening parentheses, double quotes, 2022 red Tesla Model 3, comma. 568, comma, 75, closing parentheses, semicolon. Run race, opening parentheses, Tesla, closing parentheses, semicolon. And if we run this code, we can see the output for these statements. And the output is telling us that the methods we overrode for the electric car were the ones that got executed. This means the behaviour for the electric car, the battery electric vehicle, BEV, is different than the gas-powered car or a generic car. That's what we wanted, so that's good. Lastly, let's test out the hybrid car. We'll set up a Ferrari SF90 Straydale, which has 8 cylinders and a much smaller battery than an electric car, and in this case, it's 8 kilowatt hours. Car, Ferrari hybrid, equals new, hybrid car, opening parentheses, double quotes, 2022 black Ferrari SF90 Straydale, comma. 16, comma, 8, comma, 8, closing parentheses, semicolon. Run race, opening parentheses, Ferrari hybrid, closing parentheses, semicolon. Remember, this constructor takes the description, the average kilometres per litre, which is about 16, the number of cylinders, which is 8, and finally the battery, so 8 for that too. And again, if we run that, we now see that the last car is a hybrid car. There are 2 steps to starting up, 8 cylinders are fired up, and the 8 kilowatt hours battery is switched on. And that was the challenge. In this example, we created a polymorphic method on the main class. This method only knew about the car class and not about any of its subclasses. and it could be executed for many different types as we showed. Now, maybe you went the extra mile and created a factory object like we showed you in a previous video, which made the code in the main method much cleaner. That would have been another good approach here. I hope you were able to implement something similar that used the car class as the declared compile time type. And this demonstrated that, at runtime, it executed different behavior on different objects, all of which could be called a car in a way. And hopefully you were able to code that and maybe you had a little fun with it and customize the behavior for each car type in some way. Okay, that's the polymorphism challenge, and that's actually the end of the object-oriented programming section. We've covered many of the object-oriented features, which included encapsulation, polymorphism, and composition in this section. In the next video, I'm going to give you a bigger challenge than usual to go over all the object-oriented features we've discussed and put them all into practice in one application. Let's move on, and I'll see you in that next video. Congratulations, you've made it to the Object-Oriented Programming Master Challenge. In this challenge, we're going to build a complete application using all the principles of object-oriented programming we've covered in the last two sections of this course. Bill runs a fast food hamburger restaurant and sells hamburger meals. His meal orders are composed of 3 items: the hamburger, the drink, and the side item. Your application lets Bill select the type of burgers and some of the additional items or extras that can be added to the burgers, as well as the actual pricing. You need a meal order. This should be composed of exactly 1 burger, 1 drink, and 1 side item. The most common meal order should be created without any arguments, like a regular burger, a small Coke, and fries, for example. You should be able to create other meal orders by specifying different burgers, drinks, and side items. You need a drink and side item. The drink should have at least a type, size, and price, and the price of the drink should change for each size. The side item needs at least a type and price. You need burgers. Every hamburger should have a burger type, a base price, and up to a maximum of 3 extra toppings. The constructor should include only the burger type and price. Extra toppings on a burger need to be added somehow and priced according to their type. The deluxe burger bonus. Create a deluxe burger meal with a deluxe burger that has a set price so that any additional toppings do not change the price. The deluxe burger should have room for an additional 2 toppings. Your main method should have code to do the following. Create a default meal that uses the no-arguments constructor. Create a meal with a burger and the drink and side item of your choice with up to 3 extra toppings. Create a meal with a deluxe burger where all items, drink, side item, and toppings up to 5 extra toppings are included in the burger price. For each meal order, you want to perform these functions. Add some additional toppings to the burger. Change the size of the drink. Print the itemized list. This should include the price of the burger, any extra toppings, the drink price based on size, and the side item price. Print the total due amount for the meal. That's the challenge. I hope that makes sense. It's a little bit bigger than the ones we've done before. You probably want to spend a bit of time working out your design on a piece of paper or certainly thinking about it. You want to do some work up front and decide how you want to build this application using some combination of composition, inheritance, encapsulation, and polymorphism techniques. Make sure you give this your best attempt and really try to have fun with it. Even partially completing this challenge will definitely make you a better programmer. Before you start the challenge, I just want to make it clear that it's very important that you've actually gone through the object-oriented programming section of this course. If you've skipped any videos, or if you don't understand the concepts of object-oriented programming, you might struggle with this challenge. The other thing to keep in mind is that there's lots of different ways of solving this challenge. I've purposely decided not to give you every parameter name, method name, and I'm not telling you how to design your classes or relationships. Bottom line is, this is a challenge that's meant to test you and to really make you think. So go away and see what you can do to figure this out and create your application. And when you're ready to go, come back here and you can actually have a look and come up and see what my solution was. Pause the video now. Okay, how did you get on? Did you figure out a solution? So here is the diagram of my design. This diagram doesn't include the deluxe burger class. We'll look at that a bit later. The meal order class uses composition in this design. It's composed of a burger as well as drink and side, which will just be items. These are all really items, although I specialise the burger class. I've used inheritance for the item and burger relationships, which means burger is an item. Every item has a name, type, price or base price, and a size. Item has the method getBasePrice, which is really just a getter method for the price, but the name is more descriptive. Item also has getAdjustedPrice and the printItem method. These methods will exhibit different behaviour based on the runtime type, and we know that's polymorphism. For the burger, the toppings or extras are individual attributes and also have the type item. We're going to use the meal order class to hide some of the implementation details from the calling code. This means we're going to use encapsulation techniques on meal order and item. The meal order class has additional methods that will delegate work to some of its parts, meaning the calling code won't interact directly with any of the parts. Now, it's probably very unlikely any two developers would come up with the same design. This is just one way to do this, one way of many. Okay, let's get started. I've already created a project called Bill's Burger Challenge and created the main class and main method. But we're going to start with the base class for most of our classes, the item, so let's create that class, right-click on SRC, New, Java class, and calling it item. All of the items fields. Private, string, type, semicolon. Private, string, name, semicolon. Private, double, price, semicolon. Private, string, size equals, double quotes, medium, semicolon. Here we have type. This will be burger, drink, side, or topping, for example, name, and price, and that price will be the base price. Then we've also got size here, and we've said it has the type of string, and for this, we're going to set it to medium. Now that we have the fields, we can add a constructor. Placing the cursor below the fields, and I'll pick all the fields except size. And I want to just change the constructor to make both the type and name of the item uppercase. Now I could add validation here as well, but for simplicity's sake, I'll leave that out, but you might want to check if the type is a valid type, for example, or whatever kind of validation makes sense. And we'll also add getters for the name and price fields. Placing the cursor below the constructor, I'll generate getters for name and price. And just for more clarity, I want the name of that getter, getPrice, to actually be getBasePrice. And let's change the code in getName to include the size of the item. If opening parentheses, type.equals, opening parentheses, double quotes, side, closing parentheses, logical, or operator, type.equals, opening parentheses, double quotes, drink, close both parentheses, opening curly brace. Return size plus, double quotes, plus name, semicolon, closing curly brace. In this code, we're saying if the type is a side or drink, and remember we made the type uppercase in the constructor, we'll also print out the size, which we're expecting to be small, medium, or large. Next, we need a method to get the adjusted price of an item. And because we aren't subclassing the item class, except for burgers, I want to customize what happens for the other types in this method. Public, double, getAdjustedPrice, opening and closing parentheses, opening curly brace. Return, switch, opening parentheses, size, closing parentheses, opening curly brace. Case, double quotes, small, return type, getBasePrice, opening and closing parentheses, minus 0.5, semicolon. Case, double quotes, large, return type, getBasePrice, opening and closing parentheses, plus 1, semicolon. Default, return type, getBasePrice, opening and closing parentheses, semicolon. Closing curly brace, semicolon. Closing curly brace. This code adjusts pricing for drinks and sides. We'll make both the sides and drinks have the same price adjustments for simplicity. Okay, so if something is small, we'll subtract $0.50 from it, but if it's large, we'll add $1. And one other thing we want is a setter for the size attribute. We want Bob's employees to be able to adjust the size of a drink on a meal. Setting the cursor before the closing class bracket or insert is the key combination for Windows, and we'll pick size, and that gives a way to set size on any item. And finally, let's create a method to print the item name and the item's price, meaning the adjusted price. I want everything to be printed out, all the items, the burger, its toppings, and the subtotals and totals to be printed out in a uniform way. First, I'm going to create a static method on this class and use a format string so that any code can call this method, passing a label and price, and it'll get formatted the same. Public static void print item opening parentheses string name comma double price closing parentheses opening curly brace. System.out.printf opening parentheses double quotes %20s colon %6.2f%n comma name comma price closing parentheses semicolon closing curly brace. Okay, what's this code going to do? We're using the system.out.printf statement, and we're formatting a string literal that may look a bit different than any you've seen before. This string has two specifiers, but here we're including some optional features with the specifiers. The %s is for a string, meaning it will get replaced by a string variable, but we can specify how wide we want the string to be by putting a number between the % and the s. Here, we're reserving 20 characters for the first argument, and we'll just pass the name to that. And the second specifier is %f for a floating point number, but again, we've inserted some options between the % and the f. In this case, we're saying we want 6 characters up to the decimal point, which includes spaces and numbers, and we want a precision of 2, meaning we want 2 decimal places. So this method can be called from anywhere. But next we'll create an instance method with the same name, but no arguments on the item class, and this will just call the static method. Public void print item opening and closing parentheses opening curly brace. Print item opening parentheses get name opening and closing parentheses comma get adjusted price opening and closing parentheses semicolon closing curly brace. And we're going to pass the results of the getName method and the getAdjustedPrice method as the arguments to be printed. These are the methods that will get overridden for any subclasses. And we can test this in the main method. Item Coke equals new item opening parentheses double quotes drink comma double quotes Coke comma 1.50 closing parentheses semicolon. Coke.printitem opening and closing parentheses semicolon. Coke.setSize opening parentheses double quotes large closing parentheses semicolon. Coke.printitem opening and closing parentheses semicolon. And this creates a drink that's a Coke with a base price of $1.50. This is the price of the medium drink, the way we have it coded. We print that, but next we set the size of the drink to large, and then we print that. And if we run that, we see a medium Coke printed for $1.50 and a large Coke for $2.50. You can see those got printed out, aligned nicely because of the format string we used. And we can see the price adjusted accordingly. And let's test out a topping, say an avocado topping. Item avocado equals new item opening parentheses double quotes topping comma double quotes avocado comma 1.50 closing parentheses semicolon. Avocado.printitem opening and closing parentheses semicolon. And running that, we can see the third line item avocado, and that's lined up like the other items. Okay, that's the item class. In the next video, we'll create the burger class, the meal order class, and then specialize the burger. I'll see you in that next video. Okay, in the last video, I showed you my design, and we started to build it by building the item class first. And we said that a drink and a side dish are both types of items, as well as extra toppings for the burger. In this video, we want to pick up where we left off. we'll want to build out the burger class, which we are saying extends the item class. Let's actually expand the project panel and create a new public class called burger. We'll have this class extend item so it can inherit name and price, and we'll add the 3 additional fields we have for the burger, which we'll call extra 1, extra 2, and extra 3, which will have a type of item. Private item, extra 1, semicolon. Private item, extra 2, semicolon. Private item, extra 3, semicolon. Now, in the next section, we'll learn more about things called containers, which are a way to group the same kind of items together. So instead of having 3 attributes like this, we could have a container of extra toppings, but first let's see how to do it without those structures. Okay, so those are the burger attributes. And again, this doesn't compile because we need a constructor. Let's generate a constructor. We don't want to include the extras in the constructor, so I'll use the select none button, which will still add code to initialize the superclass. Instead of include extras in the constructor, we'll include a method to add toppings, because if you think about it, these are probably going to be something specific for each customer. Firstly though, I want to change the constructor to remove type as a parameter and instead pass the type burger to the super call. Now let's override a few methods from the item class. I'll move the cursor outside of the constructor code first. And we'll do Ctrl O and select get name and the get adjusted price methods. For burger, let's change the get name method and just include the word burger in there because the type for the burger will be something like regular or deluxe, for example. And then we'll also change the get adjusted price method. We need the price to include the toppings, and we'll start by adjusting it for 1 additional topping first. Return get base price, opening and closing parentheses, plus. Opening parentheses, extra 1 equals null, closing parentheses, question mark, 0, colon, extra 1 dot get adjusted price, opening and closing parentheses, plus. Opening parentheses, extra 2 equals null, closing parentheses, question mark, 0, colon, extra 2 dot get adjusted price, opening and closing parentheses, plus. Opening parentheses, extra 3 equals null, closing parentheses, question mark, 0, colon, extra 3 dot get adjusted price, opening and closing parentheses, semicolon. Okay, so hopefully you're getting really comfortable with the ternary operator by now. And we're using it here in each case to determine if the extra topping is null. If it is, we just return 0, but otherwise we'll have the get adjusted price for each extra item. And this gets added to the burger base price, so each extra topping will get added if it has a price. We don't really have a way to test this right now because we don't have any way to add toppings. Let's add a method to add toppings next. Now we're going to let a string be passed to this method and the code will create the right kind of item. But I'm also going to include a method to determine the price based on the name of topping that's passed, so this method will be called getExtraPrice. Public double getExtraPrice, opening parentheses, string, topping name, closing parentheses, opening curly brace. Return, switch, opening parentheses, topping name dot to uppercase, opening and closing parentheses, opening curly brace. Case, double quotes, avocado, comma, double quotes, cheese, return type, 1.0, semicolon. Case, double quotes, bacon, comma, double quotes, ham, comma, double quotes, salami, return type, 1.5, semicolon. Default, return type, 0.0, semicolon. Closing curly brace, semicolon. Closing curly brace. Here, we're making avocado and cheese be an extra $1 and these 3 meat types be an extra $1.50. Everything else will have no additional price. Next, we'll write the add toppings method and we'll pass the 3 individual string variables as individual parameters, and we'll set up the extra fields by creating a new item for each string passed. Public void add toppings, opening parentheses, string, extra 1, comma, string, extra 2, comma, string, extra 3, closing parentheses, opening curly brace. This dot extra 1 equals new item, opening parentheses, double quotes, topping, comma, extra 1, comma. We get extra price, opening parentheses, extra 1, close both parentheses, semicolon. This dot extra 2 equals new item, opening parentheses, double quotes, topping, comma, extra 2, comma. We get extra price, opening parentheses, extra 2, close both parentheses, semicolon. This dot extra 3 equals new item, opening parentheses, double quotes, topping, comma, extra 3, comma. We get extra price, opening parentheses, extra 3, close both parentheses, semicolon. Closing curly brace. Okay, so let's see if we can create a burger now, add some toppings, and print its price. First, we'll comment out the other lines in the main method so we can focus on the burger output. Burger equals new burger, opening parentheses, double quotes, regular, comma, 4.00, closing parentheses, semicolon. Burger.add toppings, opening parentheses, double quotes, bacon, comma, double quotes, cheese, comma, double quotes, mayo, closing parentheses, semicolon. Burger.print item, opening and closing parentheses, semicolon. And if we run that, we can see the output, regular burger, $6.50. We started out with a regular burger and we priced that at $4. But then we added 3 toppings, bacon, which was an item that we said had the price of $1.50, and cheese was $1. Our toppings were a total of $2.50, and add that to the base price, we get $6.50. Okay, so we're halfway there. Let's add a method to burger that itemizes the extra toppings. Public void print itemized list, opening and closing parentheses, opening curly brace. Print item, opening parentheses, double quotes, base burger, comma, get base price, opening and closing parentheses, semicolon. If opening parentheses, extra 1, not equals null, closing parentheses, opening curly brace. Extra 1.print item, opening and closing parentheses, semicolon. Closing curly brace. Closing curly brace. Here, we first print out the base price of the burger. And then if extra 1 isn't null, we'll print that out, and remember, extra 1 is just an item, so we can call print item on that. Then we'll copy and paste that and change extra 1 to extra 2 in both those cases. And we'll paste that again and change extra 1 to extra 3 this time. We could do this with an else statement, but there could be a chance, if our code wasn't perfectly encapsulated, that extra 2 might get populated and not extra 3. So we'll just do this to stay on the safe side. Let's add this to the burger print item method now, so that anytime we print a burger, we get an itemized list. After that method, we'll do Ctrl-O and then select the print item method. And now we'll just insert the call to print itemized list method first, so the items are printed first. Print itemized list, opening and closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, minus dot repeat, opening parentheses, 30, close both parentheses, semicolon. Here, we're also just including a dashed line using the string repeat method we've used before, which prints out 30 dashes here. And now we can just rerun our code. And we get the toppings itemized for the burger. So that's looking pretty good. It's time to build the meal using the composition part of this challenge. And we've said we're going to do this in the meal order class. Let's create that class. Now I could have made this extend item, but I chose not to. Maybe your design has it extending a base class, and that's a good design too. Now we can add our 3 fields. We'll have burger, which is a burger type, and drink and cider item types. Private, burger, semicolon. Private item, drink, semicolon. Private item, side, semicolon. And now let's add the constructor. We'll enter this one in manually because we don't want the calling code to pass objects, just strings describing what the items in the meal are. And we've said we just want a burger type, which will just be regular or deluxe. For example, a drink type, so Pepsi or Coke maybe, and a side type, which might be fries or potato salad. Public meal order, opening parentheses, string, burger type, comma, string, drink type, comma, string, side type, closing parentheses, opening curly brace. This dot burger equals new burger, opening parentheses, burger type, comma, 4.0, closing parentheses, semicolon. This dot drink equals new item, opening parentheses, double quotes, drink, comma, drink type, comma, 1.00, closing parentheses, semicolon. This dot side equals new item, opening parentheses, double quotes, side, comma, side type, comma, 1.50, closing parentheses, semicolon. Closing curly brace. So what we're doing here is constructing the meal, the parts within this constructor. We create a burger instance and a drink and side, both item instances. Now, you could have created your constructor to accept the different parts, meaning your parameters could have been a burger or item. But I'm doing this so the calling code doesn't have to know about anything except the meal order itself. I'm encapsulating the details of the meal inside this class, and they can configure it with a few simple string literals. And let's create another constructor that has no arguments. I'll just type this above the other constructor. Public meal order, opening and closing parentheses, opening curly brace. This opening parentheses, double quotes, regular, comma, double quotes, Coke, comma, double quotes, fries, closing parentheses, semicolon. Closing curly brace. With this constructor, the calling code can quickly set up a default meal with a regular burger, medium fries and medium Coke. Before we try that out, let's write a method that gets the total price of the full meal. Public double get total price, opening and closing parentheses, opening curly brace. Return side.getAdjustedPrice, opening and closing parentheses, plus drink.getAdjustedPrice, opening and closing parentheses, plus burger.getAdjustedPrice, opening and closing parentheses, semicolon. Closing curly brace. So here, we're just adding the adjusted prices of the side item, the drink and the burger, and returning that. But we don't have a way to print anything, so let's add a print itemized list method to meal order. Public void print itemized list, opening and closing parentheses, opening curly brace. Burger.printitem, opening and closing parentheses, semicolon. Drink.printitem, opening and closing parentheses, semicolon. Side.printitem, opening and closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, minus.repeat, opening parentheses, 30, close both parentheses, semicolon. Item.printitem, opening parentheses, double quotes, total price, comma, get total price, opening and closing parentheses, semicolon. Closing curly brace. And because everything's really an item, we can call the print item method on all the parts of the meal. And we can also use that static method on item to include a total price after we print another 30 dashes to separate the total from the itemized list. So we're ready to create a meal now with this class. Go back to the main class, main method, let's comment out the last three statements. Then we'll create our first meal, and all we have to do is new meal order without any arguments. Meal order, regular meal, equals new meal order, opening and closing parentheses, semicolon. Regular meal.print itemized list, opening and closing parentheses, semicolon. And running that, we can get output that looks more like a bill. So we see the regular burger there, that's the burger name, and that's $4. And we itemize the burger above that, but right now, this burger has no toppings, so we just see the base prices. And the medium Coke is $1 and medium fries are $1.50. But we haven't provided ways for the calling code to customize the meal order. We want to let them add toppings and change the drink size. Let's write a method on meal order that lets us add up to 3 toppings. And this really is just a pass-through to the add toppings method on burger. This will be expanded when we add new burger types. Public void add burger toppings, opening parentheses, string, extra 1, comma, string, extra 2, comma, string, extra 3, closing parentheses, opening curly brace. Burger.add toppings, opening parentheses, extra 1, comma, extra 2, comma, extra 3, closing parentheses, semicolon, closing curly brace. And let's add a set drink size on the meal order class. Public void set drink size, opening parentheses, string, size, closing parentheses, opening curly brace. Drink.setSize, opening parentheses, size, closing parentheses, semicolon, closing curly brace. Okay, so now we should be able to add some toppings and change the drink size, so let's do that in the main method of the main class. Regular meal.add burger toppings, opening parentheses, double quotes, bacon, comma, double quotes, cheese, comma, double quotes, mayo, closing parentheses, semicolon. Regular meal.set drink size, opening parentheses, double quotes, large, closing parentheses, semicolon. And let's run that. And now you can see a pretty well formatted bill that includes all the toppings and some have additional costs. Here we start with a regular $4 burger, then add some bacon for $1.50 and cheese for $1 and mayo was no cost. So the total cost of the burger is shown here and that's $6.50. Now we can see the additional extra toppings, bacon, cheese and mayo that added another $2.50 to the price. Okay, so that's pretty good. Let's test out a second meal, this time using the constructor with 3 arguments. First, we'll comment out the first meal code. Meal order, second meal, equals new meal order, opening parentheses, double quotes, turkey, comma, double quotes, 7-Up, comma, double quotes, chili, closing parentheses, semicolon. Second meal.add burger toppings, opening parentheses, double quotes, lettuce, comma, double quotes, cheese, comma, double quotes, mayo, closing parentheses, semicolon. Second meal.set drink size, opening parentheses, double quotes, small, closing parentheses, semicolon. Second meal.print itemized list, opening and closing parentheses, semicolon. And running this code, we get a turkey burger with a small 7-Up and a medium order of chili. So how did you do? Were you able to create a burger meal that included a hamburger with toppings, a side item and a drink? Did you use composition, inheritance, encapsulation and polymorphism? I hope you enjoyed that. And maybe you took up the bonus challenge to include a different kind of burger with a couple of extra toppings but a single fixed price for the meal. We'll solve the bonus challenge in the next video, so I'll see you in that next video. Hopefully you have the code still up from the Bill's Burger Challenge project. Okay, so in the last video, we created all the classes for a default meal order and provided methods for adding toppings and customizing a drink size. Now, we want to create a burger subclass, the Deluxe Burger, which has 2 additional toppings, so a total of 5. And one other little thing, this burger, when it's part of a meal, has a single set price, meaning the drink, the side item and the toppings have no additional charges. Okay, now let's create this new burger. Opening the project panel, we'll create a class called Deluxe Burger, and we're adding extends burger to this class. And in addition to the 3 extra attributes, we want 2 more for this burger. Item deluxe 1 semicolon. Item deluxe 2 semicolon. Now we need a constructor, so we'll create one below these fields, but we don't want to include the deluxe attributes, so just pick the select none button. And now we have the constructor which just calls the burger constructor, which is all we need. Next, I want to use the IntelliJ override generation feature for 2 methods on burger. These are add toppings and print itemized list. We'll do the usual Control-O and select just those 2 methods, add toppings and print itemized list. But really, I don't want to override add toppings, I want to overload it. I'm going to remove the override annotation and I'm going to add 2 extra parameters for the extra 2 toppings. String extra 4, comma, string extra 5, closing parentheses, opening curly brace. Deluxe 1 equals new item, opening parentheses, double quotes, topping, comma, extra 4, comma, 0, closing parentheses, semicolon. Deluxe 2 equals new item, opening parentheses, double quotes, topping, comma, extra 5, comma, 0, closing parentheses, semicolon. That sets up the last 2 toppings on the deluxe burger, both with a price of 0. Now let's include these in the overridden print itemized list. We want to print out these 2 new items after the original 3 on the burger class. If opening parentheses, deluxe 1 not equals null, closing parentheses, opening curly brace. Deluxe 1.print item, opening and closing parentheses, semicolon, closing curly brace. If opening parentheses, deluxe 2 not equals null, closing parentheses, opening curly brace. Deluxe 2.print item, opening and closing parentheses, semicolon, closing curly brace. Finally, we need a way to override the getExtraPrice method on burger because all toppings on a deluxe burger are included or are 0 priced. Again, before the closing bracket of the class, we'll override getExtraPrice. And then we'll just return 0 for the deluxe burger. And now we're done with the deluxe burger. Now we want to create a meal order with the deluxe burger. And where we want to support this new burger is in the constructor that has parameters on the meal order class. Let's go there and we'll add a conditional check if the burger type is deluxe. Let's do that with equals ignore case, so it doesn't matter what case the user enters. If opening parentheses, burger type dot equals ignore case, opening parentheses, double quotes, deluxe, close both parentheses, opening curly brace. This dot burger equals new deluxe burger, opening parentheses, burger type, comma, 8.5, closing parentheses, semicolon, closing curly brace, else, opening curly brace. Closing curly brace. Okay, so depending on what type is passed as the first argument, we'll create the right kind of burger. If it's deluxe, then we create a deluxe burger, otherwise it's the default burger. Now, we've also said that if it's a deluxe burger meal, we're not going to charge for drinks or side items, so we need to take care of this in 2 methods on meal order. First, the getTotalPrice method needs to exclude the side and the drink if the burger is a deluxe burger. And you'll remember, we can check the type of burger using the instance of operator. If opening parentheses, burger, instance of deluxe burger, closing parentheses, opening curly brace. Return burger.getAdjustedPrice, opening and closing parentheses, semicolon, closing curly brace. Now, if the burger is just a deluxe burger, we won't include the drink or side item. And next, we want to change the way the drink or side is printed in the print itemized list method. We still want them to print, but we want their prices to be excluded, so again we'll use the instance of operator to change what is printed. If opening parentheses, burger, instance of deluxe burger, closing parentheses, opening curly brace. Item.printItem, opening parentheses, drink.getName, opening and closing parentheses, comma, 0, closing parentheses, semicolon. Item.printItem, opening parentheses, side.getName, opening and closing parentheses, comma, 0, closing parentheses, semicolon, closing curly brace, else, opening curly brace, closing curly brace. If it's a deluxe burger, we still want everything printed, but we want the price to be 0, so instead of calling print item from the drink or side instance, we're calling the static method, which the instance method calls, and passing 0 for the price. And before we can test, we need one more method on meal order, and this is to allow a user to define up to 5 toppings. I'm just going to copy the add burger toppings method and paste a copy below it. I'll add 2 parameters, extra 4 and extra 5, and then use the instance of operator again to determine which method should get called based on the burger type. String extra 4, comma, string extra 5, closing parentheses, opening curly brace. If opening parentheses, burger, instance of deluxe burger, db, closing parentheses, opening curly brace. db.add toppings, opening parentheses, extra 1, comma, extra 2, comma, extra 3, comma, extra 4, comma, extra 5, closing parentheses, semicolon, closing curly brace, else, opening curly brace, closing curly brace. In this code, notice that I'm using the instance of operator, but this time I have a binding variable, db. And this lets me call the deluxe burger's overloaded version of add toppings using that binding variable, which is typed to the deluxe burger. So that's pretty neat. I didn't have to cast or set up a local variable. Okay, so let's test this out in the main method by creating a meal order with a deluxe type. In this case, we want to include at least 5 toppings to test our extra fields. And we'll set the drink to small to make sure the price doesn't get adjusted. But first, we'll comment out the second meal so we can focus on the deluxe meal. Meal order, deluxe meal equals new meal order, opening parentheses, double quotes, deluxe, comma, double quotes, 7-up, comma, double quotes, chili, closing parentheses, semicolon. Deluxe meal.add burger toppings, opening parentheses, double quotes, avocado, comma, double quotes, bacon, comma, double quotes, lettuce, comma, double quotes, cheese, comma, double quotes, mayo, closing parentheses, semicolon. Deluxe meal.set drink size, opening parentheses, double quotes, small, closing parentheses, semicolon. Deluxe meal.print itemized list, opening and closing parentheses, semicolon. And running the code, you can see the base burger is $8.50. We've added avocado, bacon, lettuce, cheese, and mayo, and the line item prices for each topping is 0. We also have a drink and a medium chili for side items, and both are included with no additional costs. The total price for the deluxe burger is the same price as the base burger, which is what we wanted. That looks good. Regardless of the toppings or the drink or side, the price did not change. It was $8.50. Okay, so congratulations. We've finished our first whole application. I hope you've got a lot out of these last 3 videos and actually for these last 2 sections of the object-oriented course. Alright, so now that you've seen that solution, I just want to make a point that it's certainly not 100% perfect, but I think it's a good solution by using the knowledge that we've learnt in previous sections. Now in an ideal world, you'd use something like a list or an array, but lists and arrays are explained later in the course. This was designed for you to take this challenge based on the information already shown in the course. You'll want to revisit this challenge later once you've learnt these other things, such as arrays. And armed with that new knowledge, you can look at improving your solution. Now you may also notice that there's some repeated code, but that's actually okay for now. In the next section, we'll use arrays and lists to remove repeated code. Also very importantly, keep in mind that your code can and probably will be different and perhaps vastly different than the solution I've shown there. And that's because in programming, there's almost always many solutions to a particular challenge, and in this case, that's certainly true. I hope you did well with our challenge. Before we complete this section of the course, we're going to talk about packages and import statements. And then in the next section of the course, we're going to be talking about arrays, which I'm sure you're going to find very useful. I'll see you in that next section.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Up until this point in the class, we haven't created a lot of classes, so we haven't had to think much about organizing those classes. As the course progresses, we're going to be using more and more of Java's libraries, and our applications are going to get more complex. This feels like a good time to talk about the package and import statements in more detail. We've talked briefly about import statements when we used the scanner class, and we mentioned packages when we talked about access modifiers. In this video, I want to focus on what a package is, or we'll be switching to using it from this period forward, and how to access classes in different packages. As per the Oracle Java documentation, a package is a namespace that organizes a set of related types. In general, a package corresponds to a folder or directory on the operating system, but this isn't a requirement. When using an IDE, like IntelliJ, we don't have to worry about how packages and classes are stored on the file system. The package structure is hierarchical, meaning you group types in a tree fashion. You can use any legal Java identifier for your package names, but common practice has package names as all lowercase. The period separates the hierarchical level of the package. By now, you're familiar with two of Java's packages, java.lang and java.util. On this slide, we show these two packages with some of the classes we've used to date or will use shortly shown within these packages. You may remember when we used the scanner class or the random class, we were required to use an import statement. We show you an example of using the scanner class in this code. The import statement has to be declared before any class or type declarations, but after any package statement. In this code, we don't have a package statement, so the import statement must be the first statement in the code. There is no limit to the number of import statements you can have. This code shows two import statements, one for the random class and one for the scanner class. Alternately, we could use a wildcard with the asterisk character with the import statement. In the following code, we're telling Java to import all classes from the java.util package with the use of the asterisk after the java.util package reference. Packages let us reuse common class names across different libraries or applications and provide a way to identify the correct class either with an import statement or a qualifying name. For example, you might have a package for utility classes that can provide common functionality for all of your classes to access. Packages let us organize our classes by functionality or relationships. Packages also let us encapsulate our classes from classes in other packages. So you might have a package of tightly coupled classes that should only be accessed by each other, but not by the outside world, as an example. We've seen that Java starts their package names with Java in some of the examples we've looked at. However, it is common practice to use the reverse domain name to start your own package naming conventions. If your company is abccompany.com, for example, your package prefixes would be com.abccompany. For the rest of the course, I'll be using dev.lpa, which is the reverse domain of my Learn Programming Academy development company. The package name hierarchy is separated by periods. The package statement needs to be the first statement in the code, with the exception of comments. The package statement comes before any import statements. There can be only one package statement because a class or type can only be in a single package. In this code, we created a class called main. A class's fully qualified class name, FQCN, consists of the package name and the class name. So this class's fully qualified name is dev.lpa.package_1.main. It's unlikely this class, with its fully qualified name, will have a naming conflict with a main class in another package. As another example, the fully qualified class name of the scanner class in this code is java.util.scanner. You can use the fully qualified class name instead of the import statement as we show you here on this slide. This code does not use the import statement, but instead, where the scanner class is referenced, the fully qualified class name is used. You can imagine this could get tedious if you have to use the type often in your code. Later in the course, we'll talk about using a combination of the import statement and the fully qualified class name to resolve conflicts. In this slide, we're showing two classes from our previous challenge in the unnamed or default package. This is where classes are implicitly placed if we don't specify a package statement. For your applications, you should always specify a package statement and avoid using the default or unnamed package. Although that's all we've been using up until now, it has some disadvantages when you work in a true development environment. The main disadvantage is you can't import types from the default package into other classes outside of the default package. In other words, you can't qualify the name if it's in the default package, and you can't import classes from the default package. Okay, so that's the package and import statement basics. Let's jump into IntelliJ and see how to create some packages there. In IntelliJ, I've created a project called Packages, but haven't done anything else. I have the project panel open. You can create the packages first by right-clicking on the SRC folder, selecting New, then Package. And here, I'm going to type in dep.lpa, which will be the base package I'll be using from now on in the course. And you can see IntelliJ created a folder system with dep.lpa under the SRC folder. If you'd rather see the individual folders, click on the gear Tree Appearance and then uncheck Compact Middle Packages. And now we can create a class under the LPA folder by right-clicking it, New, Java Class, and entering Main. And now you can see that IntelliJ includes a package statement at the start of this new class. You can create your package structure this way and add classes under the relevant packages. An alternate way to do this is to simply include the full package structure in your new class name, but you have to be careful where you're creating the new class. Let's create a new class, but this time we'll include the package structure, com.abc.first.item. And now you see IntelliJ has both created the package folders and created a class called item at the same time, nested in the right folder. And again, the package statement was added to the source file for us. Those are the different ways to create packages in IntelliJ. Let's real quick add a field to this item class and a constructor. Private, string, type, semicolon. Public, item, opening parentheses, string, type, closing parentheses, opening curly brace. This dot type equals type, semicolon, closing curly brace. And we'll add it to string method real quick. I'll use generate to create it and place it just below the constructor. Okay, so now we're going to use this class from our dep.lpa.main class. Into that class, let's create a main method with the PSVM shortcut in IntelliJ. Then we want to create an item. I'll start by typing item, and what I want you to notice is that IntelliJ is displaying all the classes that it knows about that start with the word item, and at the top is our com.abc.first.item. If we select that first class, IntelliJ adds the import statement for us, and we can continue to create an instance of item. Item, first item, equals new, item, opening parentheses, double quotes, burger, closing parentheses, semicolon. System.out.println, opening parentheses, first item, closing parentheses, semicolon. And we can run the main method now using this item class from the com.abc.first package. And if we run that, we can see the output item type equals burger. Now, you can imagine that item as a class name might be used in a lot of applications, so the import statement lets us tell the compiler which item class this really is. We'll be going into this in a lot more detail in a future video. I've said that you could use a fully qualified name instead of an import statement, so let me just show that to you next. I'm going to retype the first statement using the fully qualified class name. Because we have those auto import settings configured, you will want to do this, the import statement will disappear. com.abc.first.item, first item equals new com.abc.first.item, opening parentheses, double quotes, burger, closing parentheses, semicolon. Okay, so that's another way to use a class from another package, but you can imagine that if we have to reference that class name more than a couple of times, this could get ugly really fast. Let's revert that code back to the way we had it. When I do that, the import will reappear, but then we'll make one minor change. In the import statement, let's replace item with an asterisk. And this code still compiles if we use an asterisk. Remember, an asterisk is a wildcard which says import all classes from this package. We only have one class in this package and are only using that one class, so the asterisk doesn't buy us much in this example. In truth, with the introduction of the IDE, the use of the asterisk is less commonplace because it's more descriptive to include an import statement for every class, but you may still see it used in some code. Okay, that's our introduction to packages and import statements. We're going to be using these from now on, so there will be plenty of time to go over more of the details as we progress. Modules are another level of organization, and we'll also be covering modules in their own section. This video ends the object-oriented introduction sections of this course. The next video starts a new section on another important Java feature, the array. I'll see you in that next video. Welcome to the Arrays section of the Java Master class, and congratulations for making it this far. I hope that as you are progressing through more and more of the course, that you're feeling more confident and getting better at writing Java code. There's still a lot to learn, and I'll admit that some of my most favourite features of Java are still ahead. In the last two sections, we learnt about different ways to create classes which can have any number and type of data elements. What we haven't really discussed, though, is a way to have multiple values all of the same type. We had a taste of this kind of problem in the Bill's Burger Challenge. We had several toppings for our burger, and we had to create individual attributes. This led to inefficient code and other limitations. For example, what if we needed 10 toppings? There are much better ways to handle this. Java provides us with many types of containers to store multiple values of the same type. These start with the most basic, which is the array, and that's what this section will cover. Let's get started. Let's look at ways to store and manipulate multiple values of the same type. The most common way to do this in Java is with an array. An array is a data structure that allows you to store a sequence of values all of the same type. You can have arrays for any primitive type, like ints, doubles, booleans, or any of the 8 primitives we've learned about. You can also have arrays for any class. Elements in an array are indexed, starting at 0. If we have an array storing 5 names, conceptually it looks as shown here. The first element is at index 0 and is Andy. The last element in this array is at index 4 and has the string value Eve. When you declare an array, you first specify the type of the elements you want in the array. Then you include square brackets in the declaration, which is the key for Java to identify the variable as an array. The square brackets can follow the type as shown in the first 2 examples. This is much more common. And this is how I'll be declaring arrays in the code in this course. The brackets can also be after the variable name, as shown in the last example. You may see this in some code you run across. You don't specify size in the array declaration itself. Remember, the declaration is usually to the left of an equals or assignment operator, but not always. One way to instantiate the array is with the new keyword, much as we've seen with most of the classes we've used to date, with the exception of string. On this slide, we have an array declaration on the left of the equals sign, and then an array creation expression on the right side. For comparison, I'm showing you a typical array variable declaration and a class instance or object creation expression using the string builder class. They look pretty similar, but there are 2 major differences. Square brackets are required when using the new keyword, and a size is specified between them. So in this example, there will be 10 elements in the array. An array instantiation doesn't have a set of parentheses, meaning we can't pass data to a constructor for an array. In fact, using parentheses with an array instantiation gives you a compiler error. Okay, that's a brief overview of what an array is. Let's look at arrays in some code now. I've already created a project called Arrays Project with the usual main class and main method. And I put this class in the deb.lpa package, which I'll be doing from now on. My class has this first statement, the package statement. I'll create an int array called myIntArray and set it to have 10 elements. Like we do when we create any new object, we use the new keyword. Underneath the covers, a Java array is just a specialized class, so the new keyword here creates a new array. And now we again need to specify the type, similar to the way we specify the class when creating a new instance. But this time, we specify the type that all the array elements will be, so this will be int here. And next, we include the brackets again, but with a number, the size of the array in the brackets. This is the number of slots, or in this case, of separate integers that we want in this array. And it's important to know that an array is not resizable. The size of an array, once created, is fixed. In this case, integer array will have 10 elements. You can't change the size of an array after the array is instantiated. We can't add or delete elements, we can only assign values to one of the 10 elements in this array in this example. Now, in our code, let's see how we'd go about accessing the array elements. I'll set element 6 of my int array to the int value 50. This statement assigns the value 50 to one of the array elements. You might assume that this code is assigning 50 to element 5, but it's actually saving it to element 6. The reason for this is, as with all arrays in Java, indexing starts with position 0, not 1, as I've stated on the slides. And for the last element, you'd actually use index 9 in this case. Instead of starting from 1 and finishing on 10 for this array, you start from 0 and finish on 9. This may be confusing at first, but you'll soon get used to it. Arrays can be any primitive type, so we could create an array to contain doubles. Let's do that next. Double opening and closing square brackets, my double array equals new double opening square bracket 10 closing square bracket semicolon. And I'll set the third element of my double array to the value 3.5. And here we're creating an array called my double array with room for 10 doubles. And we set the third element in that array to a floating point number, a decimal number 3.5. Remember that any decimal number literal like we're using here is really a double in Java. Retrieving a value from the array is done in the same way using the position of the element in the array. Let's print out the third element of the double array we just created. System.out.println, opening parentheses, my double array, opening square bracket, 2, closing square bracket, closing parentheses, semicolon. Again, we call it the third element, but we use index 2 because Java starts counting at 0 for arrays. And we get 3.5 printed out, which we assign to that element on line 11. Like any variable, whatever type you define the variable to be, that's the type of data that can be assigned to that array. You can't put a double into an integer array in much the same way you can't assign a double value to an integer variable. Now, let's assign some more data to the first two elements of the integer array. Set the first element of my array to double value 45.0. And set the second element to string literal 1. In this code, I've purposely created a couple of errors. I declared this array to store integers, and here, silly me, I'm trying to assign other types of values to the array elements. You can see we have compiler errors here because Java doesn't allow this. In the first case, we have a double, and that can't be assigned to an int element. In the second case, we're trying to assign a string literal to an int variable, which is what each array element really is. Let's fix those. And that compiles, so that's good. But imagine assigning values this way, one at a time like this, for the other 7 elements. You can see this gets tedious really fast. Java provides another shortcut for creating an array. If we know the values for all the elements at the time we create the array, we can use an array initializer. An array initializer makes the job of instantiating and initializing a small array much easier. In this example, you can see we still use the new keyword and have int with the square brackets. But here we specify the values we want the array to be initialized to in a comma delimited list in curly braces. Because these values are specified, the length of the array can be determined, so we don't specify the size in the square brackets. And actually, Java provides an even simpler way to do this. Java allows us to drop new int with brackets from the expression as we show here. This is known as an anonymous array. Here we're showing examples for both an int array as well as a string array. An anonymous array initializer can only be used in a declaration statement. I'll explain what that means in a minute. Okay, so getting back to our code, let's create a new integer array. This time, we use an array initializer to create an array with the values 1 through 10 in it. I'll tell Java it's an integer array called first10 and assign the values 1 through 10 in curly braces. I'll print out the first 10 array's first element's value. Let's say first10's length to a new int variable array length and print it out using println. Okay, so now I've created a new integer array and I've actually defined the numbers we want in that array. The fact is, there's actually 10 elements in there, 1 through 10. Java looks at that and initializes an integer array with 10 elements. Then Java assigns each value in this list to an array element in the order we specify here. Element 0 gets assigned the value 1 and element 9 of the array will get the value 10. To confirm that, I'm printing out the first element in this code. And then we access a field on the array called length that tells us the length of the array. Here, we assign it to a local variable called array length and print that out. If we run this code, you can see we've got first equals 1 and length of array equals 10. But what happens if we want to get the last element of an array? Let's add another line of code to get the last element using the length of the array. I'll print the element. But if we run this though, we get an exception. This is an array index out of bounds exception, and you can see the message index 10 out of bounds for length 10. This is a very common error to make. We've been taught to think starting with 1, not 0, so it's easy to forget that Java starts indexing with 0. Because it starts with 0, all indices are shifted by 1. The last element in an array that has 10 elements is at index 9. We need to subtract 1 from the length to get the last index. Let's fix that. I also hope you notice that we can use variables and expressions in the square brackets to access an array element, as we're showing here. The expression or variable needs to evaluate to an integer value. And running that, we get last equals 10. Now I've said this array initializer can only be used in declaration assignments or method arguments, so let's review what that means for a moment. Int, opening and closing square brackets, new array, semicolon. And I'll attempt to set the values 1 to 5 reversed as an array initializer. And now, with this code, we've got a compiler error. If we hover our mouse over that statement, we see that array initializer is not allowed here. This means you can't use the anonymous version of the array initializer in a statement outside of a declaration statement. But we can use the longer form, so I'll change that now, including new int with square brackets before the values in curly braces. And this code compiles. Once you have an array, you can loop through the elements, retrieving each value with the loop index. We can do this with the traditional for loop. For, opening parentheses, int I equals 0, semicolon, I less than, new array.length, semicolon, I plus plus, closing parentheses, opening curly brace. And I call print on new array element I and add a space after that, closing curly brace. What we're doing there is we're looping through each element starting from element 0. We start with I equals 0, incrementing by 1 while I is less than new array.length. And we print out each element using the loop index to get the current element. We're just printing all of those on a single line with a space between each and running that. We can see all the elements in the array get printed. Okay, that's our introduction to the basic array, declaring an array, and the different ways to instantiate an array. In the next video, we'll continue to talk a bit more about the array type in Java. In the last video, I introduced you to the Java array. I talked about how to declare an array, how to initialize the elements in an array, and how to access elements in it using the square brackets and an index. An array is a special class in Java. It's still a class. The array, like all other classes, ultimately inherits from java.lang.object. Getting back to the code where we left off in the last video. In the arrays project, we used an array initializer to create an integer array and set the elements in the array to be the numbers from 5 down to 1. Now, instead of doing this, we can use a loop to assign all the values with an expression or calculation. First, I'll comment out the statement with the array initializer. Then I'll create an uninitialized array. New array equals new int opening square bracket 5 closing square bracket semicolon. Let's run this. Here, you can see we get all zeros printed. When you don't use an array initializer statement, all array elements get initialized to the default value for that type. For primitive types, this is 0 for any kind of numeric primitive like int, double or short. For booleans, the default value will be false. And for any class type, the elements will be initialized to null. For our array, an integer array, 0 gets assigned to each element in the array by default, and you can see that here in the output. Now, let's use the basic for loop to assign the values as we had them before in reverse order. And I'll insert that before the loop that prints out the values. For, opening parentheses, int I equals 0, semicolon, I less than, new array.length, semicolon, I plus plus, closing parentheses, opening curly brace. New array, opening square bracket, I closing square bracket equals new array.length minus I semicolon, closing curly brace. The loop setup is the same as before, but inside the loop, you can see we're assigning each element in the loop. We're using the square brackets and the loop variable I within the brackets to assign a value to each array element. And it gets assigned whatever the value will be when the current index is subtracted from the length of the array. When this is 0 to start, we get the length of the array as the first value, which is 5. And when we reach the max value, which I've said was 4, the element will get the value 1. Now, if I run it, you can see we get the numbers printed from 5 to 1. You can use a loop to populate and initialize elements in an array as I did here. And I've used a traditional for loop to do that, as well as print out the elements. Java has another for statement. They call it the enhanced for loop, but it's also sometimes known as the for each loop. I've mentioned this for loop, and I said I'd talk about it when we got to arrays and collections. This loop was designed to walk through elements in an array or some other type of collection. It processes one element at a time from the first element to the last. Here I show you the syntax for the two types of for loop statements side by side. The enhanced for loop only has 2 components versus 3 defined in the parentheses after the for keyword. It's important to notice that the separator character between components is a colon and not a semicolon for the enhanced for loop. The first part is a declaration expression which includes the type and a variable name. This is usually a local variable with the same type as an element in the array. And the second component is the array or some other collection variable. Let's see this for loop in action. Let's do what the last for loop did in our code, which was to loop through each element in the array and print each value out. But this time, I'll use the for each or enhanced for loop to do it. I'll call println to make some space. For, opening parentheses, int element, colon, new array, closing parentheses, opening curly brace. And print out element using print with a space after it. Closing curly brace. First, we just print a new line there because the previous output didn't include it. Now we've got the enhanced for loop code. Notice that it looks similar to a traditional for loop, but it uses a colon and not semicolons and expects only 2 components in the parentheses. The first component just needs to be a declared variable. In this case, we're looping through an array of integers, so we want to set this variable to an int type. And here, rather than just the letter I, I'm purposely using something more descriptive. This is because the variable is the actual element, it's not the array index we're looping through. And the second part, on the right side of the colon in the parentheses, is the thing we're looping over. In this case, it's our integer array, new array. And now, in the print statement, we don't have to use an index to get the element from the array. The enhanced for loop gets it for us and stores it in that local variable element. In this case, we don't have to know what the index is at all. If we wanted it or needed it, we'd probably use the traditional for loop. If I run that, we get the exact same output. The values 5 through 1 are printed out. That's rather a nice thing, because you don't have to deal with the array index position. The enhanced for loop gives you a simpler, less error-prone option if all you need to do is process the elements from start to finish and you aren't trying to set, swap, or sort elements. Okay, so you might be asking, can't we just print the whole array using system.out.println? Let's try that next. Add a call to println to make some more space, and print out new array. And what happens if I run that? We get this strange thing printed out and not a neatly formatted list of our array elements. Yours might look different from mine, but that's okay. I'll explain the numbers and letters shortly. You'll remember this is Java's toString method that gets called, and I've said our array is really just a special Java class. But the array class doesn't print the elements out neatly for us as we might hope. In other words, it doesn't override the toString method, so it uses java.len.objects toString method. And this gives us the left square bracket with a capital I, which means it's a primitive integer array, and then it's followed by the hexadecimal representation of the hash code. This is not likely to be very helpful to you as you examine and manipulate your array. However, Java does provide a helper class which contains a lot of static methods which we can use for arrays. And this class is the java.util.arrays class. Java's array type is very basic. It comes with very little built-in functionality. It has a single property or field named length, and it inherits java.util.objects functionality. Java provides a helper class named java.util.arrays, providing common functionality you'd want for many array operations. These are static methods on arrays, so class methods, not instance methods. In the next video, we'll be looking at this class in a lot more detail. For now, we'll use one method on this class to print out the elements in our array, and this method is arrays.toString. The toString method on this helper class prints out all the array elements, comma delimited and contained in square brackets. The output from this method is shown here conceptually. It prints the element at index 0 first, followed by a comma, then element at index 1 next, comma, and so on, until all elements are printed. Let's see what this looks like for our integer array. I'm going to replace that last system.out.println statement in our code with a different one. System.out.println, opening parentheses, arrays.to, string, opening parentheses, new array, close both parentheses, semicolon. And now, if I run that, we see that we get our 5 elements printed out in square brackets and comma delimited. That's a handy method, which may be all you need if you just want your elements printed in a single string this way. One other thing you should know is that you can assign any array to an object variable. Let's look at this more closely. Object variable equals new array semicolon. If opening parentheses object variable instance of int opening and closing square brackets, closing parentheses, opening curly brace. Print out the string literal object variable is really an int array if that is the case, closing curly brace. In this code, we're assigning an integer array reference to an object reference. And notice here, we can still use the instance of operator using an array type on the right side of the operand. This operand will test if our object variable is really an instance of an integer array. An array is a special class recognized by Java through the use of the square brackets. It still inherits from the java.len.object class. You might ask, why would do something like this? Well, in fact, you could create an array of objects that supports any kind of type in Java. Let's look at that now. Object, opening and closing square brackets, object array equals new object, opening square bracket, 3, closing square bracket, semicolon. Set element 0 of object array to the string literal hello. Set element 1 of object array to a new instance of string builder initialized with string literal world. In this code, we're creating an array of objects, and this array will hold 3 object references. And now we can assign any object reference of any type to the elements in this array. First, we assign it a string literal, and then we assign it a string builder instance. You could assign an object of any of your own classes to this kind of array. This is one way of having an array of many different types. I'm not saying this is good practice, but I did want to point out that you could do this with arrays. Later, we'll learn more elegant ways to support different types in arrays. And because we know an array is an object, you can assign an array to be an element of this type of object array. Set element 2 of object array to new array. We've got an array of objects, and one of the elements is an array of integers. This is a nested array. We'll be looking at this in more detail when I talk about multi-dimensional arrays. But what's important for you to understand right now is an array can be treated like any other object instance in Java. So those are the basics for the array. In the next video, we're going to discuss the java.util.arrays class in more detail. This is a helper class you want to get to know better because there's no need for you to write a lot of code since Java provides so much functionality for us. I'll see you in that next video. We use arrays to manage many items of the same type. Some common behavior for arrays would be sorting, initializing values, copying the array, and finding an element. For an array, this behavior isn't on the array instance itself, but it's provided on a helper class java.util.arrays. And we saw an example in the last video when we used the toString method. Now we'll go to Oracle's API documentation and examine this class a bit more. Looking at the methods on this class can be a bit overwhelming because there are so many overloaded versions. Let's pause for a moment and look at each of the overloaded versions for just one of the methods, binary search. You can see support for every type of array. First, for all the primitive type arrays, and you can see these as we scroll down, boolean, double, float, and long are some of those. And next, there's the object array, which we discussed in the previous video. There's many overloaded versions for a single named method. This means, for example, we can use the binary search method for an array of any type. In this video, we'll review a few of the most common methods you use. As the course progresses, I'll be reviewing additional methods as they relate to the subject. I've created a project called Using Arrays with the usual main class and main method. The first thing I want to do is create another method on this class which will return an array of random integers. I'll call this method getRandomArray, and it'll take the length of the array to be created as the only argument. Private static int opening and closing square brackets getRandomArray opening parentheses int then closing parentheses opening curly brace. Random equals new random opening and closing parentheses semicolon. Int opening and closing square brackets new int equals new int opening square bracket then closing square bracket semicolon. Return new int semicolon closing curly brace. The first thing to notice here is the first statement in the method where we are creating a variable of type random. Random is another class in the java.util library that can be very useful. This class has methods on it to return random numbers, which we'll be using shortly. You can see we're also creating a new array and setting it to the size that was passed in as the method's argument. This new array gets returned from this method. Next, I want to assign a random number to each element in the array. For opening parentheses int I equals 0 semicolon I less than then semicolon I plus plus closing parentheses opening curly brace. New int opening square bracket I closing square bracket equals random.nextInt opening parentheses 100 closing parentheses semicolon closing curly brace. Return new int semicolon closing curly brace. Since we're assigning values to the array elements, we use a traditional for loop. Each element gets assigned the result of the random.nextInt method, which returns a random integer value. If you don't pass any argument to this nextInt method, it returns any number from 0 to the maximum integer value. But we want to limit the random numbers, so we pass 100. This argument is called the exclusive upper bound. This method returns a random number between 0 and 99, and it excludes 100. If we wanted 100 to be included in the random selection, we'd specify 101 and so on. Our new method, getRandomArray, returns a new array of the length we specify and fills it with random numbers. Going back to the main method, I want to call this method to get a random array and then print it out. int opening and closing square brackets, first array equals get random array opening parentheses 10 closing parentheses semicolon. System.out.println opening parentheses arrays dot to string opening parentheses first array close both parentheses semicolon. Here we create a variable of type int array and assign it the result of our getRandomArray method. And we call arrays.toString because it's a static method on arrays and we pass our array to it. And running this, you can see we get 10 random numbers there. The array numbers will be different and they'll be different every time you run it. This is because they're randomly generated. And maybe the first thing you'd like to do when you get data from any source is sort it if it's not already sorted. Java provides a sort method for us in this case on this same arrays class. Let's give that a try. I'll call arrays.sort passing first array and print out the value returned from a call to arrays.toString passing first array. We call sort directly using the class name arrays and pass it first array. This method doesn't return anything, it's void, so we're not getting a new instance of an array back. The actual array we pass to it actually gets sorted. And running that, we can see our numbers get ordered from low to high, which is called the natural order for numeric values. Let's say we want to set all the values in an array to our own initial value before processing. We want something besides zeros, but we don't want to use an array initializer because we want them all initialized with the same value. We can do this with the arrays.fill method. I'm going to create a new array for this. Int opening and closing square brackets, second array equals new int opening square bracket 10 closing square bracket semicolon. Print out the value returned from arrays.toString passing second array. Arrays.fill opening parentheses second array comma 5 closing parentheses semicolon. And print out second array again, same as I did above. This first statement creates a zero-filled array because 0 is Java's default for elements in an integer array. But on this line, when we call the fill method, it sets every element to 5. And running this, we can confirm elements start out as all zeros, then it's all 5s. Now, maybe you don't really want these changes being made to your original array. You can create a copy of the array and apply operations to the copy. Let's look at how to do that. Int opening and closing square brackets, third array equals get random array opening parentheses 10 closing parentheses semicolon. Print out the value from a call to arrays.toString passing third array. Int opening and closing square brackets, fourth array equals arrays.copy of opening parentheses third array comma third array.length closing parentheses semicolon. Print out fourth array like we did for third array above. Again, we're creating a random number array there on that first line. Then we call arrays.copyOf, which takes the array and assigns us the second argument. Since we want an exact copy, we just pass the current size of the array we want copied. Running that, we see that the third and fourth array have the same elements in the same order. And now, what if we sort the elements in this copied array in the fourth array? Will this have any effect on the third array, the array we made a copy of? Let's test that. Arrays.sort, opening parentheses, fourth array, closing parentheses, semicolon. Print out third array using arrays.toString. And same thing for the fourth array. And running this code, we see that fourth array is sorted, but the array we copied the data from is still in its original state. An array copy creates a new array, a new instance of an array, and copies the array elements over to the new array. For primitives, the values get copied. For objects, the object references get copied. Performing operations on the copied array, like sort and fill, don't impact the original array. Let's see what happens when the length we pass is less than the number of elements in the array. Int opening and closing square brackets, small array equals arrays.copyOf opening parentheses, third array, comma, 5, closing parentheses, semicolon. And let's print small array using arrays.toString. Now here, we're passing 5 as the second argument. When we run this, you can see this gives us only the first 5 elements in the copied array. And let's test one more example. We'll pass a value greater than the size of the array. Int opening and closing square brackets, large array equals arrays.copy of opening parentheses, third array, comma, 15, closing parentheses, semicolon. Using arrays.toString, print out large array. Now here, the length of our array is 10, but we want an array of 15 elements. Is this going to work? Let's run it. You can see from this output, we get our 10 elements copied over in the order they were when we made the call, but we have 5 more elements in this array initialized to 0. This one method can be used for 3 different types of copies: a full copy, a partial copy, and a copy plus additional elements. This video is getting a bit long, so I'll cover the next important operation in the following video. I'll see you in that next video. In the last video, I covered making copies of arrays, sorting them, and populating the elements with values either all the same or by some expression in a for loop. In this video, I'll cover finding a match. There are different algorithms for searching and matching elements in lists. You can hopefully imagine if you were going to start writing code to do this, you might start looping from start to finish and check each element to see that it equals what you're looking for. If you find a match, you'd stop looping and return that a match was found, either with the position you found the element at or just a Boolean value, true if it was found and false if not. This is called a linear search or sequential because you're stepping through the elements one after another. If your elements are sorted though, using this type of linear search is unnecessarily inefficient. Imagine looking for the word middle in the dictionary, starting at the first page and looking on every sequential page until you finally find the page that has the word middle. That's not really how you'd look for it though, is it? Because you'd waste a lot of time. You'd pick a spot in the dictionary based on the word you're trying to find that you think might be close to where your word might be. In this case, it might just be somewhere in the middle of the dictionary. You might divide the pages in half and determine which half included the word middle. In other words, you'd figure out which section of the two to keep looking in. You split each section up, testing the values at the boundaries, and based on that, split again into smaller sections, narrowing the number of elements to test each time. This type of searching in software is called interval searching. Within these two categories, sequential and interval, there are numerous existing algorithms in each. One of the most common interval searches is the binary search, which is why Java provides this search on so many of its collection classes. In this search, intervals are continually split into 2, hence the word binary. If you're a software engineer at heart, you'll have some fun researching these algorithms and how they differ and studying the code behind their implementations. For most of us, though, we just need to understand that Java gives us methods for searching and when and how we should use those methods. The static method, binary search, is on the arrays class. We can use this method to test if a value is already in our array, but there are some important things to remember. First, the array has to be sorted. And second, if there are duplicate values in the array, there's no guarantee which one it'll match on. Finally, elements must be comparable. Trying to compare instances of different types may lead to errors and invalid results. This method returns the position of a match if found. It returns a -1 when no match was found. It's important to remember that a positive number may not be the position of the first match. If your array has duplicate values and you need to find the first element, other methods should be used. So let's look at this method using a string array. I'll create a string array called sArray and initialize it with 5 string literals. Arrays.sort, opening parentheses, sArray, closing parentheses, semicolon. I'll print out the value returned from a call to arrays.toString passing our sArray. If opening parentheses, arrays.binary search, opening parentheses, sArray, comma, double quotes, mark, closing parentheses, greater than or equal to 0, closing parentheses, opening curly brace. print string literal found Mark in the list if he was found. Closing curly brace. In this code, I create a string array with 5 strings populating the elements with an array initializer. We sort this array because the binary search only works on sorted arrays. This is really important and can't be stated enough. What good is a dictionary if it's not sorted after all? The dictionary allows your brain to do interval searching because the words are sorted alphabetically. A binary search can do interval searching successfully because the elements are sorted. A negative number returned from the binary search method means the item wasn't found. Otherwise, the item was found in the array and it returns the position of a match, though it doesn't guarantee which match. And running the code, we can confirm that Mark is in the list. We've covered how to look for one element in our array, but what if we want to compare if 2 arrays are equal? 2 arrays are considered equal if both arrays contain the same number of elements and all elements in the same position in both arrays are equal. I'll create an array of numbers. I'll call it S1 and initialize this array with the values of 1 through 5. And I'll copy that statement, pasting it right below it, but change S1 to S2. Now I'll use the equals method on arrays. If opening parentheses arrays.equals opening parentheses S1, comma, S2, close both parentheses, opening curly brace. Print string literal arrays are equal. Closing curly brace, else opening curly brace. Print string literal arrays are not equal. Closing curly brace. The equals method on arrays takes 2 arguments, 2 arrays whose types have to match, so you have to compare 2 in arrays or 2 Boolean arrays, etc. This method returns true or false, so if we test if it's true here, we print arrays are equal, otherwise we print they are not equal. Let's run this, and we get both arrays are equal. But are they equal if they have the same length and the same values, but the values are in a different order? In the second array, we'll just switch where 1 and 5 are located. Now, if we run it, we see arrays are not equal. This method takes the order of the array elements into account as well. Let's revert that last change, and now I'm going to add an element to the second array. I'll just add a 0 at the end. And running this, our arrays are not equal because their lengths are not the same. Okay, so we've covered some of the basic functionality on the java.util.arrays class that let us sort, fill, and copy arrays and look for elements in an array and test if 2 arrays are equal. The next video will be a challenge for you to create an array and manipulate its elements, so I'll see you in that video. Okay, it's challenge time for arrays. In this challenge, I want you to create a program using arrays that sorts a list of integers in descending order. Descending order means from highest value to lowest. In other words, if the array has the values 50, 25, 80, 5, and 15, your program should return an array with the values in the descending order 80, 50, 25, 15, and 5. First, create an array of randomly generated integers. If you don't know how to do this, be sure to watch the previous video. Print the array before you sort it, and print the array after you sort it. You can choose to create a new sorted array or just sort the current array. In the last video, I showed you how to use the arrays.sort method, but that sorts from lowest to highest. This challenge is for you to sort in reverse or descending order. In addition, you should use the arrays.toString method to print out your array before and after sorting. If you want to, you can make a copy of the array before sorting. It's time now to pause the video and actually try this challenge. If you get stuck, or when you're finished and you're ready to check my version of the solution, come back and I'll show you how I did it. Pause the video now. Okay, so how did you get on? Did you figure it out? Let's go through and create my solution so you can compare it to yours. I've already created a project called Array Challenge, and I've got the usual main class inside the dev.lpa package. The first thing I want to do is write a method that gives us an array of randomly generated numbers. We did this in the last video, so this should look familiar if you watched that video. I'll type the whole method in this case, since it's really what we did before with one exception. Then we'll review it. I'll call the method getRandomArray with one int parameter named len, and it returns an int array. Random equals new random opening and closing parentheses semicolon. I'll create our int array random array. For opening parentheses int I equals 0 semicolon I less than len semicolon I plus plus closing parentheses opening curly brace. Random array opening square bracket I closing square bracket equals random.nextInt opening parentheses 1000 closing parentheses semicolon closing curly brace. Finally, I'll return the array we created, closing curly brace. I've used a random class in the java.util package, setting up a local variable for that and creating an object. Next, I created an int array with the length argument we get passed to the method. Remember, an int array, when it's created, gets initially populated with all zeros. Then I loop through that array and I set each element to a random number, calling the random.nextInt method. And this time, we've got 1000 as the upper bound passed to that method. That means we want random numbers between 0 and 999 because that upper bound is an exclusive upper bound. And finally, I return this array from the method. I'll have the code to call the new method from the main method. Int opening and closing square brackets unsorted array equals getRandomArray opening parentheses 5 closing parentheses semicolon. I'll print out the value returned from a call to arrays.toString passing unsorted array. In this case, we start with a small array with 5 elements and we'll print the unordered elements out. Running that. Your array will be different from mine since the numbers are randomized. And we know we can just order these using arrays.sort, but that sorts in the order lowest to highest. We want the opposite here. How do we sort in reverse order? Later, we'll learn how to use an overloaded version of the sort method to do this, but in this challenge, I want to use the skills we've learned so far. We could go about this in a couple of ways. We could sort the array first, then just swap the order of the elements. Or we could write our own sort method. For my solution, I'm going to do it the second way. I'll create a method called sortIntegers that's going to sort the array and return a new array containing the sorted numbers. The first thing I'll do is copy the contents of that array into a new array. Now, I know we can do this using arrays.copyOfMethod, so let's use that here. Private static int opening and closing square brackets sortIntegers opening parentheses int opening and closing square brackets array closing parentheses opening curly brace. Create a copy of the array passed to this method and return it, closing curly brace. We haven't sorted anything yet, we're just returning a new copy of the array from this method. Now we have to add the code to do the reverse sorting. We're going to do this with a while loop. Boolean flag equals true semicolon. Int temp semicolon. While opening parentheses flag closing parentheses opening curly brace. Flag equals false semicolon. Closing curly brace. Return the array. First, I created a boolean called flag, set that to true. Our while loop will keep processing until flag is flipped to false. We also need a temporary variable which we'll use in the loop in a minute. Next, I start the while loop, testing the flag condition, which is true. And right away I'm going to set it to false, and the reason is I'm going to have a nested for loop. If the for loop hasn't finished sorting all the numbers, we're going to flip the flag back to true again so that the actual while loop continues. By default, we're setting it to false, which means if we don't reset flag to true, we'll end the while loop. Now, I need to add the code to actually start doing the sort. Bear with me as I type this out, then we'll talk about how this works. For opening parentheses int I equals 0 semicolon I less than sorted array.length minus 1 semicolon I plus plus closing parentheses opening curly brace. If opening parentheses sorted array opening square bracket I closing square bracket less than sorted array opening square bracket I plus 1, closing square bracket, closing parentheses, opening curly brace. Temp equals sorted array, opening square bracket, by closing square bracket, semicolon. Sorted array, opening square bracket, by closing square bracket, equals sorted array, opening square bracket, by plus 1, closing square bracket, semicolon. Sorted array, opening square bracket, by plus 1, closing square bracket, equals temp, semicolon. Flag equals true, semicolon. Closing curly brace. Closing curly brace. This code is going to compare two contiguous or sequential elements, meaning elements that are side by side. We'll do this in a for loop, starting at element 0, which we know is the first element. Because we're comparing two elements in each iteration, we'll stop comparing at the element that's just previous to the last element. That's why we're using sorted array.length -1 there as the condition in the for loop. The first time in this loop, we'll compare the first and second elements with this if statement. If the first element is less than the second element, we want to swap the elements. We use the temp variable to move the current element's value into a temp variable. We then set the current element to the value we want swapped in. And then we set the next element's value to the one in the temp variable. If we didn't move the current value into a temp variable, we would override it or lose its value, so we have to temporarily store it while we're swapping. When you're switching places like this, you'll often see code that moves one array element into a temp variable before it swaps it with another. And although this will order some of the values in the first pass through the loop, it may not get them all. Let's add some system.out.println statements that will help us see this better. We'll print the array right after we swap a number, and we'll print the array right after we finish one pass through the for loop. Print the value returned from arrays.toString, passing our array called array. I'll print sorted array via call to arrays.toString. And print sorted array again here. And to make this easier for our purposes right now, to understand what this code is doing, we'll pass in a static array with 3 values. We'll create out sorted array with a call to sort integers, noting how I'm passing a new array. And then print our sorted array via call to arrays.toString. And if we run that, we can see what is happening at the different stages. We start with the numbers in the reverse order of what we want them to be. On the first check, the code checks if 7 is less than 30, and it is, so it's going to swap them and print that out. On the second line there, you can see 7 and 30 were swapped. Next, it's going to test the following element, which is 7 now because we just swapped it, and it's going to see if 7 is less than 35, and it is, so again it'll do the swap process. It swaps 7 and 35. At the end of the for loop process, we have the array in the order 30, 35, 7. And we can see from this, it's not done sorting. Now, the flag was set to true during the last swap, so our while loop is going to keep processing. And the for loop will happen again. And now the second time through the for loop, we're starting with 30, 35, and 7. The first element is less than the second element in this case, so again a swap will happen, 30 gets swapped with 35, and the flag gets set to true. And now we have a fully sorted array, but because the flag is true, the while loop will execute again, and the for loop will execute again. But there's nothing left to swap. This time, the flag never gets set to true, so the while loop will finally exit. Okay, so that was the challenge. And maybe you came up with a different method to sort. Maybe you used arrays.sort to first sort lowest to highest, and then simply swap the values. We'll look at something similar to that in a future challenge. For this challenge, I wanted you to see how you might go about manually sort array elements. This will help you appreciate some Java features we'll be talking about later. Java provides many ways to sort your collections of objects. Right, in the next video, we'll do a recap of the Java array, then I'll give you a couple more challenges. The array is a very important data structure in Java, so it's important to grasp how it works. I'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Alright, I want to recap what we've learnt so far about arrays and discuss some of the common errors that occur using arrays. An array is a data structure that allows us to store multiple values of the same type in a single variable. The default values of numeric array elements are set to 0. Arrays are 0 indexed, so an array with n elements is indexed from 0 to n minus 1. For example, 10 elements would have the index range from 0 through 9. If we try to access an index that is out of range, Java will give us an array index out of bounds exception, which indicates that the index is out of range, in other words, out of bounds. We try to access an element that is outside of what we've defined. To access array elements, we use square braces. This is also known as the array access operator. Here, I'm showing an example of how to create an array. I'm using square brackets after the type. In this case, it's an int array, so we've got int, square brackets, then the name of the variable. We're calling it simply array, so it's int, square brackets, array. Then after the equals sign, we type new int, again because it's an int array, and 5 in square brackets, representing the number of elements in the array. In other words, 5 is the length of the array, and you can see that in this scenario. This array contains the elements from array 0 through to array 4. It has 5 elements and an index range, in this example, from 0 to 4. The new operator or keyword is used to create the array and initialize the array elements to their default values. In this example, all the array elements will default to 0 because it is an int array. For Boolean arrays, elements would be initialized to false. If you use string or other objects, they would be set to null or a null reference. We can also initialize an array inline using an array initializer block, as I show here. In this example, I've got int left to right square brackets, my numbers equals, and I've got left and right curly braces with the numbers 5 down to 1. Then at the end, there's a semicolon. Notice that I define the values for the array in curly braces in the order we want them assigned, each value separated by a comma. This way of initializing array elements is also known as an anonymous array. It has 5 elements and an index range from 0 to 4. In this example, the array elements are initialized to 5 down to 1. Alright, here's another example of our array. Int, square braces, my array equals new int, 5 in square braces, and a semicolon. Hopefully you will recall that when we first used variables, we said a variable is a place in memory. Think of it like a box, and you can store something in that box. Well, the same goes for arrays. With arrays, you can imagine an array as a row of boxes or slots where each box can contain a value. In other words, we could store something in each box. In this example, I've created an array with 5 elements. In other words, 5 boxes, and they are by default all initialized to 0. Every box in this example contains an integer value of 0. Every box or slot's got an index, which we can use to access the values by an index using square brackets. In this example, I've initialized the array with values in the same line using an array initializer, as we have talked about previously. That's also known as an anonymous array. Each box or slot contains a different value in this case. The array again has 5 elements, but we're putting a different value into each box. The box or element at index 0 contains the number 10, the box at array element 1 contains 35, and so on. Alright, let's see some of the common errors that occur when working with arrays. Here's an example of the first common error, array index out of bounds. As you can see, we're trying to assign the element at index 5, and that index doesn't exist. In other words, it's out of bounds. And the same goes if you use a negative index, because arrays can't have a negative index. The index or position of the element has to be 0 or higher. But note that an array element's value can be a negative value. In other words, we can put a negative number into one of those boxes, but we can't try and access a specific box or element using a negative number. In this particular case, you can see that we've defined the array on the first line, int left and right square brackets, my array equals, then we've got the left and right curly braces, 10, 35, 20, 17, and 18, separated by commas, and then a semicolon on the end of that line. That's a 5-element array, but remembering that our array index starts at index 0. Therefore, this code with my array, square brackets, and 5 in between, trying to set that to 55, is giving us an error. And you can see there on the screen, in the bottom right-hand corner, in that scenario, we're trying to basically update a box that doesn't exist in this particular array. So be careful when accessing array elements. Remember that array index positions start from 0 and go up to the length of the array -1 or take away 1. In other words here, we've got 5 elements and the valid range to access those elements is from 0 to 4. A second common error happens when you loop through an array using the traditional for loop with an index variable. This one is a logic error because we're starting here from element 1. Remember that the array index starts from 0. If we printed out the elements of this array starting from index 1, the first element, which is at index 0, won't be printed in this scenario. If this ever happens to you, just change the variable in the for loop to start at 0. You can see what's happened in this code. We've assigned the values in the array to 10, 35, 20, 17 and 18, but the output, as you can see, has bypassed the value of 10 because that's the value from index 0 in the array. This is because the for loop, as you can see in the red box, started from the value 1, and of course index position 1 is really the second element and contains the value of 35. The last common error that happens would again cause an array index out of bounds exception. Now this is because the condition in the for loop isn't correct. Here, we're using the less than equal operator. You can see that highlighted in the red box. But we should be using just the less than operator. The problem happens because the last iteration of the loop, the I variable will have the value 5, and the length of this array is 5. We've got 5 elements in the array, but the index range is from 0 to 4. When I is equal to 5, the condition will still be true because we've used the less than equal operator there. And 5 is less than equal to 5 is true there, with 5 being the value of I and 5 being the length of the array. This will cause another out of range exception. I keep repeating myself, but it's important to remember that the index starts at 0 and ends at 1 less than the length of the array. When looping, it's easier to use the less than sign than having to use the length take 1. Here, you can see that we could change the code to I less than myArray.length, which would work just fine. If you're just printing out an element like this, the enhanced for loop is probably a better option because it's less error prone. Use the enhanced for loop if you're looping through elements from first to last and want to process them one at a time and you're not setting or assigning values to elements. Alright, so that's a recap of arrays. I hope you got a lot out of it, and we'll move on now to the next video. In a previous video, I talked about the differences between a reference versus an object versus an instance versus a class. I want to revisit this a little and talk about why this matters when we're talking about arrays. When you assign an object to a variable, the variable becomes a reference to that object. This is true of arrays, but the array has yet another level of indirection if it's an array of objects. This means every array element is also a reference. Let's start by looking at this in code. I've created a new project that you can see here in IntelliJ called Array References. And I have a main class in the package dev.lpa with a main method. And let's just create a new simple array in the main method. Int, opening and closing square brackets, myIntArray equals new int, opening square bracket, 5, closing square bracket, semicolon. This array has 5 elements, and we have a variable, or in other words, a reference, myIntArray. Now arrays again are reference types. This means a reference is an address to the object in memory, but not the object itself. Stated differently, the variable myIntArray holds a reference or address to an array in memory. And we use a reference to access and control the object in memory. If you still find this confusing, I'm going to show you some slides shortly that should make things a bit clearer. For now, let's create a second reference variable, an integer array. Int, opening and closing square brackets, another array equals myIntArray, semicolon. Here, I'm declaring another reference to the same array in memory, so now we've got 2 references pointing to the same array in memory. In other words, both myIntArray and another array hold the same address. One way to know it's a reference type is the new operator, because that creates a new object in memory, and we're using the new operator on line 7 where we created an array of 5 elements. Basically, new here means new object. On the second line, we haven't used the new keyword. We've just used the equal sign, which means we're assigning one reference to another. Let's print these array references out. I'll use arrays.toString for my array and print the value returned. And same thing for another array. I'll just run that. And you can see that it's nicely printed out the values. We've got all zeros because all we've done is initialize the array with a size and the default values. Let's actually see what happens if we make a change to one array. Another array, opening square bracket, 0, closing square bracket, equals 1, semicolon. I'll add a call to arrays.toString for my end array and print what is returned. And do the same for another array. And we're printing out both reference variables again after we make that change. What do you think is going to happen at this point? Will it change just another array? Or will it in fact change both arrays? Let's run this and see what happens. And you can see what's happened with those last two output statements. Both variables are referencing the same array in memory, so there's only one copy of the array. When you use one reference variable to make changes to the object in memory, it's like making that change with the other variable. Now, this might look a bit weird, but that's how references work. And you'll soon see with some slides that I'm about to bring up on the screen, it's because reference types represent the address of the variable rather than the data itself. In our case again, both variables represent the address pointing to the same array in memory, so in effect we've only got one array in memory that both variables are pointing to. Let's check out those slides. Here, we've got the same code from IntelliJ. When the line int myIntArray equals new int 5 executes, this creates a new array in memory with 5 elements and initializes all elements to 0. And that's because, by default, numeric arrays are initialized to 0, because they have type int in this case. Now we've got a reference that points to the array address in memory. And on the image, you can see an arrow from the reference pointing to the array in memory. On the next line, we're creating another reference to the same array. Notice on the slide, we've still only got the one array, but we've now got two references that point to that same array in memory. In other words, pointing to that same address in memory, each reference or variable has a different name, but that doesn't mean there's two different arrays. We've got two references, but both, as you can see, clearly point to the same array. The next two lines are just printing out the array to the console. We're printing the same array again. Because there's only the one array in memory, every element has the value 0, and that's exactly what's printed out. Here another array element 0 equals 1. We're assigning the value of 1 to the first element of the array. You can see that in red in the bottom left-hand corner. That puts the value 1 into the element at index 0. In other words, we're setting the element at index 0 to hold the value 1. Now, since another array and myIntArray are two references pointing to the same array, we could say that both references can see that change. In other words, we've got one array in memory, so whichever reference to the array we use, the other references are still pointing to the same address, and we're getting the same output back as a result of making that change. Alright, we're printing out the last two lines now, and again since we're printing the same array out. Since we changed array element at index 0 to 1, we see the change for both lines for the first element in element 0, now showing the value 1 instead of 0, so both references. Again, we can see the change that we made, and we get 1 as the first element in the array. This same behavior happens when we pass reference types to methods. Let's jump back to IntelliJ to see another example. I'm going to create another method here because I want to show you that this behavior is true when you call a method and pass an array reference to a method. I'll create a new method called modifyArray that takes an int array as a parameter. Private static void modifyArray opening parentheses int opening and closing square brackets array closing parentheses opening curly brace. I'll set the second element in the array 1 to the value 2 closing curly brace. And let's call this from the main method, and I'll let that call before the last two output statements. ModifyArray, opening parentheses, myIntArray, closing parentheses, semicolon. What do you think is going to happen when we pass the reference type to the method? Well, the address is copied to a parameter. In other words, while this method is executing, we've got three references to the same array. Let's run this. And you can see from this output that the method changed our array. The simplest way to think of a variable is it's a way to store a primitive value, a value type, or it's a way to store a reference to an object. When we pass a variable to an argument, we're never really passing an object, or in this case the array, but only the reference or address to that object. And Java makes a copy of that reference, not a copy of the object, when it copies the method parameter. When we make changes using the parameter reference, we're making changes to the addressed object because we've simply got yet another copy of the address made when the method was called. The point of all this is really a word of caution. If you don't want the elements in your array to change, it's a good idea to pass a copy of your array to a method if you're not sure what that method might do. Later, we'll learn ways to pass immutable collections to methods so you don't have to worry about this behavior. But we can't do this with arrays. In the next video, we're going to look at another, more flexible way to pass elements to a method, both in an array and not in an array, so I'll see you in that next video. In the last couple of videos, we covered basic arrays. In this video, I'll be covering some related features. If you can believe it, I want to revisit the main method. Bear with me, there is a good reason for this. You probably have the structure of the main method memorized by now. Notice here, if you haven't noticed before, that the parameter to the main method is an array of string. This means we can pass an array of strings to this method when it's called. Or, if we use this method as the entry point to our application, we can pass data on the command line to this method. Up until now, I've only shown you this particular method's signature. But this signature can be written in a slightly different way. We can replace the brackets after the string type, which we know tells us this method will take an array of string. And we can instead replace that with 3 periods. This is a special designation for Java that means Java will take 0, 1, or many strings as arguments to this method and create an array with which to process them in the method. The array will be called args and be of type string. So what's the difference then? The difference is minor within the method body, but significant to the code that calls the method. Let's review this in code. I've created a project called var args with the main class and main method in the dev.lpa package. I'm going to change that main method to use the var args version for the parameter. And let's just print something out and confirm that works. I'll print the string literal hello world again. And running that, everything works as before, so this change isn't really evident to us using the main method as the entry point to the application. Let's create our own method that will print out an array of strings, each on its own line. Private static void print text opening parentheses string opening and closing square brackets text list closing parentheses opening curly brace. Using for each, we will cycle through the text list array and print T. Closing curly brace. Closing curly brace. This method takes an array of strings and prints each string on its own line using an enhanced for loop. I'll call this method from the main method. I'll come back and change the method's signature in a bit. Firstly though, now that we know about arrays, I also want to introduce you to a string method we haven't covered yet that you'll find super useful in the future. And that's the split method, which splits a string into a string array by whatever delimiter you tell it to use. String, opening and closing square brackets, split strings equals, double quotes, hello world again, dot split, opening parentheses, double quote, space, double quote, closing parentheses, semicolon. I'll call print text, passing our split strings string array. In this code, we have a string literal, which is just a hello world again sentence, and we're immediately calling the split method a string instance method. This method takes a string which can support regular expressions, which tells the method what the string should be split on. In this case, we're going to split by the spaces in the sentence. This means this string will get split into pieces, and the method returns an array of the parts, an array of string. You might remember we learned about the join method on string, which concatenated multiple strings together into one string. The split method has the opposite functionality. Let's run this code. And you'll see that we've got an array of 3 strings back, and these are printed out on separate lines using our method. Let's change our method that prints this array from accepting an array to accepting variable arguments for the string. And all we need to do is replace the brackets with 3 periods. And if we run that, we get the exact same result. So what's the big deal? The variable arguments parameter gives us a lot more options when we execute the method. Let's look at these. First, we already know we can pass an array to this method. But what's really neat is we can pass a simple string if we wanted to. System.out.println, opening parentheses, double quotes, underscore dot repeat, opening parentheses, 20, close both parentheses, semicolon. And I'll call print text again, passing the string literal hello. First, I'll just include a separating line here for clarity when we look at the output. Now notice here though, we're calling that same method, but we're only passing a single string. We're not passing an array at all. This code compiles and runs. And the method prints just hello, as you can see. I'll copy and paste those last 2 lines. But this time, I'll pass several strings to the method, again not as an array, just as arguments to the method. Instead of having to overload this method to take an array of string, a single string, 2 strings, or whatever, we have a single method declared. This feature lets us create one method to support multiple ways of calling this method. In fact, we can call this method with no arguments at all, so let's copy and paste those same 2 lines, but this time we won't pass anything as an argument to the method. And this code runs too. Now there are some restrictions on when you can use variable arguments as a method parameter. There can be only one variable argument in a method. The variable argument must be the last argument. Those rules are pretty easy to remember. You'll find that Java uses variable arguments in many methods contained in their library classes. In fact, the string.joint method itself uses a variable argument as its last argument, which is why the delimiter needs to be specified first. We showed you how to use this method with multiple strings, but it can also be used with an array of string, so let's look at that. I'll call our string array s-array and initialize it with 5 elements. And I'll print out the value returned from string.join. First, I'm creating a string array, and here I'm using an anonymous array initializer. It's called anonymous because the type isn't included, but Java can figure it out because it's being used in a declaration statement. Next, we print out the result of the string.join method with a comma as the first value and our array as the last argument. And we can run that. And we can see the output printing a single string of our elements, comma delimited. So that was variable arguments and using arrays as method arguments. Whichever you choose will depend on the other parameters in the method arguments list, as well as whether you want your users to have the ability to pass a variable list of elements versus just passing an array of elements. In the next 2 videos, I have 2 array challenges for you, which hopefully will solidify some of the topics we covered so far. This time, I'll have you create a couple of interactive programs using the scanner class, which we've used on several occasions. See you in the next video. Alright, it's time for another challenge. This is the minimum element challenge. Here's what you need to do. Write a method called readIntegers that reads a comma delimited list of numbers entered by the user from the console and then returns an array containing those numbers that were entered. Next, write a method called findMen that takes the array as an argument and returns the minimum value found in that array. In the main method, call the method readIntegers to get the array of integers from the user and print these out using a method found in java.util.arrays. Next, call the findMen method, passing the array returned from the call to the readIntegers method. Print the minimum element in the array, which should be returned from the findMen method. A tip here. Assume that the user will only enter numbers, so you don't need to do any validation for the console input. So pause the video, try out the challenge, and when you're ready, come back and see my solution. Pause the video now. Welcome back. I hope you managed to do well with that challenge. Let's go through my solution. I've already created a project called Minimum Element Challenge and a main class in the dev.lpa package, and I've already got the main method here. Let's now break this down into smaller pieces. First, we need to write the method readIntegers, and that has no parameters. So let's create that. I'm going to put that just below the main method and make it private because I don't want any other classes to access this method. Private static int opening and closing square brackets, read integers, opening and closing parentheses, opening curly brace. I'll create our scanner instance. Then print out some simple instructions and call scanner.nextLine, closing curly brace. In this code, we first create a scanner variable and we have a scanner instance because we want to prompt our user to enter a list of integers separated by commas. And then we'll read that data from the console by using the nextLine method from the scanner class. This code doesn't compile yet because it wants us to return an array, so we'll write the code for that next. If you recall, in the last video, I introduced you to a method on string called split, which splits a string and gives us an array of string. Let's use that method here. String, opening and closing square brackets, splits equals input.split, opening parentheses, double quotes, comma, closing parentheses, semicolon. Int, opening and closing square brackets, values equals new, int, opening square bracket, splits.length, closing square bracket, semicolon. And return our newly created array. Again, I'm not going to include any validation in this code to check if only integers were entered. I'll just take the input and split it by the comma because the challenge asked for a comma-delimited list of numbers. This is going to give us an array of string, but we really want an array of integers, so in the next line, I'm creating a new integer array and setting it to the same length as the number of values they entered. And then we return the array back to the calling method. This method compiles now, but the array we're returning is just full of zeros at the moment. Now we need to pass each of the strings into an integer and add each to the integer array. Remember, we can do that with the integer wrapper class and the parseInt method. I'll loop through our array and update the array, closing curly brace. In this code, we're using a traditional for loop to loop through the splits array we created and splitting the input by commas. For each value in the splits array, I'm passing it to the integer.parseInt method, as you can see on the right side of this assignment. Notice here that I'm chaining the trim method to that when I get the array element. Just in case the user puts spaces before or after the commas, we want to trim them off before parsing, otherwise parsing might fail. I'm going to assign that result to the same spot in my integer array because there should be a one-to-one correlation between these arrays. Again, there's no validation here other than trimming spaces. But if you went the bonus mile and added some in there, that's great. I'll build out our findMin method before we do any testing. You can write this method a couple of different ways. I'll start with the traditional way of getting a minimum value from an array. Again, I'll make this method private. The challenge told us to call this method findMin and wants it to take an integer array as an argument. Private static int findMin, opening parentheses, int opening and closing square brackets, array closing parentheses, opening curly brace. I'll assign the largest integer to min, closing curly brace. Here, we're starting by setting up a local variable called min and setting it to the highest number that an integer can hold. Now, we've used this value on the wrapper class previously in the minimum and maximum challenge earlier in the course. This field holds the maximum integer value an int can be. So why am I actually setting the min variable here to the maximum value that an integer can actually hold? We want to compare the first number the user enters to this number, and it's probably a good assumption that whatever the user entered will be less than this number. Another approach would be to set min to the first element of the array and then compare it with each of the others. The point here is that there are many different ways to code a particular challenge solution, but in any event, we've gone here with the max_value version for an integer. All right, so the next thing we now need to do is we need to cycle through the array and find the smallest number, the minimum value. We're going to create another for loop, but this time we'll use a for each loop. I'll add our for each loop. If opening parentheses, L less than min, closing parentheses, opening curly brace. Min equals L semicolon. Closing curly brace. Closing curly brace. And return the smallest number found. We know this loop processes every element in the array we specify to the right of the colon in the parentheses there. We're calling the loop element L for simplicity and for each element, we'll compare it to the min variable. So the first time in this loop, we'll compare whatever the user entered as their first number to the max underscore value, which we set min to. And it's highly likely the number will be less than the current min value, so we'll set the min value to the first value the user entered in this first iteration. After that, it will get changed only if another number is less than the first number they entered. Okay, so that's our find min method. So now let's run this code from our main method. Going back to the main method, we're going to put that on the line after our call to the read integers method. Int opening and closing square brackets returned array equals read integers opening and closing parentheses semicolon. Or print returned array via call to arrays.toString. Int return min equals find min opening parentheses returned array closing parentheses semicolon. Or print return min. To start with, I've set up an array event and called that variable returned array, and we'll assign that to whatever we get back from the read integers method. And then we'll just print that out and echo it back to the user. And then we'll pass that array to the find min method and assign that result to return min, which we then print. Let's try this out. And we get prompted to enter a list of numbers. I'm going to enter some numbers. I'll enter 8 numbers separated by commas. And we can see down the bottom there, it's got min equals 3. And since the number 3 is the lowest of all the numbers we entered, we know that our application is working correctly. Alright, so that was my solution to the challenge, and I hope you had a little fun with that. Maybe you came up with a different way to get the minimum value, like sorting the array first and then just getting the first element as one example. That's another good option, depending on the size of your array. The next challenge is very similar. In fact, we'll start with this code base for that challenge, so keep this project open and I'll see you in that next challenge. Let's do another quick challenge, and this one I'm calling the reversed array challenge. The challenge is to write a method called reverse that takes an int array as a parameter. The method is going to allow the array being passed to be method to be modified. As a result, this method shouldn't return any value. In the main method, call the reverse method and print the array both before and after the reverse method is called. To reverse the array, you have to swap the elements so that the first element is swapped with the last element, and so on. So for example, if the array contains the numbers 1 through 5, then the reversed array should be 5 down to 1. Alright, so that's it. See if you can figure that out. Pause the video now and try your hand at this challenge. Once you've completed it or get stuck, come back to see my solution. Pause the video now. Okay, welcome back. Hopefully you managed to finish that or give it a good go. Let's go through and try to solve this particular challenge together now. We need to start off by writing the reverse method. Before we do that, let's think about what we want to do conceptually. This shows the array before we start reversing the values and the end result we want to achieve. How would we go about doing this? We could start swapping the elements at positions 0 and 4 to get this interim result after the first iteration. Then swap the elements at the next positions, which we could describe as swapping the element at first +1 position with the element at the last -1 position. At this point, for a 5-element array, you'd actually be done with the reverse process. Notice the middle element never had to be swapped at all. This process would take only 2 iterations to complete for 5 numbers. It would take 3 iterations for 7 numbers, etc. We start with the outermost elements, swapping them, and work our way towards the center item. If the number of elements is odd, we can leave the middle element unswapped. We can think of the middle element as the pivot point. I'm going to use the project from the last challenge video, the minimum element challenge. And I'm going to add the reverse method to this code to reverse the elements. Within this method, we're going to use a for loop to go through the array elements. For each iteration of this loop, we're swapping 2 elements in our array, so we're doing 2 steps in 1 iteration. For that reason, we need to only go through half of the iterations we normally would. I've said we'll start swapping with the outer elements, so the first and last elements on the first round. On the second iteration, we'll want to add 1 to the index for the swapped item on the left and subtract 1 from the index for the swapped item on the right. our loop index will keep track of the left-sided element to be swapped. But we want to create another variable to keep track of the index position of the right-sided element we want swapped. This will start out with the index of the last element, so the array length -1, private static void reverse opening parentheses int opening and closing square brackets array closing parentheses opening curly brace. Int max index equals array.length -1 semicolon closing curly brace. The next variable will be called half length, which will represent half of the array length. Now, this is where it becomes tricky. We need to loop through the array and continue swapping until we get to the halfway point of the array. Remember, we're kind of working both ends of the array at the same time, so we only have to iterate for half the elements as I showed on the slides. Int half length equals array.length divided by 2 semicolon. As a recap, let's discuss why we're only looping through half of the array. The reason is we're swapping elements, so once we reach halfway, the second half of the array has already been swapped with the first half. As a result, there is no need to go further. Let's start generating the code for our for loop. I'll create the for loop using half length. Assign array element I to a temp variable. Assign array element at other end to array element I. And finally, assign the temp variable to the array element at other end. Closing curly brace. This code might be starting to look familiar by now. It's how we swap array elements. First, we move one element to the temp variable, then we set that to the element we want to swap it with. After that, then we can complete the swap by setting the second element to the value in the temp variable. When the index size is 0, we're swapping the first element, array position 0, with the element at array position 4 if we use our example from the slide. In the next iteration, I is 1, so we swap array position 1 with array position for -i, which is 4 - 1, which is position 3. Let's add a print statement to review what is happening. I'll print array via call to arrays.toString. Now let's call this method from the main method. First, I'll comment out the last 2 lines in the main method where we're getting the minimum value. Reverse, opening parentheses, returned array, closing parentheses, semicolon. I'll print returned array via arrays.toString. Okay, so I'll run this, and for the first time through, let's use the numbers from the slide. I'll enter the numbers 5 down to 1. And this code shows us the interim steps, so on the first iteration, we swapped 5 and 1 as we showed on the slide. And on the second iteration, we swapped the values 4 and 2, and that's all we really had to do. Let's try something a little more interesting, maybe a set with even numbers, to make sure the code works for both an even set of numbers and an odd set. I'll run this and enter the numbers 10 through 1 here. What this code shows is that we iterated through 5 times, and you can see the numbers being swapped each iteration. First from the outermost positions, then from the positions next to those, and so on. What this example showed, and which we've discussed, is that calling a method can change the value of your array elements, which this reverse method does. We can see the changes the method made on this array in the main method after the method was run. There is a name for this kind of method. It's called a mutating method, meaning it has impact on the calling code's data. This may or may not be a desirable effect. In general, it's probably not what you want to happen. I could have made a copy of the array in this method, so as to not change the array passed to the method. Let's do that. I'll write a new method called reverse copy to make it clear. This wasn't part of the challenge, but I just want to show you another approach. This code is actually simpler in some ways, but much less efficient since we're creating an entire new array in memory. And depending on how big your array is, this might not be behavior you want. I'll create the method signature for reverse copy. Now create a local variable array of the same length as the passed array. Int max index equals array.length -1 semicolon. Use it for each loop to cycle through the passed array, and save the element from the passed array into our local array. Closing curly brace. And return our copy of the passed array. Closing curly brace. This method is different right away because it's returning a new integer array. If you recall, the reverse method wasn't returning anything. The new method still takes an array as an argument. It creates a new array which has the same length as the one that's passed to this method. Next, the code creates a local variable which is the position of the last element to start with. Then it loops through the elements using the enhanced for loop, and the code populates the reversed array, setting the last element in the new array to the first element in the array passed to this method. And here we use a post decrement operator, the minus minus, which decrements this variable. The first time through, max index is the last index, and so the reversed array's last element is populated with the first element in this loop. Only after max index is used to access the last element of reversed array does it get decremented. To be clear, the decrement of max index occurs after the assignment is completed. This is why this operator is called a post decrement operator. The decrement happens after any expression this operator may be participating in is evaluated, as we show here. Okay, let's run this by adding a call to this method in the main method. I'll first comment out the code we were using to call the reverse method. Int opening and closing square brackets, reverse copy equals reverse copy opening parentheses, returned array closing parentheses, semicolon. Print out returned array via arrays.toString. And same thing, but this time for reverse copy. The code will call the new method reverse copy, passing in the array we get from the console. Then we'll get that reversed array back from the method, and we'll print both our original array and the reversed array. So running this code, and now you can see the reverse copy method isn't a mutating method anymore, meaning the original array didn't get changed. This method had no effect on the array we passed to it. Instead, it returned a copy with the elements reversed. Alright, so that's it for this challenge. I hope that looping logic made sense. In the next video, we'll be looking at Java support for arrays that contain arrays, so I'll see you in that next video. In the last few videos, we've discussed arrays and variable arguments which store values of the same type. In this video, we're shifting gears to talk about multi-dimensional arrays and how Java provides support for them. I briefly mentioned before that an array element can actually be an array. It's known as a nested array or an array assigned to an outer array's element. This is how Java supports 2- and 3-dimensional arrays of varying dimensions. A 2-dimensional array can be thought of as a table or matrix of values with rows and columns. You can use an array initializer for this, which I'm showing on this slide. Notice the 2 sets of square brackets on the left side of the assignment in the declaration. Using this type of declaration tells Java we want a 2-dimensional array of integers. Here we show the same declaration with array initializers that mean the same thing. The first example just uses white space to make it more readable. In this example, all the nested arrays have the same length. The 2-dimensional array doesn't have to be a uniform matrix though. This means the nested arrays can be different sizes, as I show with this next initialization statement. Here, we have an array with 3 elements. Each element is an array of integers, a nested array. Each nested array is a different length. If you find that confusing, don't worry. It should all make sense shortly. You can initialize a 2-dimensional array and define the size of the nested arrays as shown here. This statement says we have an array of 3 nested arrays, and each nested array will have 3 ints. The result of this initialization is shown in the table on this slide. Java knows we want a 3x3 matrix of ints and defaults the values of the nested arrays to zeros as it would for any array. You can initialize a 2-dimensional array without specifying the size of the nested arrays. Here, we're specifying only the outer array size by specifying the length only in the first set of square brackets. We've left the second set of square brackets empty. The result of this initialization is an array of 3 null elements. We are limited to assigning integer arrays to these elements, but they can be any length. We'll be looking at this in code in just a bit. I want to just cover a couple more points first. There are a lot of ways to declare a 2-dimensional array. I'll just cover the 2 most common ways here. The most common, and in my opinion, clearest way to declare a 2-dimensional array is to stack the square brackets as shown in the first example. You can also split up the brackets as shown in the second example, and you'll likely come across this in Java code out in the wild. Now let's get back to some code. I've created a new project called multiple arrays. I want to start with a simple two-dimensional array in the main method. Int square brackets, array2 equals new int for in square brackets, semicolon. Okay, so here I'm using two square brackets after the primitive type int and naming the array variable array2. This instantiates an array that has 4 elements. Each element in the outer array gets assigned a nested array with 4 elements, each an int, with a default value of 0. I'll print out the value returned from a call to arrays.toString passing array2, and print out array2's length. And if we run this code, we can see the length of array2 is still 4, but when we use the arrays.toString method, we see 4 elements printed. You might remember this onLooking printout, which is really the result of just calling toString on an integer array without using the helper class method. We would get this if we printed out each element in the array individually, so let's do that next. Define our for each loop. Print outer, closing curly brace. In this code, I'm using the for each loop, but notice what our loop element is. It's an array of integers. This loops through the outer array, and each element is an array of 4 integers. And if we run this, we get similar output to before, but now each array is printed on its own line. But if we change the code, and instead of just printing each loop element, which we know each is an array, we can pass it to the arrays.toString method instead. System.out.println, opening parentheses, arrays.toString, opening parentheses, outer, close both parentheses, semicolon. And running this code, we can see each nested array gets printed. And we can confirm now that each of the elements in the nested arrays is initialized to zeros. You can print all these elements out using a nested for loop. Let's do that next, because you'll probably see code processing nested arrays like this a lot. Add a for loop for array2. Assign inner array to array2 element I, closing curly brace. This loop should look familiar. We're going through the loop, which in this case we use to traverse the outer array using the I index. We'll loop from 0 to 1 less than the length of the array, and right now we're not doing anything except assigning each element to a variable in the loop we called inner array. Here I'm using var as the type because the JVM can infer the type of our elements, which in this case is an integer array. Next, I want to loop through the elements that are in each of these nested arrays. Add a for loop for inner array. Print array2 element I, j, with a space, closing curly brace. And a call to println to take us to the next line. We are looping through the inner array's elements using a nested for loop and a different loop index, j. And j starts with 0 because arrays are always indexed, starting at 0. We'll print each element using the indices for the outer loop and the inner loop. Let's quick look at what we're really doing here with the help of a slide. When we access a one-dimensional array element, we do it with square brackets and an index value. So this code sets the first element in the array to 50. To access elements in a two-dimensional array, we use 2 indices, so this code sets the first element in the first array to 50. This next code sets the second element in the second array to 10. The code on this slide is similar to the code we have in our class using nested traditional for loops. In this case, we're not using any local variables, but accessing array elements and variables directly. This table shows the indices which are used to access the elements in the two-dimensional array in our code sample. When we loop through the outer loop, we're accessing each row of elements. We've highlighted the first row, which would be the elements accessed when I equals 0 for the outer for loop. When we loop through the inner loop, we're accessing each cell in the array. The cell in this matrix can be any type. In our code, each is an integer value, and we know they've all been initialized to 0. Now getting back to our code, we've learnt that we can use nested for loops with indices to print each of our elements. We can use for each loops as well, so let's add code that does the same thing, but with the enhanced versions. First I'll comment out the traditional for loops, then I'll add some new code. 4, opening parentheses, var outer, colon, array2, closing parentheses, opening curly brace. 4, opening parentheses, var element, colon, outer, closing parentheses, opening curly brace. I'll print element and add a space after it, closing curly brace. And I'll add a call to println to take us to the next line, closing curly brace. Let's talk about this. I've said the enhanced for loop can take and erase the right-sided component, and here we use our two-dimensional array, array2. On the left side of the colon, in the parentheses of this for loop declaration, we're setting up the element we're looping over. In this case, it's a one-dimensional int array, and we're going to call the local variable outer in this loop. And again, to make our jobs easier, we don't have to declare the type because Java can infer it if we use the var keyword. Next, we nest a second for each loop, which will loop through every integer in our matrix of data. We use the outer variable now as the right-sided component in the loop declaration. The for loop variable in this nested loop, which we're calling element, is simply an int, but again, we'll just use var here. And we're just printing each element out with a space between the elements, and in between rows, we'll add a new line. We want that after the inner loop completes, but in the outer loop. And running this, you can see that it gives us the same output as before, but the output is a bit easier to read. We already know we can use toString on the arrays class to print out a nicely formatted one-dimensional array. As it turns out, the arrays class provides us with another method to print multi-dimensional arrays called deep2string. Let's comment out our last for loop again, and this time just print out our array using this one method. I'll call arrays.deep2string, passing array2, and print the value returned. And if we run that, we can see our two-dimensional array printed on a single line. Here you can see the outer square brackets, which represent the outer array, and the inner brackets each mark the inner arrays. So now, let's actually assign some values to our two-dimensional array, something other than zeros. And we'll do this, again, with the traditional for loops, because we need to use indices when assigning values. We'll uncomment the code we had, lines 17 to 23, but then comment out the toSystem.out.print statements. Next, we'll insert a statement in the nested for loop. Array2, opening square bracket, I, closing square bracket, opening square bracket, j, closing square bracket, equals, opening parentheses, I, times, 10, closing parentheses, plus, opening parentheses, j, plus, 1, closing parentheses, semicolon. So what is this doing? Let's just run that code because it's easier to explain it after we see the results. Each iteration of the outer loop index gets multiplied by 10 and the inner loop index gets added to that plus 1. This was just one to show you how you can assign a different value to every element in a two-dimensional array using nested for loops. Let's end this video here. In the next video, we'll move from a two-dimensional spreadsheet example of nested arrays to a much messier but more versatile construction of nested arrays. In the last video, all of our examples of two-dimensional arrays, our second level of arrays, all had the same size. In our code sample so far, all of the nested arrays were arrays with 4 elements. But in Java, I've said previously, we don't have to do this. There's no requirement that the nested arrays be any particular size or even have any values at all. In fact, even though we've initialized this array as a 4x4 matrix of integers, we're not restricted to staying with that. We can actually assign any array of integer to one of the outer array's elements, and I'll demonstrate that now. I'll assign array 2's second element to a new array containing 3 elements. Now I'll print the value returned from a call to arrays.deep2string for array 2. On this line, we set the second element of the outer array to a new integer array. Here, we're using an array initializer with new, int, and square brackets, and then a list of different values in curly braces. Now notice there's only 3 elements in this array. This code compiles without issue. And if we run it, we can see that we still have an array of 4 arrays, but now our second nested array is a list of 3 integers, 10, 20, and 30. One other thing I want to point out with this code is that we can't use an anonymous array in this assignment. What do I mean by that? Let's see what happens if we remove the new square brackets in that last assignment. And you can see IntelliJ is flagging that as an error that an array initializer can't be used there. This means we need the array creation part of the code, in other words the new int and square brackets. Let's undo that last change. Now, this concept of nested arrays may be confusing. As a result, I want to spend a bit of time reviewing this so it becomes clearer. When we declare multi-dimensional arrays, the declared type can itself be an array, and this is how Java supports two-dimensional arrays. We can take that even further. The outer array can have references to any kind of array itself. In this example, we have an outer array with 3 elements. The first element is itself a single-dimension array. The second element is a two-dimensional array. And lastly, the third element is a 3-dimensional array. The easiest way to examine this multi-dimensional aspect is to create an array of object, as I showed on the last slide. I've said everything can be referred to as an object, including arrays themselves, so I'll use this to help you to understand how Java implements arrays simply as nested arrays. Set up our object array with 3 non-initialized elements. And finally, I'll print the value returned from arrays.toString passing our array. In this code, we're creating an array of 3 objects in the first statement. And we're just going to print that array out. I'll run the code. You can see we have an array of 3 elements and they are all initialized to null. Now, we can really assign anything we want to any of these 3 elements, including in an array, so let's do that. I'll assign element 0 in our array to a new string array and print the value returned from a call to arrays.deep2string. We're assigning the first element of our array at index 0 to a string array which has 3 elements. And running this, we can now see that we have a nested array and that we've nested the ABC string array in our outer array. At this point, you could say we have a 2-dimensional array. But let's keep going with this. Let's set element 2 of our array to a 2-dimensional array, adding the numbers 1 through 9 as separate strings. Closing curly brace, semicolon. And let's print out any array, again via that same call to deep2string. So here, we're saying the second element of our outermost array is a 2-dimensional string array, and we're using an array creation expression with an array initializer. We have 3 string arrays in this 2-dimensional array, and this is being assigned to the second element. At this point, we've made this outer array, any array, a multi-dimensional array in which the dimensions are different now for each element. And we can run this code and see that. Finally, I'll initialize the last element. I'll assign element 3 to a 3-dimensional array, and another print of any array using arrays.deep2string. This last element, our third element of the outer array, is being assigned a 3-dimensional initialized array of 2 by 2 by 2 ints. Okay, so let's run this. So this is a bit hard to look at and figure out which arrays are nested in which. We'll print these nested arrays by using a for each loop. For, opening parentheses, object, element, colon, any array, closing parentheses, opening curly brace. I'll print element.getClass.getSimpleName, print element, and call arrays.deep2string, closing curly brace. Notice, in this particular for each loop, we're using object as the type of our element in the loop declaration. First, we print out the class name of each element in this array. Second, we print out the toString representation of each array element. And then we want to print out each element contained in this multi-dimensional array. Now, we happen to know that each element is an array, but the Java compiler doesn't know that. The arrays.deep2string method takes an array, so we need to cast our element to an array of object before we pass it to this method. Now, if we'd assigned something other than an array, this would break the code, but we didn't. We'll talk more about this issue later. Running this, we can see each type printed out. So the type for the first element, the element type is string with a single pair of square brackets. The second element is a 2-dimensional string array. And the last one is a 3-dimensional integer array with all its values set to the default 0. And we can also see the elements printed out in each case. In general, it's not good practice to create object arrays like this. This is because the compiler won't do any type checking, meaning anything can be assigned to this outer array, and this code wouldn't work if we simply assign a string to any array 2 as an example. Let's just do to see what happens. I'm going to comment out that line with any array 2 and type in a statement below that. I'll assign element 3 to a string literal hello. Now, with this change in place, the arrays.deep2string method still works, the one that we call immediately after that. But the call to the deep2string in the for loop will give us an exception if we run it. We're trying to cast something that's a string to an array of object, and we can't do that. When using arrays, you should really stick to more strictly typed arrays as a general rule. This will prevent any calling code from inserting object types that you don't expect and can't handle, just like we did here. But we'll revert that last change, removing that new statement and uncommenting the previous statement. And we'll end this video here, which is also the end of this section. Java supports two-dimensional and multi-dimensional arrays with the concept of nested arrays, as we've shown you in the last several videos. An array can be an array of primitive data elements, an array of any type in Java, or simply an array of object, which is the most generic class you can declare anything to be. In the next section, we'll be looking at different types of list classes. These classes differ from arrays because they can be resized, but they also don't support primitive data types. I'll see you in the next section.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome to the list section of the Java Masterclass. In the last section, I talked about the array as a way to manage a list of items all having the same type. Arrays were a massive improvement if you needed to store items of the same type, but as you saw, arrays have some limitations. Not being able to change the number of elements in an array being one. Fortunately, Java also includes an entire library for Java containers, which they call collections. They take the arrays we worked with to the next level. They allow you to change the number of elements defined in an array for one, but there are many other improvements as well. In this section, we'll be talking about lists, which are Java containers, and explain what they are and how to use them. Two of the most common classes for lists are ArrayList and LinkedList. We will start by looking at these. In addition, I'll be covering important concepts related to these topics, like big O notation, iterators, autoboxing and unboxing, and the enum type. If you are unfamiliar with any of these terms, by the end of this section, they will make sense. There's a lot to cover in this section, so let's get started. We've spent quite a few lectures now discussing arrays in Java. An array is mutable, and we saw that we could set or change values in the array, but we could not resize it. Just like the string builder class provides a resizable way to handle text, Java gives us several classes that let us add and remove items and resize a sequence of elements. These classes are said to implement a list's behavior. So what is a list? Intuitively, we all know what a list is. In our everyday life, we use lists all the time. When we go to the grocery store, we've got a list. We have a list of things we need to do, a list of addresses, a list of contact numbers, etc. It wouldn't be a very useful list, however, if we started with 10 items we could change, but never add or remove an item. A list is a special type in Java called an interface. We'll have a whole section on interfaces coming up in the next section of this course. For now, I'll say list interface describes a set of method signatures that all list classes are expected to have. Let's look at some of these methods. I'm going to pull up the list methods in Java's API. Some of these methods may even remind you of some of the methods we saw on the string builder class. You can see the methods add, contains, index of, and last index of, for example. But there are many more, as you can see. These are methods available on any class that uses a list interface. A class can use or implement an interface, which means it agrees to have the methods that the interface describes. If I scroll to the top of this page, you can see the names of the classes that use this interface. Abstract list, array list, copy on write array list, linked list, stack, and so on. Of these classes, the ArrayList is probably the most commonly used class here and is the one we'll focus on next. So what the ArrayList is, it's a resizable array. And if I scroll down and look at the methods, they look just like the methods we saw on list. This means we can say an ArrayList implements the list's interface methods. The ArrayList is a class that really maintains an array in memory that's actually bigger than what we need in most cases. It keeps track of the capacity, which is the actual size of the array in memory. But it also keeps track of the elements that have been assigned or set, which is the size of the ArrayList. As elements are added to an ArrayList, its capacity may need to grow. This all happens automatically behind the scenes. This is why the ArrayList is resizable. What I'm going to do now is create some code and walk you through a demonstration using an ArrayList to manage a grocery list. I've created a new project called ArrayLists. In the main.java source file, I want to create a record called grocery item. If you remember, we can do this using the type record instead of class, and at its simplest, we pass the fields we want on the record in the declarations parentheses. Record, grocery item, opening parentheses, string, name, comma, string, type, comma, int, count, closing parentheses, opening curly brace. Closing curly brace. Okay, that's our grocery item record with 3 fields, name, type, and count. But let's say 9 times out of 10, we'll have a count of 1, so we want a simpler way to create one of these records. We can add constructors to records, so we'll do that now. Public grocery item, opening parentheses, string, name, closing parentheses, opening curly brace. This opening parentheses, name, comma, double quotes, dairy, comma, 1, closing parentheses, semicolon, closing curly brace. This constructor takes only one field, the grocery item name. For a record, we have to call the generated default constructor first with all 3 fields. Here, we call this and pass the name. Making it all uppercase, I've set the type for now to dairy and the count to 1. Now I'll go to the main method and create an array. I'm next going to do what I told you not to do previously, which is create an array of object. You'll understand why I'm doing this shortly. Object, opening and closing square brackets, grocery array equals new object, opening square bracket, 3, closing square bracket, semicolon. Grocery array, opening square bracket, 0, closing square bracket, equals new grocery item, opening parentheses, double quotes, milk, closing parentheses, semicolon. Grocery array, opening square bracket, 1, closing square bracket, equals new grocery item, opening parentheses, double quotes, apples, comma, double quotes, produce, comma, 6, closing parentheses, semicolon. Here, I have a grocery array, and I've set it to a size of 3, meaning we can only have 3 items in this array. And we're assigning the first 2 elements to instances of our new grocery item record using the explicit one-argument constructor I declared and the default implicit constructor. The first instance only takes name, and the second one takes type and count as well. I'm going to add another element to this array, and then I'll print this array out. Assign the string 5 oranges to element 3 of grocery array, and let's print out grocery array using arrays.toString. Here, I've set the element to a string and not a grocery item at all. And because I've said we have an array of objects and not an array of grocery items, the compiler isn't going to prevent us from doing this. Any code now that expects this array to contain only grocery items might have a problem processing this data. But I'll run this. As you can see, for our grocery items, we also know what department we might find that item in, but in the case of the string, it just prints 5 oranges. We could easily fix this, in this case, by making the array an array of grocery item, so I'll change this code, improving it. I'll change the array from an array of object to an array of grocery item. You'll notice right away that now the compiler won't let us just assign a string to the third element of this array. We need to change that and properly set it to an instance of a new grocery item. Grocery array, opening square bracket 2, closing square bracket equals new grocery item, opening parentheses, double quotes, oranges, comma, double quotes, produce, comma, 5, closing parentheses, semicolon. And the compiler is happy with that change. Declaring your arrays with a specific type allows compile time type checking, as we've shown in this case. Type checking at compile time prevents runtime exceptions when instances assigned to arrays aren't what they are expected to be. Okay, so now I'll create a grocery list using the ArrayList class instead of an array. I'll create and initialize a new array list called objectList. Now, we don't have an error, but what I want you to notice straight away is that IntelliJ is highlighting the ArrayList class in yellow, which is its way of warning us about something. If I hover my mouse over that class, IntelliJ gives us the message raw use of parameterized class ArrayList. So what does that mean? Well, in truth, it's a lot like the example we just walked through with the array of object. If we don't specify type with an ArrayList, it's going to use the object class by default. This is called the raw use of this type. And this will result in the same problems we saw when we had an object array, meaning any object at all could be put in this array list. I'll type that in. I'll add a new grocery item object set to butter to object list, and add a string yogurt to our object list. Here, we're adding elements using the add method on ArrayList. First, we add a grocery item, but we're also adding a string with this second add statement. And like we had before, the string may not be what the code wants or is expecting. And that's generally not behavior we want. When you declare an array list, you probably know what data you want in that list. In our case, it's a grocery item record, and we don't want anything else but grocery items in the list. So how do we specify type for an array list? I'll add a new declaration, then I'll talk about it. Array list, less than sign, grocery item, greater than sign, grocery list equals new array list, less than sign, grocery item, greater than sign, opening and closing parentheses, semicolon. So here we've used the less than and greater than signs, also called angle brackets, and we've specified the type. This is the type we want all elements in this list to be a grocery item record. And we've included this type immediately following the ArrayList class in the declaration of the variable on the left. We've also specified this in the instantiation of this list on the right of the assignment operator or the equals sign. Now, I'll hover over that second grocery item class on the right side of the assignment in IntelliJ. And notice here that IntelliJ is telling us this second reference to grocery item, which is called an explicit type argument, is unnecessary. In this case, I'll use IntelliJ's recommendation and change this by selecting replace this when I hover over that second set of angle brackets. And that gets replaced with empty angle brackets. These angle brackets, when empty like this, are also called the diamond operator. Later, we'll be talking about type arguments in a lot of detail when we review generics, but right now, you should try to type your array lists as I show here. With this declaration, the compiler can do compile time type checking because we've specified that we only want grocery items in our grocery list. I'll copy the two lines we used above and paste them here, changing the name of the array to grocery list in both statements. And now you can see the compiler won't let us add a string object to this list. If we hover over that, we see that grocery item is the required type. I'll remove that last line of code. Now, the other thing you might have noticed in this statement where we're creating a new array list is we never specified a size for the list. An array list is a resizable array implementation, meaning it's not a fixed size, so we don't need to specify the number of elements it will have. It will grow automatically as needed. I'll end this video here. We've talked about a few of the similarities and differences between a Java array and the ArrayList class in the java.util package. In the next video, we'll get to know the ArrayList class better. In the last video, I started with declaring and initializing an instance of java.util.ArrayList. I showed you how to create what Java calls a raw version of the ArrayList, which simply means I didn't use a type argument in the declaration or the creation of the ArrayList object. It's common to find the raw version of the ArrayList in older legacy Java code. In general, you want to include a type argument when using the array list. Before I start reviewing other methods on array list, I want to revisit a very common mistake that can be made using array lists. Remember in the last video when I said that you should declare an array list with a type argument as we did in this code using grocery item. These angle brackets, by themselves, called the diamond operator, can be used when Java can infer the type, as it can in this declaration and assignment statement. But if we forget the diamond operator, in the instantiation part of this statement, we'll get another warning from IntelliJ about the raw use of a parameterized list. Hopefully, you remember this means the compile time type checking won't occur, so without using the diamond operator, we'd be allowing other types to be potentially included in this array list. If I remove the diamond operator, you can see IntelliJ warning us about this problem. Okay, so I'll revert that last change. It's a good idea to pay attention to IntelliJ's warnings and to resolve as many as you can, because IntelliJ encourages best programming practices in many cases. Ideally, you want to aim to remove all IntelliJ warnings. In many cases, IntelliJ can actually fix the problem for you if you don't want to know how to do it yourself. You saw my apply an IntelliJ fix in the last video. In this code, from the last video, I used the add method without actually discussing it. This is the simplest form of the add method, which adds an element to the end of the list. Let me print our grocery list out now. For an array list, we can simply use system.out.println, passing the array list instance, so that's nicer than having to use a helper class as we did with the array. I'll print out grocery list, and when I run that, this prints out our list, which has one grocery item. I'll add a few more items to the list. I'll add a milk grocery item. And I'll add an oranges grocery item. And running that, we get all three items in our list printed, butter and milk, both in the dairy department, and oranges in produce. And now I'll add apples, but let's say we want apples to be first in the list. We can use an overloaded version of the add method for that. I'll use that again, but we'll specify an index number for apples. This version of add takes an index as the first argument. What we're saying is, instead of adding this new item to the end of our existing list, let's actually add it at index 0, moving all the other elements down. Before I run that, I'll simplify how the record gets printed out. Under our grocery item record, I'll add my string method to this record. At override. I'll type this manually instead of using IntelliJ. I'll format the return string, closing curly brace. I'm overriding the toString method and returning a formatted string using string.format that has three specifiers. The first specifier is for an integer, the count, and then we have two string specifiers for the name which we want to be uppercase and type. And if I run that, we see that 6 apples in produce was added as the first list item, and the output is a bit easy to read. If instead of the add method, I use the set method, instead of inserting the apples, set will replace the first item, butter, with the apples, so I'll do that next. And running this code, you see we have replaced the butter item with 6 apples. We can also remove an item by index, so if we wanted to remove milk from our list, we could pass one, which means the second element. Like arrays, array lists also start with an index of 0. I'll remove the second element from grocery list, and running this, we can confirm we've removed milk, the second item from the list. For the next set of methods we'll be looking at, I want to create a new class in the dev.lpa package named moreLists as the name, and I'll add the main method. In this code, I want to start with a string array with some groceries we might buy. I'll type in some code, and we'll talk about this shortly. I'll create a new string array called items with 4 elements, apples, bananas, milk, and eggs. I'll use list.of to return a list of strings. Then I'll print out our list. First, we have an array of string with 4 strings in this array. Next, we're using a method on list, which is a factory method. We've talked about factory methods previously. This is when we call a static method on a class and it returns a new instance of a class for us. And here we're calling a static method on list, simply called of, and that returns a list of string elements back. And we're assigning this to a list variable. Notice we're using the type argument string on the left side in the declaration of this variable. Now list is not array list, and there's a reason why I'm not assigning this to an array list of string. And that's because the object coming back from this method isn't actually an array list. We'll talk about what this is in just a minute, but let's see what we get when I print this list object out. Running this, we get a nicely printed list of our array items. So this method transformed an array of string to a list of string. Let's explore this a bit more and see what kind of object we're getting back from this static factory method. I've shown you previously that we can do this by calling getClass and then chaining getName to that. Let's print out list.getClass.getName. The getName method gives us a little extra information than getSimpleName, which we've seen before also. And running this, we learn that this list is something called java.util immutable collections $list_n. Okay, so what is that? Well, the list we're getting back is of type list_n, and it's a nested class within the immutable collections class, but most importantly, it's immutable. And don't worry, we'll be talking about nested classes in a few sections of the course. Alright, we can test this by trying to add an item to this list. I'll attempt to add the string literal yogurt to our list. If we try to run this code, we get an exception, an unsupported operation exception. So why would I show you a method to get an immutable list? Well, as it turns out, this method can be used in the creation of an array list to make populating the array list a bit easier. Let me show you that here next. I'm going to remove those last two lines of code I added. Array list, less than sign, string, greater than sign, groceries equals new, array list, less than, greater than, opening parentheses, list, closing parentheses, semicolon. I'll add the string literal yogurt to groceries and print out groceries. Here, we're creating an array list of string using the variable groceries and assigning a new instance of the array list to it. And notice the diamond operator there. I could have included the type string in there, but it's not required, and this is simpler to read and write. And now look, we're calling a constructor on array list and passing an argument, the list we created above. The result of this instantiation is a new mutable array list populated with the elements from the immutable list we passed. And to prove this list is mutable, I'll add a new element, yogurt, and print groceries out. Running that, we get the 4 items we had plus yogurt in the output. Looking back at the list.of_method, it's overloaded and supports different versions, including variable arguments, which we talked about in a previous video. I'll simplify this code and create a list with specified elements all in one statement. Let me show you what that looks like. Array list, less than sign, string, greater than sign, next list equals new, array list, less than, greater than, opening parentheses. List.of, opening parentheses, double quotes, pickles, comma, double quotes, mustard, comma, double quotes, cheese, close both parentheses, semicolon. Then print out next list. In this code, we create a new array list, and this time we can just pass a list of strings to the static method on list, list.of, and we put that in our constructor parentheses as shown. This is one way to create and populate a small array list in one statement with a few known elements. Let's keep looking at ways to add elements. There is another method, add_all method, on array list which takes any list as an argument. I'll use this next. I'll use a call to add all on groceries passing next list and print out groceries again. Here, we're adding everything in our second list to our first list with the add_all method and passing next list to it. And when I run that, you can see our groceries list now has 8 items in it. All the elements in next list were added to our grocery list. Since this video is getting a bit long, let's end it here. In the next video, we'll look at removing elements and sorting, as well as making copies of our list. I'll see you in that next video. In the last couple of videos, we created array lists, but not a lot else. Now it's time to do something with them. First of all, you can retrieve an element in an array list by its index, much like the way we reference an array element by its position in square brackets. But for an array list, we use the get method, not square brackets. I'll show an example of using the get method to print out the third element in our list. System.out.println, opening parentheses, double quotes, third item equals, plus groceries.get, opening parentheses, 2, close both parentheses, semicolon. Like arrays, array lists start with a 0 index position, so the third element is at index 2. This code simply prints out third item equals milk. Next, let's talk about searching for an item in the list. The array list provides several methods to help us do this. First, there is the contains method that returns a boolean, returning true if it finds a match. Make a call to .contains to check if mustard is in the array list. Print out a string literal if it does. Closing curly brace. And if I run that, we get the message, this contains mustard, printed out. This method will work for many of Java's built-in classes, like string, because it ultimately calls the class's overridden equals method. We'll look at this more for our own classes in later lectures. We can also use the indexOf method and the last indexOf method. These methods return the index position of the element in the list if it finds it, instead of just returning true or false. These methods return -1 if the element isn't found in the list. Array lists can have duplicate elements, so I'll add yogurt to the list even though it's already there as the fifth element. I'll print out groceries.indexOf for yogurt, and I'll also print out last indexOf for yogurt. And running this code, we see that the indexOf method found the first instance of yogurt at index 4, and the last indexOf method found the yogurt element just added at the end of the list at index 8. In addition to finding elements, we have several methods we can use to remove elements from a list. We can remove by index if we know it, or we can remove by the element's value. Print out groceries. Remove element 2 from groceries. Print out groceries again. Call remove on our array list. And print out groceries for a third time. First, I'm printing the full list out before I'm removing anything. Then I remove the second element in the list by passing the int value 1 to the remove method. And I then print our list again. Finally, I'll remove yogurt from the list if a match is found and print the list again. When I run this code, you can see that bananas, the second element, was removed. And then we remove yogurt, but notice only the first yogurt element was removed, so this remove method only removes a single element. In addition to removing one element at a time, we can also remove a set of elements. Call remove all, passing a call to list.off. And I'll print out groceries again. So again in this code, we're using the static method list.off to create a temporary list from a variable arguments list of elements. These are the elements we want removed, so if I run this code now, our list no longer contains apples or eggs. Another method that might remove elements is called retain all. This method's functionality is opposite to that of the remove all method, but since it potentially removes elements from a list, let's look at it next. I'll add a call to this method with a set of items. I'll call retain all, specifying the elements I do not want deleted. And I'll print out groceries to check the result. I'm using list.off again, passing for grocery items. This list gets passed to the retain all method called on our groceries list. And this method removes every item in the grocery list, which isn't one of the items passed in the argument. After executing this method, our list should only contain 3 items: milk, mustard, and cheese. Before this call, our list didn't include apples, so that element is just ignored here. So this really means we're left with just milk, mustard, and cheese. Finally, we can remove all the elements from a list with the clear method. Groceries.clear, opening and closing parentheses, semicolon. I'll print groceries. Print out the value of is empty on groceries. This code clears all elements in the list and we'll print that out to confirm it. And while we're at it, we call another method on list called isEmpty, which returns true if the list has no elements in it. Running this code, we get the output, square brackets with no elements listed, and is empty equals true. Now, I'll add some elements back to this empty grocery list using the add-all method. I'll call it twice and pass it lists from two factory methods, the one on list we've used several times, but also another that's on the arrays helper class. I'll call add-all, passing a list created by list.off. And same as above, but use arrays.asList this time. By now, the first statement should be starting to look familiar. I'm using the static method list.off with a variable list of strings, then passing that result to the first call to the add-all method on our groceries array list. Like list.off, opening and closing parentheses, arrays.asList takes a variable argument list of elements and produces a list, and we can pass that list to our second call to groceries.addall method. After executing these methods, we'll have 8 elements in our list. Now that we have data again in the array list, let's sort the elements. ArrayList has a sort method, so I'll just call it on groceries. Print out groceries. Groceries.sort, opening parentheses, comparator.naturalorder, opening and closing parentheses, semicolon. Print out groceries again. Again, we want to print the grocery list first before we sort it. Next, we call the sort method on the list. This method has one argument, which is a type called comparator. This special type allows instances to be compared to one another. We're going to be talking a lot more about comparators when we talk about interfaces. For now, this method requires one, and Java provides the one we need with a static factory method on the comparator type called natural order. We call it and pass the result directly to the sort method argument list. This object allows array lists with types that have a natural order to be sorted. Strings will be ordered alphabetically from A to Z, for example, and numbers will be ordered from smallest to largest. Running this, we can see our grocery list gets sorted as we'd expect. We can also call the reverse order static method on the comparator type to sort in reverse. I'll call reverse order this time. Print groceries. Running that. Our groceries are now printed in reverse alphabetical order. Okay, so we've looked at 2 ways to transform arrays or variable arguments into list. Now, let's go the other way, getting a list from an array with a different method on ArrayList. This is an overloaded method, appropriately called toArray. For the sake of time, I'll show you the most commonly used version, which takes a typed array as an argument. This method will return an array the same size as the array we passed to it and of the same type. Call to array, passing a new string array. I'll print out the value returned from a call to arrays.toString, passing our grocery array. So here, we're passing a new string array to the toArray method, which is initialized to the type and size we want the returned array to be. In this case, we want an array that has the same size and type as our list. This method then returns an array of string. There may be times you might want to pass your data as an array to methods that accept arrays rather than lists, as an example. Here we simply pass the array to the arrays.toString method and print the array out, which we know takes an array as an argument. Okay, so that was a pretty fast review of a lot of methods on list which were implemented for the ArrayList class. In the next video, we'll review what we've learnt so far, or comparing the array and the ArrayList side by side. We've covered a lot of ground on arrays and ArrayLists. This feels like a good place to pause and review these two side by side. This slide demonstrates that arrays and ArrayLists have more in common than they don't. Arrays support primitive types, but ArrayLists don't. ArrayList supports primitive wrappers. Both are indexed and ordered by that index. Both allow duplicate values and null values. Both inherit from java.util.object and are mutable. An array is not resizable, but the ArrayList is, and I've talked at length about the many methods implemented by ArrayList. On this slide, I show the differences when creating a new instance of an array compared to a new instance of an ArrayList. An array requires square brackets in the declaration. In the new instance, square brackets are also required with a size specified inside. An ArrayList should be declared with the type of element in the ArrayList in angle brackets. We can use the diamond operator when creating a new instance in a declaration statement. You should use a specific type rather than just the object class, because Java can then perform compile time type checking. You can use an array initializer to populate array elements during array creation. This feature lets you pass all the values in the array as a comma-delimited list in curly braces. When you use an array initializer in a declaration statement, you can use what's called the anonymous version, as I show here. You can use an ArrayList constructor that takes a collection or a list of values during ArrayList creation. The list.offer method can be used to create such a list with a variable argument list of elements. The number of elements is fixed when an array is created. We can get the size of the array from the attribute length on the array instance. Array elements are accessed with the use of square brackets and an index that ranges from 0 to 1 less than the number of elements. The number of elements in an array list may vary and can be retrieved with a method on the instance named size. ArrayList elements are accessed with get and set methods, also using an index ranging from 0 to 1 less than the number of elements. ArrayLists come with built-in support for printing out elements, including nested lists. Arrays don't though, so you need to call arrays.toString, passing the array as an argument. This slide shows examples of single-dimension arrays and ArrayLists. Here I show examples of multi-dimensional arrays and ArrayLists and how to print the elements in each. A multi-dimensional ArrayList simply has a type which in itself is an ArrayList. For a multi-dimensional array, you need to call the arrays.deepToString method, passing the array as an argument. For nested ArrayLists, we can still just pass the ArrayList instance directly to system.app.println as shown here. For arrays, we can use the binary search method to find a matching element, although this method requires that the array be sorted first. In addition, if the array contains duplicate elements, the index returned from this search is not guaranteed to be position of the first element. For the array list, we have several methods. We can use contains or contains all, which simply returns a boolean if a match or matches were found. In addition, like the string and string builder, we have the methods indexOf and lastIndexOf, which will return the index of the first or last match. When a -1 is returned from these methods, no matching entry was found. Sorting seems like a simple concept when you think about sorting numbers and strings. We know there is a natural order for numbers and even for strings. We can use the arrays.sort method for arrays with numeric primitive types and wrapper classes, as well as strings and string builders. For the array list, we can use the sort method, again for numeric wrapper classes, strings and string builders. We pass ArrayList's sort method a comparator type argument that specifies just how to sort. We call static methods on the comparator type to get a comparator for either a natural order or reverse order sort. There are times when you want to switch between an array and an array list, and we find support for this on both the arrays class and the ArrayList class. The arrays.aslist method returns an array list backed by an array. Here, I show the creation of a 3-element array. Then the code uses the arrays.aslist method, passing it the array and assign it to a variable using the var keyword to a variable named original list. You can think of this conceptually as putting an array list wrapper of sorts around an existing array. Any change made to the list is a change to the array that backs it. This also means that an array list created by this method is not resizable. Let's look at this method in some code. I've created a new project called Arrays and ArrayLists with the same class and package we have been using, including the main method. I'll have the code we saw on the slide. I'll create the original array, string array, with 3 elements first, second, and third. Use arrays.aslist to save into original list. The method arrays.aslist returns a special type of list, which we'll look at shortly. This is another good case for the var keyword, which lets us declare this variable without knowing the type exactly. Now, original list is backed by original array. This means we have access to lists methods to make changes to the array which backs it. I'll use the set method on the array list. I'll set element 0 to the string literal 1. I'll print out original list, and also print out original array using arrays.toString. And here, we print both the list and then the original array. When I run this code, We can see what it means to have a list backed by the array. The list's first element, you can see, was changed from first to 1. But look at the second output. This is the output from printing the original array. And here too, you can see the array's first element has been changed to 1 as well. So any method we use on this list will have an effect on the array that was the source of the list. Let's try another method. This time, I'll sort the list and print out the original array. Original list.sort, opening parentheses, comparator.natural order, opening and closing parentheses, semicolon. Print out original array using arrays.toString. And running this code, we see the array is now sorted. You'll notice for strings, the natural order of sorting is to have uppercase letters considered less than lowercase letters. So we get second, third, and 1 in that order. But this type of list has limitations. Because this list is backed by an array, we can't remove or add elements. Let's see what happens if I try to remove that first element. Call .remove, passing 0. This code compiles, but if I run it, we get an unsupported operation exception. Next, I'll replace that last statement and try adding an element. Again, this compiles, but if I run it, we get the same error and for the same reason. You can look at what we did here using the method arrays.aslist as a way of just dressing up the array that's passed as an argument to this method to make it look like a list. It's almost like a list wrapper. You do this when you want to be able to use list functionality to manipulate that underlying array, as I did here, sorting of the array, but using list's sort method to do it. The list we get back from arrays.aslist isn't resizable, again because its ultimate source is original array and arrays aren't resizable. One other thing I want to show you is that this method takes variable arguments. We can use it to create a fixed size list from a list of elements. Create new list and save the contents of a call to arrays.aslist and print out new list. This code uses 3 strings passed as arguments to the aslist method. Here, we don't have a reference to the array backing the list because the array is created from these 3 strings within that method. You can use this type of list creation if you desire to create a fixed size list. And if I comment out line 21 and run this again, we get our list printed out. I've already talked about the list.off method, which returns an immutable list. And I covered the toArray method in our last video, so I'll just give you a summary of these methods on a slide. This slide demonstrates 2 ways to create a list from elements or from an array of elements. Both are static factory methods on types. The first is the aslist method on the arrays class, and it returns a special instance of a list that is not resizable but is mutable. The second is the off method on the list interface, and it returns a special instance of a list that is immutable. Both support variable arguments, so you can pass a set of arguments of one type or you can pass an array. We show examples of both here, first using variable arguments and second passing an array. This slide shows the most common method to create an array from an array list using the method toArray. This method takes one argument, which should be an instance of a typed array. This method returns an array of that same type. If the length of the array you pass has more elements than the list, extra elements will be filled with the default values for that type. If the length of the array you pass has less elements than the list, the method will still return an array with the same number of elements in it as the list. In the example shown here, we pass a string array with 0 as the size, but the array return has 3 elements, which is the number of elements in the list. Okay, so I hope this comparison of arrays and array lists helped you understand the differences and the similarities of these 2 methods. In general, arrays are more efficient because they have fixed length and support primitive types. But the ArrayList class has a great deal of functionality that we only partially get with the Arrays Helper class. In the next video, I'm going to give you an ArrayList challenge so you can put some of the skills you've learnt to work. I'll see you in that next video. It's now time for a challenge to practice what you've learnt for array lists. The challenge is to create an interactive console program and give the user a menu of options as shown here. Using the scanner class, solicit a menu item 0 1 or 2, and process the item accordingly. This means if the user enters 0, you should quit the program. If the user enters 1, you want to prompt them for a comma-delimited list of items to add. And similarly, if the user enters 2, prompt them for a list, again comma-delimited, to remove from the grocery list. Your grocery list should be an array list. You should use methods on the array list to add items, remove items, check if an item is already in the list, and print a sorted list. You should print the list, sorted alphabetically, after each operation. You shouldn't allow duplicate items in the list. So that's the challenge. Go away and try that out and see how you get on. Pause the video now. Okay, how did you get on? Did you figure it out and get it all working? I've already created a project called ArrayList Challenge. First, I'm going to create a static field for the scanner instance. I'll use this instance in several of the methods I'll be creating. I'll make this private since it only gets used by this class. And it needs to be static since we'll be calling it from static methods. Private static scanner equals new scanner opening parentheses system.in closing parentheses semicolon. Next, I want to create the method that displays the menu options. I'll call it print actions. And for this, I'm going to take advantage of Java's text block feature. Let me set this up with an empty text block first. Private static void print actions opening and closing parentheses opening curly brace. String text block equals triple quotes semicolon. And then I'll print out text block along with a space at the end, closing curly brace. So a text block is just a special way to format a multi-line string in a what you see is what you get manner. Here I'm assigning the text block to a string variable. And we start a text block with 3 double quotes. These have to be on a separate line from the rest of the block. After that, we type in what we want the user to see. And then we end the text block with 3 double quotes. Okay, so now I'm going to paste the menu items from the text file menu.txt attached to the resource section of this video. I'm going to paste it on the line with the second set of triple quotes right before them. Just type out the menu if you don't want to download the menu text file. So notice I've got the last 3 double quotes immediately after the last bit of text. This is on purpose so we won't have an extra new line included. When the user enters input, we want it to be entered on the same line as this prompt. I'm also adding an extra space when I print this out because the text block removes all trailing spaces. This one extra space helps separate the input from the prompt. Okay, now back to the main method. I'm going to create a while loop. For each iteration, I'll show the menu items, then solicit an integer from the user. Boolean flag equals true semicolon. While opening parentheses flag closing parentheses opening curly brace. I'll add a call to print actions. Then I'll add a switch statement using integer.parseInt with scanner.nextLine as the argument. Default return type flag equals false semicolon. Closing curly brace. Closing curly brace. First, we create a Boolean flag and set it to true. We set this to false in the loop if the user enters something other than 1 or 2. Right now, if any number is typed in, including 1 and 2, that will be the case, but we'll add some extra case options shortly. And we set up the while loop using that flag as the condition. We first execute the print actions method. Now, we have a switch statement. And in that switch expression, we have a compound expression. I could have put these all on separate lines, but this is an example of using an expression that evaluates to an integer in a switch condition. First, we use scanner.nextLine, which reads input from the console. That's getting passed directly to the method parseInt on the integer wrapper class. We've done this quite a few times in other code. If the user enters anything that's not an integer, this method will fail and the code will crash. But we're not doing any validation on purpose to make this code simpler. And here, we're setting up the default value with the enhanced switch statement syntax. The default behavior just sets flag to false, which should break out of the while loop. If I run this, we'll see the menu options, and we see that we prompted to enter something after the last statement and colon on the same line, so that's good. As I mentioned, right now, at this point any number we put in there will break out of the loop. We still need methods to add one or more items and to remove items. I'll start with adding elements, but first we need a grocery list. I'm just going to add this as a local variable to the main method. Array list, less than sign, string, greater than sign, groceries equals new, array list, less than, greater than, opening and closing parentheses, semicolon. Groceries.sort, opening parentheses, comparator.natural order, opening and closing parentheses, semicolon. And then I'll print out groceries. The grocery list will just be a list of string, so we specify that type in the angle brackets on the left side of the assignment. We still want to include the angle brackets or diamond operator on the right side in the creation expression. After each selected action item, we'll sort the list. We do this by calling the sort method and passing a comparator to the method, getting that from the static method on comparator called natural order. We've seen this in use previously in this section. And then we'll just print the grocery list out, passing the array list instance to system.out.println directly. And that's it for printing out a sorted list. Okay, so now the methods. First, add items. Private static void add items, opening parentheses, array list, groceries, closing parentheses, opening curly brace. First, I'll print out the instructions on how to add items. String, opening and closing square brackets, items equals scanner.nextLine, opening and closing parentheses, dot split, opening parentheses, double quotes, comma, closing parentheses, semicolon. Use add all, passing the items via list.off, closing curly brace. The first thing I'm doing is to prompt the user to enter a list of items they want at the grocery store. They can enter the items on a single line separated by commas. After the prompt, we call scanner.nextLine, which reads the data. I chain the split method on string to that call, which splits the string we got from the user by the comma and returns a string array. We could loop through and add these items to the list one at a time. Instead, for now, I'm using the add-all method, passing the result of a call to list.off using the string array we just created out of the data we got from the user. Going back to the main method, I'll add a call to this method. Case 1, return type, add items, opening parentheses, groceries, closing parentheses, semicolon. If the user enters 1 as a menu item, we'll prompt them to add items to the grocery list, so we'll call the add items method there. Now, remember, with this enhanced syntax, for the switch statement, we don't need break statements. The enhanced switch doesn't have the problem of fall through like the traditional switch statement does, so the flag isn't going to get set to false there. Okay, so let's test this out. We get the first prompt and we enter 1. Now, we're prompted to enter some items separated by commas. I'll add eggs, milk, cereal, bananas, cheese, and ham. And there you can see all those items got added all at once, and although that's kind of fun, it's not really what we want. Also, notice how eggs is at the end of the sorted list. This is because all the other items start with a white space, and the white space takes precedence over letters in a sorted list. I'll take care of that shortly. Okay, remember we don't want to add duplicate items, and this code lets us do it. So if I enter 1 again, and add eggs and cereal this time, we can see they got added again, and now we have eggs and cereal in our list twice. Let's enter 0 to quit out of that loop, and then we'll fix our add items method. I'm going to comment out that line that adds all the items the user entered. It really has 2 problems. It adds duplicates, and it includes extra spaces the user may have added. Let's fix both those problems. I'll use an enhanced for loop to loop through the items. String trimmed equals I.trim, opening and closing parentheses, semicolon. Check if the trimmed item is in the groceries list. Not found. Let's add it. Closing curly brace. Closing curly brace. We're replacing the code that added all the items with this for loop. And the first thing we'll do is trim the array element, getting rid of leading and trailing white space if the user included any in their comma delimited list. Then we check if that element is already in the list. We'll keep this code simple, just checking for a match on exact case using the index of method on the groceries list. If we don't find a match, if we get -1 back from that method, we add the trimmed item to groceries. When I rerun this code, using the same tests as before, selecting one, then entering eggs, milk, cereal, bananas, cheese, and ham. You can see they get added, so we'll select one again and enter eggs and cereal this time. Those don't get added, as you can see, so that's good. Pressing 0 will get us out of that loop. Now, it's time to write the remove items method, which will look a lot like the add items method. I'm going to copy and paste that method, then rename it to remove items. I'll change the user's prompt from add to remove items. I'll also delete the commented outline. And I'll change groceries.add to groceries.remove in the for loop, but I'm going to remove the surrounding if block. I'll add a call to this method in the switch statement. Case, to, return type, remove items, opening parentheses, groceries, closing parentheses, semicolon. And now we can test all our menu options. I'll start again with 1 and enter that same list of items: eggs, milk, cereal, bananas, cheese, and ham. Now I'll enter 2 and I'll enter eggs and ham. And there you can see our list no longer has those 2 items, so I'll remove method work there. And 0 will quit the program. That's it for the ArrayList challenge. And I hope you got a lot out of that, and you can see that the ArrayList class offers a lot of ways to do things like add elements, remove elements, clear a list, and so on. Okay, so in the next video, we'll complicate things a little and introduce you to another list type, the linked list. I'll see you in that next video. In this video, I'm going to start talking about another class Java provides that also implements many of the same list methods we've seen already. And this is the linked list. To understand why the linked list class exists, it's important to understand a few things about the way Java stores information in memory for the array list, and the linked list. Let's start with an array of primitive data types. This is the simplest thing to understand. When an array of primitive types is allocated, space is allocated for all of its elements contiguously, as shown here. You can see from this slide that we have an array of 7 integers. The index position is in the left column, and that's the number we use to access a specific array value. So the first element, when we use index position 0, this will retrieve the value 34. When we use index position 1, this gets the value of 18, and so on. The addresses we show here are memory addresses represented by these numbers. If 100 is the address of an integer, and we know an integer is 4 bytes, then the address of the next integer, if it's contiguous, would be 104, as we show here for the second element. Java can use simple maths using the index and the address of the initial element in the array to get the address and retrieve the value of the element. For reference types, meaning anything that's not a primitive type, like a string or any other object, the array elements aren't the values, but the addresses of the referenced object or string. There's a level of indirection as I show on this slide. We've learnt that array lists are really implemented with arrays under the covers. This means our objects aren't stored contiguously in memory, but their addresses are in the array behind the array list. And again, the addresses can be easily retrieved with a bit of maths if we know the index of the element. This is a cheap lookup and doesn't change no matter what size the array list is. But to remove an element, the referenced addresses have to be reindexed or shifted to remove an empty space. And when adding an element, the array that backs the array list might be too small and might need to be reallocated. Either of these operations can be an expensive process if the number of elements is large. In this slide, the string, 3.5, represents a new element we want inserted at index position 3. This means all the elements below this point need to be moved and reindexed. An array list is created with an initial capacity depending on how many elements we create the list with, or if you specify a capacity when creating the list. On this slide, I show an array list that has a capacity of 10 because we're passing 10 in the constructor of this list. We then add 7 elements. We can add 3 more elements using the ArrayListAdd method, and the array that is used to store the data doesn't need to change. The elements at indices 7, 8, and 9 get populated. But if the number of elements exceeds the current capacity, Java needs to reallocate memory to fit all the elements, and this can be a costly operation, especially if your array list contains a lot of items. So now, if our code simply calls out on this array list, the next operation is going to create a new array with more elements, but copy the existing 10 elements over. Then the new element is added. You can imagine this add operation costs more in both time and memory than the previous add methods did. When Java reallocates new memory for the array list, it automatically sets the capacity to a greater capacity. But the Java language doesn't really specify exactly how it determines the new capacity or promise that it will continue to increase the capacity in the same way in future versions. We can't actually get this capacity size from the array list. From their own documentation, Java states that the details of the growth policy are not specified beyond the fact that adding an element has constant amortized time cost. Okay, maybe you're interested in what constant amortized time is. Let's start with how to determine cost, which in this case is generally considered in terms of time, but may include memory usage and processing costs, etc. Maybe you've heard people talking about big O notation, or big O, and wondered what this means. I won't get too deep into it, but there are a couple of concepts that are fairly easy to grasp and will help us understand how cheap or expensive an operation is in terms of time and memory usage as the operation scales. This means it's a way to express how well the operation performs when applied to more and more elements. Big O approximates the cost of an operation for a certain number of elements called n. Cost is usually determined by the time it takes, but it can include memory usage and complexity, for example. As n, the number of elements gets bigger, an operation's cost can stay the same. But cost often grows as the number of elements grow. Cost can grow linearly, meaning the cost stays in step with the magnitude of the number of elements. Or cost can grow exponentially or by some other nonlinear fashion. In a perfect world, an operation's time and complexity would never change. This ideal world in big O notation is O1, sometimes called constant time. In many situations, an operation's cost is in direct correlation to the number of elements, n. In big O notation, this is On, sometimes called linear time. So if we have 10 elements, the cost is 10 times what it would be for one element, because the operation may have to execute some functions up to 10 times versus just once, and 100 times for 100 elements, for example. On is generally our worst case scenario for list operations, but there are big O notations for worse performers. We won't be talking about exponential growth or nonlinear growth yet, since it's not relevant to our discussion here. Another scenario is the one the Java docs declared for the growth of the array list, that adding an element has constant amortized time cost. In our case, we'll designate this constant amortized time as O1 star. This means that in the majority of cases, the cost is close to O1, but at certain intervals, the cost is On. If we add an element to an array list where the capacity of the list is already allocated and space is available, the cost is the same each time, regardless of how many elements we add. But as soon as we reach the capacity and all in elements need to be copied in memory, this single add would have a maximum cost of On. After this operation, that forced a reallocation, any additional add operations go back to O1 until the capacity is reached again. As the expensive intervals decrease, the cost gets closer to O1, so we give it the notation O1 star. This slide shows the big O values for the most common array list operations or methods. Let's just talk about one example that contains method which looks for a matching element and needs to traverse through the array list to find a match. It could find a match at the very first index. This is the best case scenario, so it's O1. It might not find a match until the last index. This is the worst case scenario, so it's On. In general, the cost will be something in between for the contains method, because the element will be found somewhere between the first and nth or last element. You'll notice that the index methods are usually O1, remembering that finding an element by its index is a simple calculation. It only gets costly with indexed add or remove methods if the array list needs to be reindexed or resized. Now that you understand why some operations are more efficient and less costly because of indexing, it's time to look at another class called the linked list. The linked list is not indexed at all. There is no array storing the addresses in a neat ordered way as we saw with the array list. Instead, each element that's added to a linked list forms a chain, and the chain has links to the previous element and the next element. This architecture is called a doubly linked list, meaning an element is linked to the next element, but it's also linked to a previous element in this chain of elements. The beginning of the chain is called the head of the list, and the end is called the tail. This can also be considered a queue, in this case, a double-ended queue, because we can traverse both backwards and forwards through these elements. Getting an element from the list or setting a value of element isn't just simple maths anymore with the linked list type. To find an element, we'd need to start at the head or tail and check if the element matches, or keep track of the number of elements traversed if we are matching by an index, because the index isn't stored as part of the list. For example, even if you know you want to find the fifth element, you still have to traverse the chain this way to get that fifth element. This type of retrieval is considered expensive in computer currency, which is processing time and memory usage. On the other hand, inserting and removing an element is much simpler for this type of collection. In contrast to an array list, inserting or removing an item in a linked list is just a matter of breaking two links in the chain and re-establishing two different links. No new array needs to be created, and elements don't need to be shifted into different positions. A reallocation of memory to accommodate all existing elements is never required. So for a linked list, inserting and removing elements is generally considered cheap in computer currency compared to doing these functions in an array list. All of that being said, there is a lot of debate about whether a linked list is ever really a preferred solution over the array list, especially as the Java language improves in performance and computer hardware itself continues to improve. I won't wade into this debate, but I want to encourage you to review both sides of the debate if you're interested. Let's look at the big O notation for the matching operations in a linked list. This slide shows the big O values for the most common shared list operations or methods for both types. For a linked list, adding elements to the start or end of the list will almost always be more efficient than an array list. When removing elements, a linked list will be more efficient because it doesn't require reindexing, but the element still needs to be found using the traversal mechanism, which is why it is ON as the worst case. Removing elements from the start or end of the list will be more efficient for a linked list. So let's review what all of this means. The array list is usually the better default choice for a list, especially if the list is used predominantly for storing and reading data. If you know the maximum number of possible items, then it's probably better to use an array list, but set its capacity. This code demonstrates how to set the capacity of your array list to 500,000. An array list index is an int type, so an array list's capacity is limited to the maximum number of elements an int can hold. Integer.max_value equals 2,147,483,647. You may want to consider using a linked list if you're adding and processing or manipulating a large amount of elements and the maximum elements isn't known, but may be great, or if your number of elements may exceed integer.max_value. A linked list can be more efficient when items are being processed predominantly from either the head or tail of the list. I'll explain methods for this in more detail coming up. In the next video, I'll just show you a few significant differences between the linked list and the array list, in addition to these behind-the-scenes differences we've discussed here.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
I've just talked a lot about how the linked list and the array list are different under the covers. An array list is implemented on top of an array, but a linked list is a doubly linked list. Both implement all of lists methods, but the linked list also implements the queue and stack methods as well. When you think of a queue, you might think of standing in line. When you get in a line or a queue, you expect that you'll be processed in relationship to the first person in line. We call this a first in, first out, or FIFO data collection. If you want to remove an item, you poll the queue, getting the first element or person in the line. If you want to add an item, you offer it onto the queue, sending it to the back of the line. Single-ended queues always process elements from the start of the queue. A double-ended queue allows access to both the start and end of the queue. A linked list can be used as a double-ended queue. When you think of a stack, you can think of a vertical pile of elements, one on top of another, as we show on this slide. When you add an item, you push it onto the stack. If you want to get an item, you'll take the top item or pop it from the stack. We call this a last in first out or LIFO data collection. A linked list can be used as a stack as well. Let's start using this new class in some code. I've created a project called linked lists. The first thing I'll do is create a linked list variable called places to visit. Linked list less than sign string greater than sign places to visit equals new linked list less than greater than opening and closing parentheses semicolon. Like an array list, we include the type parameter string in the angle brackets in the declaration. And we use the diamond operator on the right side of the assignment operator. This is one way to declare a linked list. I want to take an extra minute here to talk to you about lists and the var keyword. I'll comment that last line out so you can see it for comparison. Now, I'll use the var keyword instead to set up this linked list. Create a new linked list of strings and assign to var places to visit. What I wanted to show you here is that we can use the var keyword for typed linked lists or any typed list or collection. But when we do, we have to specify the type parameter on the right side of the assignment operator in the angle brackets. We can't just put a diamond operator there as we did on that line above. Using the diamond operator without a type in this statement doesn't give Java enough information to infer the type. So in this case, the type is an optional on the right side of the assignment. Now, adding records to a linked list is a lot like adding records to an array list, so let's add a few places we might want to visit in Australia. First, I'll add Sydney. Then I'll add Canberra at index 0. And then I'll print the linked list out. Like an array list, we can use the add method, passing it just an element, which appends the element to the end of the list. We next use the overwritten method for add, which takes an index, again like the array list. This insets Canberra at position 0 of the list. Running this code, we confirm that our list has Canberra first, then Sydney. Now, because the linked list implements methods on the deck interface, we have several other functions to add elements. I'm going to create a method called add more elements to demonstrate some of these. I'll make the return type void and add a parameter of a linked list of strings. I'll then add Darwin at the start of the list, and then Hobart at the end, closing curly brace. Hopefully these add methods are self-explanatory. They are methods that are on the linked list class, but not on an array list. The first statement adds Darwin, inserting it at the start of the list. The next statement adds Hobart, appending it to the end of the list. Let's call the add more elements method from the main method, then print out the list. Add more elements, opening parentheses, places to visit, closing parentheses, semicolon. And then I'll print out the list again. Running that code. We can confirm that Darwin was added at the start and Hobart at the end of the list. In addition to these methods, linked list has a method called offer, which is queue language, if you will, for adding an element to the end of the queue. Let's add that to the add more elements method. I'll add this comment. I'll call offer, passing the string literal Melbourne. And running that, we see Melbourne now at the end of this list or queue. The offer last method does the same thing as the offer method. We also have an offer first method that does what the add first method does, so let's add these next. I'll call offer first, passing Brisbane, and call offer last for Toowoomba. Running this, we see Brisbane as our first element and Toowoomba as the last. Continuing on, there is one more method for adding an element. If you're familiar with stack language, you might know that when you want to add something to a stack, you push it onto the stack. We also have a push method. The top of the stack is the first element in the linked list, and if you're using linked list as a stack, pushing will insert the element at the start. I'll add this comment. List.push, opening parentheses, double quotes, Alice Springs, closing parentheses, semicolon. Running that. We see that the push method placed Alice Springs at the head or beginning of the list. So you can see the linked list can be used as different types of data collections, a list, a queue, a double-ended queue, and a stack. Like the many ways to add an element, there are also many ways to remove an item from a linked list. We'll put these in a separate method called remove elements. Private, static, void, remove elements, opening parentheses, linked list, less than sign, string, greater than sign, list, closing parentheses, opening curly brace. I'll remove the element at index 4 and remove Brisbane, closing curly brace. Here, we're simply calling the remove methods that we also saw on the array list. The first statement removes the fifth element in the list, which will be Sydney, and the next removes Brisbane from the list. Let's add a call to the remove elements method in the main method and print the list. Remove elements, opening parentheses, places to visit, closing parentheses, semicolon. And then I'll print out the list. Running that. We can confirm that we removed Brisbane and Sydney. Linked list has additional methods to remove elements that aren't on array list. One of these is a no argument remove method. First, I'll print out the list. Then I'll remove the first element and assign it to S1. And then I'll print out a message that it was removed. So we call remove again, but we aren't passing any arguments to this version of the method. This method removes the first element in the list and returns the removed element. We assign that to a variable S1 and print that out. And we can confirm that Alice Springs was removed from the list, which was the first item in our list. Now, I'll cut and paste those last two lines. I'll change the name of our variable to S2 and the method we call to remove first. And again, I'll change S1 to S2 in the last println statement. And running that, we confirm that remove first is the same as calling remove, but might be a bit clearer to anyone reading our code. And there's also a remove last method, so let's cut and paste those last two lines again. I'll change the variable name to S3, change the method name to remove last, and change the comment to say removes last element. And in the last statement, I'll change that to print out S3, which is the result of the remove last method. And running that, we see that Toowoomba, the last element, gets removed this time. And like the additional queue methods offer first and offer last for adding an element, we have the poll first, and poll last methods to remove an element. Let's add these, starting with poll. I'll add this comment. I'll remove the first element and assign it to P1, and then I'll print it out. First, we create a local variable, a string named P1, and assign it the result of the poll method, which removes the first element from the list. And we simply print that variable out. I'll copy those two statements and paste them, changing P1 to P2 and poll to poll first in the first statement and P1 to P2 in the println statement. And I'll again copy those last two statements and paste them, changing P2 to P3 and poll first to poll last. I'll also change that comment to say removes last element and change P1 to P3 in the println statement. And running this code, we see Canberra was removed first, then Hobart, and finally Melbourne, which leaves our list empty. Let's add a couple of elements back to our list before we test one more method. Let's use the push method here, another stack method that pushes the item to the top of the stack, the start of the list. You can imagine, if you will, that push is pushing all the elements back in the pile or downwards in the stack. I'll add Sydney, Brisbane, and Canberra back into the list. System.out.println, opening parentheses, list, closing parentheses, semicolon. We'll test the stack method for removing an element, which is the pop method. I'll remove the first element and assign it to P4. Then I'll print it out. So let's run this code. And we can confirm Canberra gets removed using the pop method. Using the push methods, it was the last element in, and with pop, it was the first element out. This feels like a good place to end this video since it's getting a bit long, and we covered most of the add and remove methods on linked list. In the next video, we'll look at additional methods to retrieve data from the linked list. I'll see you in the next video. In the last video, we covered many methods available to the linked list for adding and removing elements. Now, I want to review the different ways to retrieve an element from a linked list. I'll add another method to this class. I'll call it getting elements, static return type void, and a parameter of a linked list of strings. And then I'll print the element at index 4, closing curly brace. This method simply retrieves the fifth element in the list and prints that out. Let's add a call to this method in the main method. First, we'll comment out the call to the remove elements method. Call getting elements, passing places to visit. And now if I run this code, we can see we retrieved the element at index 4, or the fifth city in our list, Sydney. I've said this is a method on both ArrayList and linked list. However, on the ArrayList, the big O notation is O1 at its worst, whereas for a linked list, the worst case is ON. It's actually not as bad as that on a linked list. Since it's a double-ended queue, Java will decide where to start searching. The retriever will start moving from one link to the next, either from the start or the end of the list, whichever is closer to the specified index. So it would never traverse the entire number of elements. In addition to the get method, the linked list has the get first and get last methods. I'll print out the first and last elements using get first and get last. Here we're calling each method and printing the result in the system.out.println statement. So no surprises here when I run it. We get Alice Springs from the get first method and Toowoomba from the get last method. We can also use the methods index of and last index of to see if an element is in a list, as we did with the array list. First, I'll print the index of Darwin. Then I'll do the same thing for Melbourne. The big O notation is the same for these methods as it is for the array list. The worst case is ON for both if the element retrieved is the element at the last position to be checked. Running this code tells us the positions of these towns in our list. So Darwin is at position 2 and Melbourne is at position 6. As you'd expect, linked list has additional methods for retrieving an element. The first is appropriately named element, which is a queue method. I'll add a comment here and print out the element returned by the method element. This method takes no arguments. So what element does it return? Remember, I've said it's a queue method and a queue is first in, first out. So this should indicate that element gets the first item out of the list. Running this, we can confirm that because we get Alice Springs. Now let's add the stack retrieval methods, which are peak, and similar methods like peak first and peak last. Another comment. And print out the result of calling peak. Then I'll copy that statement and paste it. Change peak to peak first in both cases there. And I'll paste it again, changing peak to peak last in both cases. Running that, we can see that peak and peak first get the first element of the list, Alice Springs, and peak last gets the last element, Toowoomba. We've covered quite a few ways to add, remove, and get elements from this linked list. Now, let's switch gears and talk about traversing and manipulating the elements in the list. First, let's use a simple for loop. We'll say this list of towns is our itinerary, and we plan to travel to each list in the order we've defined here. I'll call the method printItinerary and pass it a linked list of string. Public static void printItinerary opening parentheses linked list less than sign string greater than sign list closing parentheses opening curly brace. I'll print out where the trip starts and where it ends, closing curly brace. This method uses the get first and get last methods to print out the starting and ending points of our trip. And I'll add a call to this from the main method. I'll first comment out the call to the getting elements method. Call printItinerary, passing places to visit. Running this code, we should see our list of places and then that the trip starts at Alice Springs and ends at Toowoomba. Now let's include a loop to print the places in between, and we'll want to include an entry for each item except the starting and ending points. Every line item will include where we started and where we ended up. Our for loop will use list.size. And then I'll print out the two places we're travelling between. Closing curly brace. So this for loop starts at I equals 1 because we don't want to include an entry for the first town we started in since we've already printed that out. And then I'll print the item we started at using a -1 as the index to get that town and then get the town at the current index. And running this code, we get a decent itinerary. I've said that indexing into a linked list isn't the most efficient way to access elements. In this loop, we're accessing 2 elements by index for each iteration of the loop. Let's try another method, this time using the for each loop. I'm going to copy and paste this method, renaming it to printItiner2. And I'm going to remove the code for the traditional for loop. Now I'll add the enhanced for loop. String previous town equals list.getFirst, opening and closing parentheses, semicolon. Our enhanced loop will use list here. Then I'll print out the 2 places again. Previous town equals town, semicolon, closing curly brace. Okay, so we first set up the previous town to be the first place in our list. Then we set up the for each loop using a string variable named town, and the second component of this declaration is the list. Then we'll print out the previous town and the current town. Next, we set previous town to the current iteration's town variable. And that's it. I'll call this method now in the main method. Instead of print itinerary, I'll make that print itinerary2. So this is a bit more efficient, but it also prints out from Alice Springs to Alice Springs on that second line. Using this loop limits us to looping through the elements one at a time from the very first to the last. The traditional for loop is much more flexible if we don't want to loop through every element one at a time. But now, let's look at another way to do this without using either of the for loops. I'll copy and paste this method, printItiner2, and rename it to printItiner3. Now, we're going to use something called a list iterator. Let me set this code up, and then we'll talk more about how it works after. List iterator, less than sign, string, greater than sign, iterator equals list.listIterator, opening and closing parentheses, semicolon. While opening parentheses, iterator.hasNext, opening and closing parentheses, opening curly brace. Var town equals iterator.next, opening and closing parentheses, semicolon. Here, I've made 3 changes. I've set up a local variable with a type of list iterator with type string. And I've named it iterator and assigned it to a method on linked list, listIterator. After this, I changed the for loop to a while loop, and we're using a method on listIterator called hasNext, which will return true if there are more elements to process. After this, we have a local loop variable, which we're calling town again. And we're setting this to the result of another method on the listIterator called next. And instead of calling printItiner2, I'll call printItiner3. When I run this code, we get the same output as before, including that problematic first line that we don't really want. Let's make one change to this printItiner3 method. When we make that call to the method listIterator on the linked list, we'll call an overloaded version, passing the index of the first element we want to process. And now I'll run this again. And you'll notice, I hope, that we don't have that problematic first line because this particular method gets an iterator that isn't set before the first element, but is set before the second element in between index 0 and 1. By now, you must be asking what's an iterator or what's a list iterator to be more specific. I'm going to end this video here and answer that question in the next video. So we last left off looking at this method, which got an object from the linked list method, a list iterator. We used 2 methods on this object, the hasNext method to check if there were elements, and the next method to actually retrieve the element from this object. Let's talk about the iterator for a few minutes. So what's an iterator? So far, we've mainly used for loops to traverse or step through elements in an array or list. We can use the traditional for loop and an index to index into a list. We can use the enhanced for loop and a collection to step through the elements one at a time. But Java provides other means to traverse lists. 2 alternatives are the iterator and the list iterator. If you're familiar with databases, you might be familiar with a database cursor, which is a mechanism that enables traversal over records in a database. An iterator can be thought of as similar to a database cursor. The kind of cursor we're referring to here can be described as an object that allows traversal over records in a collection. The iterator is pretty simple. When you get an instance of an iterator, you can call the next method to get the next element in the list. You can use the hasNext method to check if any elements remain to be processed. In the code, you can see a while loop, which uses the iterator's hasNext method to determine if it should continue looping. In the loop, the next method is called and its value assigned to a local variable and the local variable printed out. This would just print each element in a list, but do it through the iterator object. This slide shows visually how an iterator works using the places to visit list. When an iterator is created, its cursor position is pointed at a position before the first element. The first call to the next method gets the first element and moves the cursor position to be between the first and second elements. Subsequent calls to the next method moves the iterator's position through the list, as shown, until there are no elements left, meaning hasNext equals false. At this point, the iterator or cursor position is below the last element. We looked at it briefly in code in the last video, but I want to explore this type with you a bit more. I'll start with a new method in our main class called testIterator. Private static void testIterator, opening parentheses, linked list of strings, list, closing parentheses, opening curly brace. I'll create a variable containing our list iterator and loop through it using hasNext. Let's print out the element returned by the next method. Close while loop, and then print out the list, closing curly brace. Here, I have created an iterator variable assigning it the result of the list.iterator method. I have a while loop that checks the iterator.hasNext method, which returns true if the cursor position is before another item to process. And I'm calling iterator.next and passing the result directly to the system.out.println statement, so these will print every element in the list. Back to the main method, I want to comment out the printItiner3 method. And now I have the call to testIterator, passing it places to visit. TestIterator, opening parentheses, places to visit, closing parentheses, semicolon. And if I run that, we first get our places printed out one by one and then the full list. One of the benefits of an iterator is that you can use it to modify the list while you're iterating through it. Let's say we wanted to remove all instances of Brisbane from our list and our list could contain duplicates. I'll add that code to the testIterator method. First, I want to comment out the system.out.println statement in the while loop. Now, I'll check if each element is Brisbane, and if it is, I'll use the remove method on iterator to remove it from the underlying list. Chain an equals method call to check for Brisbane. Remove it. Closing curly brace. Here, we just have an if condition that checks if the value we get back from the next method equals Brisbane. If it does, we execute iterator.remove, running that. You can see this works, and Brisbane was removed from this list. But what if I tried to remove Brisbane directly from the list at this point? I'll change iterator.remove to list.remove. If I run this, we get a concurrent modification exception. You get this same error if you tried to do something similar in an enhanced for loop. The iterator provides a safe way to remove elements while still iterating through the list, so it's important to make sure you're calling remove on the iterator object and not the list object. I'll revert that last change. This type of iterator only allows us to move forward through the elements. This means we can only call the next method on this iterator instance. And the only method available for mutating elements in this iterator is the remove method, which I just showed you. There is another iterator, the list iterator, that gives us additional functionality. An iterator is forwards only and only supports the remove method. A list iterator can be used to go both forwards and backwards, and in addition to the remove method, it also supports the add and set methods. I'll make a minor change to our code. Instead of calling the iterator method, I'll change that to call the list iterator method on list, which gives us a list iterator. Running this, With this one change, we get the exact same results. But now I can change remove to add, adding a new place to visit after Brisbane. Instead of removing Brisbane, this code adds Lake Wivenhoe to our places to visit after Brisbane. Again, it's really important to note we're using the add method on the list iterator and not on the list itself. This code compiles, and if I run it, we can confirm that Lake Wivenhoe was added to the list immediately following Brisbane. Now, after the while loop, what happens if I want to loop through the elements again? I'll add another while loop just after the first and loop through the elements again, just printing them out. We'll create a while loop based on our iterators as next method. Here I'll print out the next element, closing curly brace. If I run this code, we don't get an error, but we don't get any places printed out individually. And that's because as next, after that first while loop, is false and the second loop never executes. If we wanted to loop through this iterator again, we couldn't use this same iterator instance to move forward anymore, not in its current state. And we can't simply reset it to the beginning. We could get a new instance by calling the list iterator method again, or we could move backwards. I'll try moving backwards here, so I'll change has next to has previous in the while condition. And I'll print out iterator.previous instead of iterator.next. In this code, we're actually iterating backwards through the list and printing each town. And if I run this, you can see in the output, Toowoomba is printed first and Alice Springs last. After running this, we're at the top of the cursor again at the start of the list. Another thing we can do is call the list iterator method and pass the cursor position we want to start at. I demonstrated this in the last video, but I'll show it here again. I'll do this creating a new iterator after the last statement. var iterator2 equals list.list iterator, opening parentheses, 3, closing parentheses, semicolon. Then I'll print out the next element. This is a way to get an iterator with the cursor positioned in some other place other than the default, which is prior to the first element. Here, we've specified position 3, so the cursor is placed between the elements at index 2, Lake Wivenhoe, and index 3, Darwin. Running this, we get Darwin printed out. Let's change next to previous. And running that, we get Lake Wivenhoe. I'll show you one more slide that hopefully helps you understand how the iterator is positioned compared to the elements in the list. It's really important to understand that the iterator's cursor positions are between the elements. When the iterator is at position 0, or the start, it's not pointing at element 0. The code on this slide shows an iterator for this list. We get Alice Springs when we first call iterator.next, and that moves the iterator's cursor to cursor position 1, meaning after Alice Springs. Another call to iterator next returns Brisbane and moves the cursor to cursor position 2, or between Brisbane and Darwin. But if we decide to reverse positions and call previous here, we get Brisbane because the cursor position was 2 when we made this call. Traversing both backwards and forwards through a collection using a list iterator is a little tricky because of this. But if you remember that the cursor is always between elements, then you'll be able to keep it straight. Okay, so we'll end this introduction to the iterator and list iterator here. In the next video, I'll be giving you a linked list challenge to give you a chance to practice what you learnt in the last 3 videos, so this should be fun and interesting. I'll see you in that next video. It's now time for a linked list challenge. I'm going to ask you to use linked list functionality to create a list of places ordered by distance from the starting point. And we want to use a list iterator to move both backwards and forwards through this ordered itinerary of places. First, create a type that has a town or place name and a field for storing the distance from the start. Next, create an itinerary of places or towns to visit, much like we've been doing in the last few videos. But this time, instead of strings, you want to create a linked list of your place or town type. Here we show a list of a few places in Australia and their distances from Sydney. You'll create a linked list ordered by the distance from the starting point, in this case Sydney. Sydney should be the first element in your list. You don't want to allow duplicate places to be in your list for this data set. In addition, you'll create an interactive program with the following menu item options. The menu will have options to move forwards and backwards through your itinerary, to list the itinerary, and print menu options and quit the program. You want to use a scanner and the next line method to get input from the console. You use a list iterator to move forwards and backwards through the list of places on your itinerary. Okay, now pause the video and have a go at building this, and when you're done or want to see the way I build this, come back and we'll walk through it together. Pause the video now. Welcome back. I hope you found this an interesting challenge. I've created a new project named Linked List Challenge, set up in the normal way. The challenge said to create a type for the place or town to visit or the itinerary item. Did you create a class for this? That would have been a good way to solve it, but Java does offer a much easier option, the record. I'm going to create a record and put it in the main.java source file. Record, place, opening parentheses, string, name, comma, int, distance, closing parentheses, opening and closing curly braces. This record has two fields, name and distance, which is distance from the starting point. And just by doing this, we have a constructor, accessor methods, and an overridden to string method created for us implicitly by Java. Next, I want to set up a linked list of these records in the main method. Linked list, less than sign, place, greater than sign, places to visit, equals, new, linked list, less than, greater than, opening and closing parentheses, semicolon. With this code, we're saying that linked list is going to contain a list of our place records. We could use any of the add methods on linked list, but I want to create my own method called addPlace. This code is going to let us add the place in order of the distance from the starting place and also check for duplicates. This will be a private method taking a linked list and the place record that should get added. This method will return void and be called addPlace. I'll add those two arguments. I'll add place to the list, closing curly brace. This code right now just calls the add method, but we don't want to add the place if it's already there. Let's add the code that checks for that. Does this contain the place? If it does, I'll print it out. Return, semicolon, closing curly brace. Hopefully you've remembered that lists have a method called contains. This checks for a matching element, so if this method finds a match, we'll just return from this method, meaning the item won't get added because it's already there. Let's see what happens when we call this method from the main method. Place, Adelaide, equals, new, place, opening parentheses, double quotes, Adelaide, comma, 1374, closing parentheses, semicolon. Add Adelaide to our places to visit. And then I'll print out the list. Here, we create a new place record with name Adelaide and the distance is 1374, which was in the table of data on the slide. Then we call our place, passing the linked list and this new record. When I run this, we see our list now includes the Adelaide record. This is the default string representation for a record and includes the class name and the record field names and values. I want to simplify this, so I'll add a couple of lines between the brackets in the record body. Then I'll generate an overridden method. I'll use controller to bring up the options. And I'll replace the null, returning a formatted string. Return string.format, opening parentheses, double quotes, %s, opening parentheses, %d, closing parentheses, comma, name, comma, distance, closing parentheses, semicolon. Hopefully you remember the string.format method takes a string with format specifiers and we pass the values name and distance. Rerunning the code. We get a simpler string printed. This will be easier to look at when we have more places. So now let's test to see if we can add a duplicate record. Add place, opening parentheses, places to visit, comma, new, place, opening parentheses, double quotes, Adelaide, comma, 1374, close both parentheses, semicolon. Here, we create another record with the exact same data as the previous record, and we just create that in the second call to add place. Running the code. We see that our code recognized this as a duplicate record and didn't add it. This works because Java includes implicit code for the record, which tests the equality of all its fields. If all the record's field values match another record's field values, Java recognizes that the records are equal. This means we can use the contains method to find a match for records, so that's kind of another nice feature with using records. Now, I'm going to change the second record to have Adelaide all in lowercase. Running this, we get 2 Adelaide records, one uppercase and one lowercase. This isn't the behavior we want, so I want to write my own test, looping through every element in the list. For me, a match will be a match when the place names are the same, ignoring the case, and I'm not going to compare the distance fields. Add a for each loop over our list. If the name I'm adding is in the list, I'll print it out then exit the method. Closing curly brace. Closing curly brace. In this code, we've got an enhanced for loop with a local variable p, which is a place record. We compare each record in the list with the one we want added, comparing the name field values on each record. The implicit accessor is not getName but just name on records. And we print out found duplicate and return from the method if we find a match. If I run this, we get found duplicate Adelaide 1374 and the list still only has one record. So that's good. Now that we've handled duplicates, I want this method to add each new place in order by the distance to Sydney. We want the closest place to be first and the farthest place to be last. I'm going to use a simple enhanced for loop for this. Int matched index equals 0 semicolon. Add a for each loop for our list. Add one to our count. Closing curly brace. First, we create an index variable which keeps track of what element is being processed, what index position, and we know we want to start at 0. In the loop, we increment the matched index variable in each iteration. Now, I add the code to compare distances between the record we're adding and the record we process in the loop. Add the comparison. Add place in the specified index if the above line returned true. And then I'll exit the method. Closing curly brace. We use the accessor method, distance, and compare that to the loop variable thisPlace.distance. If the new record is closer to Sydney, we'll add it using the add method that takes an index and pass it the matched index. Then we'll return from this method once we've added the element. If we get to the end of the loop, we know we still need to add the element, so we'll add it to the end of the list. Now, we could have used a list iterator, and it could be argued that might have been a bit more efficient. This is because an indexed add for a linked list has to loop through the elements again to find that index and place that element. But when you're dealing with just a few elements, as we are here, sometimes it's preferable to use code that's just simpler to use and read, like this. Let's go back to the main method and add all of our places. I'm at these in no particular order. I'll copy the Adelaide statement on line 21 and paste it, changing the variables each time. First Brisbane with 917 kilometres. Then Perth at 3,923 kilometres from Sydney. Alice Springs 2771. Darwin 3972. And finally Melbourne 877. Okay, there's our test. I'll run this code now. And we get that printed out, and we can see that our itinerary is ordered by distance to Sydney from closest to furthest away. Let's add Sydney as the first place in our list. Places to visit .add first, opening parentheses, new place, opening parentheses, double quotes, Sydney, comma, 0, close both parentheses, semicolon. So here, we just go to add Sydney as the first element in the list with the add first method, a method that's on linked list, but not on array list. Running this code confirms that's what we've done. Okay, so let's end this video here. In this video, we've created an itinerary ordered by the distance to our starting point and prevented duplicates from being added. In the next video, we'll add the interactive part of this challenge. I'll see you in that next video. In the previous video, we created a linked list of places to visit, ordering that list by how close the place was to Sydney. Now we'll create the interactive part of our program with the menu items shown here. We'll use a scanner to get input from the user, and we'll use a list iterator to move back and forth through the itinerary. First, we want a method to print those menu options. I add a new method called printMenu, make it private and static, and add that before the closing bracket of the main class. I'm going to start typing this, then just paste that menu we showed you once we have the triple quotes that start a text block. Private, static, void, print menu, opening and closing parentheses, opening curly brace. System.out.println, opening parentheses, triple quotes. Triple quotes, closing parentheses, semicolon. Closing curly brace. This code is demonstrating that we can pass a text block directly to the system.out.print statement. Right now, it's an empty block. What's nice about using a text block is we can actually just copy that data we showed you and paste it just the way it was on the slide. You've seen me do something similar before. I'll open up challenge menu.txt from the resources section of this video and then paste it in. Now remember, we have to keep the first 3 double quotes on a separate line from the rest of the text block. For the last 3 double quotes, we don't have to do that, though we're doing that here. This adds a new line after this text, and I don't actually want that. So I'm going to change this slightly, removing the extra line and having the triple quotes right after quit. Okay, so there's our print menu method. Now, let's just go back to the main method, and I'll set up the scanner and a few other local variables. Add a var to store our places to visit list iterator. I'll create an instance of the scanner class, and then I'll create 2 Boolean variables called quitLoop and forward and set them to false and true respectively. In this code, we set up the iterator variable using the var keyword and calling the list iterator method on our linked list. Next, we create a scanner variable, which we've done quite a few times, so this should be familiar to you. And we set up a couple of Boolean variables, which I'll explain shortly. Next, I'll print the menu and start the while loop, called print menu, while opening parentheses, not quit loop, closing parentheses, opening curly brace. Then I'll print out a message for the user. String menu item equals scanner.nextLine, opening and closing parentheses, dot to uppercase, opening and closing parentheses, dot substring, opening parentheses, 0, 1, closing parentheses, semicolon. Closing curly brace. Here we use one of the Boolean variables, the quit loop, to determine whether we keep looping or not. And next we get from the console with scanner.nextLine. We force the input to be uppercase, then get the first character with the substring method, chaining all these methods together. This means the user can enter one letter or the whole word in all uppercase or mixed case, and our code can still figure out what they want to do. Next, I want to use a traditional switch statement to process each menu item. I'm going to start with the default label. Add a switch for menu item, default, quit loop equals true, semicolon, break, semicolon, closing curly brace. So this code sets quit loop to true, which will quit out of the loop next time it's checked at the top of the loop. Now we need more case labels for more menu items. I'll start with F for forward, add case for forward. Print out a message that the user wants to go forward. Break, semicolon. And I'm going to copy and paste that case section, change the label to B and the comment to say backwards. And I'll change the statement to say user wants to go backwards, not forward. Okay, so I want to paste that 2 more times, first for label M and call the print menu statement. And then finally for label L, and this time I'll replace the system.out.println text with the places to visit list. So we've set up our loop and we can test that, making sure we can test each option. I'll enter menu selections in lowercase. So we can enter F and C user wants to go forward and B backwards. L prints out our whole list of places and M gives us the menu options again. And Q is quit. So now we've got the shell build out, and that looks good. So now I want to print out the position of the first place at the start of the loop. Can we move backwards? I'll print out where we started. Set direction to forward. Closing curly brace. Here, we check if the iterator.hasPrevious method returns false. This means we're at the start of the list. We print out the first element, the originating place, using the next method. And we set the forward variable to true because we can only go forward when this is the case. And I'm going to copy that if statement, pasting it directly below. I'll change hasPrevious to hasNext in the if condition. I'll change originating to final in the output string and call iterator.previous instead of iterator.next. And finally, I want the forward flag equal to false. Now for this code, if iterator.hasNext is false, this means we're at the end of the list. So we print out the element just up from the cursor using the previous method. This is the final element in our list or final place in our itinerary. We set forward to false because the only direction we can go in from this point is backwards, so forward is false in this case. We'll test this shortly. Now I have to add code to walk through the list backwards and forwards one place at a time. And hopefully you remember how to do this using the hasNext and next methods for moving forward. Can we go forwards? Then I'll print out the next element. Closing curly brace. When the user enters F or forward, we'll just get the next element in the list when there is a next element. And I want to copy that if statement and paste it after the print statement user wants to go backwards. I'll change hasNext to hasPrevious in the if statement. And I'll change iterator.next to iterator.previous in the statement after that. With this code, when the user presses B, we get the previous element after we confirm there is a previous element using hasPrevious, and we print that element out. Okay, now let's test this out. I'll enter the menu selections in uppercase this time. First, we see that the cursor, or iterator, is starting at the originating place, Sydney. And if we press F once, we get Melbourne, our second place in the list. And we'll press F again, and now we get Brisbane, 917 kilometres from Sydney. Let's keep moving forward until we read the end of the list. After Brisbane, we'll get Adelaide, then F, and we get Alice Springs. Another F gives us Perth, and one more, we have Darwin. And we'll know we're at the end of the list when we see final Darwin printed out. Now, let's test going backwards now. Using B, we get Perth, then Alice Springs. And I'll select L next so we can confirm that these cities are being shown as we expect. And we can confirm that Darwin is last, and before that Perth, and before that Alice Springs. Okay, so what happens if we now reverse directions from where we are? Hopefully you'll remember what's going to happen and won't be surprised. I'll enter F here, and now you'll see that Alice Springs has been repeated. Do you remember why? Let's pull up a slide similar to one we saw in the last video. Here, we show the 3B, or back menu items, each calling the previous method. This leaves our cursor position, shown as an orange arrow, positioned between Adelaide and Alice Springs. When we decided to go forward, we called the next method from this cursor position, and that gave us Alice Springs. When we change directions, we have to compensate for the cursor being ahead of where we want it to be. So we have to make the call, either next or previous, twice, the first time to adjust the cursor, and the second time to get the element. Let me add that code in first for going forward, case label F. If opening parentheses, not forward, closing parentheses, opening curly brace, comment, reversing direction. Forward equals true, semicolon. If opening parentheses, iterator.hasNext, opening and closing parentheses, opening curly brace. Iterator.next, opening and closing parentheses, semicolon, comment, adjust position forward. Closing curly brace. Closing curly brace. We know the forward flag is set to true when we start at the top of the cursor. and we set the forward flag to false if we're at the end of the cursor. If forward is false, this means we're moving backwards. In this code, we set the forward flag to true if it's false because the user pressed F or entered forward. With this next if statement, we check to see if there really is a next element. If there is, we want to adjust the cursor, moving it forward one extra spot. All of this code is for when we reverse directions from backwards to forwards. Now, we have to do the same from forwards to backwards. So I'm going to copy those 6 lines of code and paste them after the first statement in the BK section. I'll remove the not from the if condition and change forward to false because we'll be going backwards at this point. Then I want to change has next to has previous, then iterator.next to iterator.previous. This is the same kind of thing as it was for forwards. If the forward flag was true, this means we're reversing our direction and moving backwards, so we set the forward flag to false. And we need to adjust our cursor with an extra call to the previous method, first testing if has previous is true. Let's test this out. We'll start by listing our itinerary with an L. Then move forward with F, gives us Melbourne. Another F gives us Brisbane, then Adelaide, then Alice Springs. And now we want to test reversing direction, so we'll enter AB. This gives us Adelaide, which is exactly the behaviour we want because we were at Alice Springs, so moving backwards should give us Adelaide. And pressing B again, we get Brisbane. Now we'll reverse direction again, for good measure, and press F, and we've got Adelaide. We're not seeing Brisbane twice when we reverse directions because we added the code to handle that. So we've tested reversing ourselves in both directions and got the right results both times, so let's enter Q and quit our application. And that's the end of the challenge. I hope you enjoyed that and that it helped you understand the list iterator and the linked list a little bit better. In the next video, we're going to take another look at wrapper classes because they become more important when we use lists. I'll see you in that next video. I've talked a lot about Java support for groups of similar types or collections, more specifically lists and arrays. In this section, I'll revisit primitive data types and their wrapper classes, and I'll explain why shortly. Some object-oriented languages don't support any primitive data types at all, meaning everything is an object. But most of the more popular object-oriented languages of the day support both primitive types and objects, as does Java. Primitive types generally represent the way data is stored on an operating system. Primitives have some advantages over objects, especially as the magnitude or number of elements increase. This is why many of the object-oriented languages chose not to be purists on this point and continue to provide support for primitive types. Objects take up additional memory and may require a bit more processing power. And we know we can create objects with primitive data types as field types, for example, and we can also return primitive types from methods. So we can mix and match primitives with objects pretty easily. But when we look at classes like the array list or the linked list, which we've reviewed in a lot of detail in this section, these classes don't support primitive data types as the collection type. In other words, we can't do the following, creating a linked list using the primitive type. This code won't compile. This means we can't use all the great functions lists provide with primitive values. More importantly, we can't easily use primitives in some of the features we'll be learning about in the future, like generics. But Java, as we know, gives us wrapper classes for each primitive type. And we can go from a primitive to a wrapper, which is called boxing, or a wrapper to a primitive, which is called unboxing, with relative ease in Java. A primitive is boxed or wrapped in a containing class whose main data is the primitive value. Each primitive data type has a wrapper class as shown on the list, which we've seen before. Each wrapper type boxes a specific primitive value. And how do we box? Each wrapper has a static overloaded factory method, value of, which takes a primitive and returns an instance of the wrapper class. You'll remember that factory methods are often used instead of the new keyword to get a new instance of a class. The code shown on this slide returns an instance of the java.lang.integer class to the boxed-in variable with the value 15 in it. And we can say this code manually boxes a primitive integer. Another manual way of boxing, which you'll see in older code, is by creating a new instance of the wrapper class using the new keyword and passing the primitive value to the constructor. We show an example of this here. If you try this in IntelliJ with any Java version greater than JDK 9, IntelliJ will tell you this is deprecated code. Deprecated code means it's older and it may not be supported in a future version. In other words, you should start looking for an alternate way of doing something if it's been deprecated. Java's own documentation states the following. It is rarely appropriate to use this constructor. The static factory value of int is generally a better choice as it is likely to yield significantly better space and time performance. This deprecation applies to all the constructors of the wrapper classes, not just the integer class. In truth, we rarely have to manually box primitives because Java supports something called autoboxing. We can simply assign a primitive to a wrapper variable as we show on this slide. Java allows this code and it's actually preferred to manually boxing. Underneath the covers, Java is doing the boxing. In other words, an instance of integer is created and its value is set to 15. Allowing Java to autobox is preferred to any other method because Java will provide the best mechanism to do it. Every wrapper class supports a method to return the primitive value it contains. This is called unboxing. In the example on this slide, we've autoboxed the integer value 15 to a variable called boxedInteger. This gives us an object which is an integer wrapper class and has the value of 15. To unbox this, on an integer class, we can use the intValue method which returns the boxed value, the primitive int. This method is called manually unboxing. And like boxing, it's unnecessary to manually unbox. Automatic unboxing is really just referred to as unboxing in most cases. We can assign an instance of a wrapper class directly to a primitive variable. The code on this slide shows an example. We're assigning an object instance to a primitive variable in the second statement. This is allowed because the object instance is an integer wrapper and we're assigning it to a primitive type variable. Again, this is the preferred way to unbox a wrapper instance. Let's get back to some code now and show different examples of when this feature can be used. There are a lot of ways Java supports autoboxing and boxing, and we've shown you a couple of simple examples on the slides. I want to review these in code, but I want to also get you thinking about other places this feature can be used. I've created a project called autoboxing and the usual main class. And I'll start with the examples from the slides for manually boxing and unboxing. Integer boxedInt equals integer.valueOf opening parentheses 15 closing parentheses semicolon comment preferred but unnecessary. Integer deprecated boxing equals new integer opening parentheses 15 closing parentheses semicolon comment deprecated since JDK 9. Int and boxedInt equals boxedInt.intValue opening and closing parentheses semicolon comment unnecessary. Okay, so the reason I'm showing you these three statements is so you'll recognize a couple of things. The first two statements are attempting to manually box the primitive int 15 to an instance integer wrapper class. You'll notice that IntelliJ is trying to attract your attention. Depending on your configuration of IntelliJ, either some parts or everything after the assignment operator is highlighted. In my case, you can see value of is highlighted. Hovering over the highlighted part of that first statement, IntelliJ tells us this is unnecessary boxing, and we've commented that as well. Now, check out the second statement. IntelliJ has, for me, placed an error underneath the integer class, but you may find it has crossed out the integer class in addition to highlighting everything after the assignment operator. Although it's an error, it won't stop the code from running. Let's see what IntelliJ has to say about that. The message we get is integer int is deprecated and marked for removal. And I've discussed that and how this particular method is discouraged. We won't use it again, but you should be familiar with it if you run into legacy code. Lastly, the third statement is also highlighted by IntelliJ, and this message says it's unnecessary unboxing. Remember that unboxing means you're returning the primitive value, unboxing the primitive. I'll leave those three statements in, but I'll add the way you should write this for variable assignments. I'll add a comment automatic. Integer autoboxed equals 15 semicolon. Int autoboxed equals autoboxed semicolon. And then I'll print out both the variables by calling getClass and getName. Here we have two declarations. The first assigns 15 to an integer variable. The second assigns the variable autoboxed to an int variable. Then we print out both variables' class names, attempting to use the getClass method chained to getName. Notice though that the last statement is a compiler error. We can use int variable types in many different places, but not in this way. The JVM knows auto and boxed is a primitive type, and we can't use methods on primitive data types like this. Let's comment that last line out, then run this code. And hopefully, no surprises. The output shows that the autoboxed variable is of type java.lang.integer. This example is a bit forced because it doesn't quite explain why you'd want boxing or unboxing automatically or otherwise. Let's create a couple of methods, one that returns a double primitive type and one that returns a double wrapper instance. Private static double get double object opening and closing parentheses opening curly brace. Return double dot value off opening parentheses 100.00 closing parentheses semicolon closing curly brace. In this code, we use the static factory method double dot value off just to make it clear that in this case we're returning an object of type double. In the second method, I want to return a double primitive value. Private static double get literal double primitive opening and closing parentheses opening curly brace. Return 100.0 semicolon closing curly brace. And that method is pretty simple. We just return a literal decimal number because that's a Java double primitive. Then going back to the main method, we'll call these methods. Double result boxed equals get literal double primitive opening and closing parentheses semicolon. Double resultant boxed equals get double object opening and closing parentheses semicolon. Now in this code, autoboxing and auto unboxing is again occurring, but not by the assignment of simple variables or literals. The method getLiteral double primitive returns a primitive data type, but the JVM is automatically boxing it because it's being assigned to a variable of the java.lang.double class. And the same is true in reverse. The method getDoubleObject returns an object instance, but because we're assigning it directly to a primitive variable, the unboxing occurs automatically. I hope you can see how that's helpful, being able to use method results and autoboxing when you want to assign the results to variables. Let's end this video here. I'll pick up this topic in the next video because I want to walk you through some examples that are specifically related to some of the topics of this section.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
In the last video, we looked at several places where autoboxing and boxing is supported. Next, I want to focus on this feature and how it applies to arrays, variable arguments, and lists like ArrayList and linked list. Hopefully, you still have the code up from the last video because I'm going to continue to use it in this video. First, I want to create an array of the integer wrapper class in the main method. Integer, opening and closing square brackets, wrapper array equals new integer, opening square bracket, 5, closing square bracket, semicolon. Wrap array, opening square bracket, 0, closing square bracket, equals 50, semicolon. And then I'll print out the array. In this code, we create an array of integer wrappers and set the array size to 5. Then we assign the first value, the value 50, and this auto boxes the primitive integer literal 50 to an instance of an integer class. And we print this array out using the array's helper class and the toString method. And running this code, we can see the array was initialized to nulls. Remember, the integer wrapper classes are really classes and their default values in arrays are null references. But the first element prints as 50. And just for good measure, let's confirm we can print out the object type of that first element. I'll use getClass and getName to print out the type of the element. And running that, we can confirm that the first element is java.lang.integer. So the JVM auto boxed the literal number 50 before assigning it to an element in the array. We can also use autoboxing with an array initializer, which I'll do next. I'll create a character array with the elements A, B, C, and D, and then I'll print out the array. Here, we've got an anonymous array initializer that sets up an array of the character wrapper class, and then we want to print that array out, running that. We don't get any kind of runtime errors, and we get those characters printed out as a result. So this is an example of using an array initializer using char literals, and the JVM autoboxes each of those values. Before we look at lists, let's visit autoboxing and unboxing when it comes to method declarations. First, you should know that this feature is supported within methods themselves, both with method parameters and method return types. I'm going to create a few more private static methods which should demonstrate autoboxing in a few different ways. I'll call this private method return an int, and it does just that. Return the int, closing curly brace. In this code, we take a java.lang.integer parameter as an argument and simply return it from this method whose return type is an int primitive. So again, this unboxes the I argument to return the primitive value boxed in the wrapper argument as the return value from this method. Let's try things the other way around. Similar to before, but return as integer this time, and it returns an integer. Return the integer, closing curly brace. This method takes an int parameter and returns it from a method that's got a declared return type of java.lang.integer. An object is expected to get returned, in other words. So I use autoboxed to an instance of the integer wrapper class and returned without us having to worry about or write that code. Putting another twist on this, we can invoke these methods, passing boxed and autoboxed values to these methods. I won't invoke these methods from the main method. Instead, let's extend this a little, creating a method that takes a variable argument of int primitives as one of its parameters. And we will use this method in code. The method will return an array list of integer, and I'll call it getList. I'll also create a local variable of type ArrayList, and I'll then use the for each loop to add the ints to the array list. And then I'll return the newly created array list. This method is declared with a single parameter, a variable arguments declaration for the int primitive. This means this method can be called with 0 to many int values. Inside the method, we create a new instance of an array list with the integer wrapper class as its type in the angle brackets. We can't put just the int type in there, so this is a good place for autoboxing. We use a for loop to iterate over the values we got passed to the method in the varargs argument and add these primitives to our array list. Now the add method on an array list is declared with an integer wrapper parameter type, not a primitive type, so we're really showing many kinds of autoboxing here. Finally, we return the list we created from this method, and we want to call that from our main method. I'll call the getList method with the values 1 through 5, then I'll assign it to the var type, and then I'll just print it out. I'm purposely using the var keyword here because I want you to see the IntelliJ hint. I have this turned off at the moment, so nothing is showing. Let me show you how to have it show in IntelliJ. Come up here to File and select Settings. Type Inlay and click into Type. Then click into Java and check implicit types, which I will do now. Finally, I'll click OK to go back to the code and notice the return type hint is showing now. It shows we're getting back an array list of integer. And then we just want to print out that list. And that just prints out a list of numbers 1 through 5. Now, what if I change this method to take a variable argument of integer wrapper class? With this change, everything still compiles and runs even though in the main method we're passing literal int values. This method's expecting integer instances, but the JVM will again autobox everything in that variable argument list. In a way, this means we can almost use primitives and their corresponding wrappers interchangeably. What this means is that for the factory objects that create lists, we can create lists from primitive literals as we did here in the main method. We can simply replace this call to our custom method with the list.factory method, which we've talked about previously. Remember, this specific method returns an unmodifiable list. Note when I do that, the inlay hint updates to show a new return type from the list.offFactory method. Okay, So let's end our discussion about auto boxing and boxing here. In the next video, I'm going to give you a challenge to see how much you learnt from this discussion. I'll see you in that next video. Okay, so it's time for a challenge on auto boxing and unboxing. In this challenge, you will need to create a simple banking application with a customer and bank type. The customer will have a name and an array list of transactions containing double wrapper elements. A customer's transaction can be a credit, which means a positive amount, or it can be a debit, a negative amount. The bank will have a name and an array list of customers. The bank should add a new customer if they are not yet already in the list. The bank class should allow a customer to add a transaction to an existing customer. This class should also print a statement that includes the customer name and the transaction amounts. This method should use unboxing. Okay, so hopefully that's fairly clear, but gives you a little room to be creative. Alright, so it's your turn to see if you can create something like this. Remember, it doesn't have to be terribly complicated, just keep it pretty basic. The customer is literally only the name and the transactions at this stage. You don't need to store customer contract addresses or anything like that. The main thing is the relationship between the various classes and also the auto boxing and unboxing. Pause the video now. Okay, how'd you get on? Did you figure it out? Let's go through with my own implementation and build this. I've created a new project named Auto Boxing Challenge and the usual main class. And for simplicity, I'm going to add our classes in the main.java source file so they won't be public. But if your solution put classes in separate files, that's okay as well. Actually, for customer, I'm going to make that a record and not a class since there's very little functionality needed. I'll add that now. So we have a customer record that takes a name and an array list of transactions. It would be nice to create a new customer with just a customer's name and an initial deposit amount. Like any class, we can create overloaded constructors in a record as long as a call to the default constructor is the first statement. Let me add this constructor and I'll talk about it after. Public customer, opening parentheses, string, name, comma, double, initial deposit, closing parentheses, opening curly brace. This, opening parentheses, name dot to uppercase, opening and closing parentheses, comma. New, array list, less than sign, double, greater than sign, opening parentheses, 500, close both parentheses, semicolon. Transactions.add, opening parentheses, initial deposit, closing parentheses, semicolon. Closing curly brace. This constructor takes two arguments, name and a primitive double we're calling the initial deposit. And we first call the record's implicit constructor, so we'll pass name, first making it uppercase, and secondly, a new instance of a double array list. Here, we're setting the capacity to 500, which is what I'm estimating will be sufficient for most customers for a year of transactions. Remember, if you can guess the maximum size of your array list, you can set the capacity this way. This prevents the JVM from incremental reallocations as the list grows. After this, we can add the initial deposit to the customer's transaction list. And here we use auto boxing, passing a double primitive variable to the add method on array list, which auto boxes it to a double wrapper instance. So that's a pretty simple record that takes a double primitive argument, then passes that with auto boxing to the add method on transactions. And that's our customer record. I'll create a new customer in the main method. First, I'll create a test customer object. And then I'll print it out. In this code, we create a new customer record, calling it Bob, and passing Bob S and $1,000 to the constructor. Then we simply print Bob out. And we can see the record prints out the name and transactions of the customer record automatically. Now let's create the bank class. As mentioned previously, my solution is putting everything in the one file, main. This time, I'm not going to use a record. I want more functionality and flexibility for the bank, so I'll use a class. Set up our bank class. I'll declare two fields, a string and an array list. and then a constructor that accepts only a string. In this class, we have name and an array list of customers. Note the lack of a public access modifier because it's in this file and not a separate one. We initialize the customer list with a capacity of 5,000, assuming a bank could easily have that many customers as an example. And then we set up a simple constructor just with the bank name. Because we don't have getters and setters, no client code can access the customer list, and this is exactly what we want. Before we add a customer, I want to add a method that returns a matching customer from the list based on the customer name. So first, I add this method calling it getCustomer. Private customer, getCustomer, opening parentheses, string, customer name, closing parentheses, opening curly brace. I'll use an enhanced for loop to search all customers. Have we found a match? Return element if so. Print a message saying that it couldn't be found. Return null semicolon. Again, hopefully there's no surprises with this code. We use an enhanced for loop looping through the customer list. We compare the customer name with the name passed as the method's argument, ignoring the case. If we find a match, we'll return that match immediately, quitting out of the loop and the method at the same time. Otherwise, if we get to the end of the loop, we haven't found a match, so we return a null from this method which indicates no match. Okay, so now it's time for the add new customer method. Public void add new customer, opening parentheses, string, customer name, comma, double, initial deposit, closing parentheses, opening curly brace. If getCustomer returns null, I'll create a new customer object, add it to the array list, and print out a message that it was added successfully. This code is pretty straightforward, I hope. We take a customer name and an initial deposit amount and create a new customer record with these values. First, we call the getCustomer method, and if it returns null, we know we need to add a new customer. So if we get a null back, we create a new customer record and add that to the bank's customer list. And we print out a statement that we've added a new customer. At this point, we have a bank class which we can use to add customers and a customer class to add transactions. Let's end this video here. In the next video, we'll pick up from here and create an instance of a bank, add a customer, and finish the rest of the bank's methods. I'll see you in that next video. In the last video, we set up a bank with a customer array list, and we added a method on bank to add new customers, but first checking if that customer is already in our list. Now, I want to go to the main method on the main class and create a new bank, then add a new customer. Bank equals new bank, opening parentheses, double quotes, chase, closing parentheses, semicolon. Bank.add new customer, opening parentheses, double quotes, JNA, comma, 500.0, closing parentheses, semicolon. And then I'll print out the bank object. Here, we create a new instance of a bank, add a new customer, Jane, with an initial deposit of $500. And we want to print out the information in the bank. Running this code. We see that a new customer was added, and we also get the standard to string method text for a class. I want to go back to the bank class and generate a to string method for this. When I run this code again, we get a slightly better idea of what our bank class consists of. Our bank class doesn't expose its customers, meaning there's no getCustomers getter method or a public getCustomer method. The only way we want anyone to be able to add a transaction is through the bank with a customer name. So now I add the add transaction method to bank, ensuring that it's marked public. Public void add transaction, opening parentheses, string, name, comma, double, transaction amount, closing parentheses, opening curly brace. I'll make a call to getCustomer with the name of the customer. Check if the customer exists. Add transaction if it does. Closing curly brace. This method allows transactions to happen through a bank instance, which gets a matching customer and the customer's transactions, then adds the transaction, again with the use of autoboxing. Next, we need a way to see the customer's transactions, so I'm going to create the method print statement next. I'll make this one public as well. Looking at the add new customer method, I made that one public as well, which is necessary so we can call it from main. Public void print statement, opening parentheses, string, customer name, closing parentheses, opening curly brace. Use get customer again. Check if customer not found. Just exit if not found. The first thing we do in this method is again try to locate the customer record by customer name, calling the get customer method to do that. Remember that get customer is marked as private, so is not directly available outside of the class. If null is returned, meaning the customer was not found, then we'll simply return from this method doing nothing. We could throw an exception or return a null or some other methods, but I'm really just keeping it simple here, especially given the method is just printing a statement. If a customer is found, we want to print out the customer's name and the transactions in a more formatted way. I'll add that code. First, I'll print out 30 dashes. Then I'll print out the customer's name and a heading. I'll use the enhanced for loop for customers. Use printf to print out transaction amount and whether it's a debit or credit. In this code, we first print a line to separate entries using the repeat method on string, which I've used before. Then we print the customer name. Note, we use the accessor method on our customer record and not the name passed in on the method. That's because we want the name formatted in uppercase, which was part of the record creation. Then we print out the transactions using a for each loop. And here is the unboxing part of the challenge. You can see we've set up a local loop variable typed with a primitive double. This means every entry in our array list gets unboxed, then assigned to this primitive variable. And then we print out a formatted statement using printf. You'll remember that specifiers have additional options, and we use one here for the transaction amount, %10.2f. This prints a double value with a width of 10 and a precision of 2 decimals. Then we'll print out whether the transaction was a debit or credit in parentheses. We use a ternary operator to check if the amount is less than 0 to determine what will get printed. And that's it. I'll add a couple more transactions for Jane and print her statement out in the main method. A debit transaction for $10.25. Another debit for $75.01. Print them out. Running this code. We get the information about Jane A and a list of her transactions printed out, formatted, and specifying if the transaction was a credit or debit. Notice that it didn't matter what case we used in Jane A's name, it found her customer record in each of these instances. Okay, so that was the autoboxing challenge, and we created a simple bank application that kept track of a list of customers. And each customer had a list of transactions. Finally, for good measure, let's test our methods for a customer that we never added, Bob S. Add a $100 credit transaction for Bob and print it. Running that. We see that in both cases, Bob S isn't a customer of our bank. And even though we created a customer instance for Bob S, we can't really add him to our bank. The only way to add a customer to our bank is using the only constructor we have, which takes a name and an initial amount. Okay, let's add him that way with an initial deposit of $25, and I'll change the case. Use add new customer this time. And running with this code now, we get a statement for Bob S. I hope you had fun with that and can start to see why array lists with wrappers makes the job easier in a lot of ways than trying to manipulate everything as a primitive array. In the next video, we're going to look at another special type in Java called the enum. So let's move on and see what the enum gives us. In this section of the course, we've covered array lists and linked lists, which let us have a list of elements all the same type. In this video, I want to look at another list type in Java called the enum. The enum type is Java's type to support something called an enumeration. Wikipedia defines enumeration as a complete ordered listing of all the items in a collection. The distinction here is on the phrase all the items. And Java describes the enum type as a special data type that contains predefined constants. And a constant is a variable whose value can't be changed once its value has been assigned. So an enum is a little like an array, except its elements are known, not changeable, and each element can be referred to by a constant name instead of an index position. An enum, in its simplest form, is described like a class, but the keyword enum replaces the keyword class. You can name the enum with any valid identifier, but like a class, upper camel case is the preferred style. Within the enum body, you declare a list of constant identifiers separated by commas. By convention, these are all uppercase labels. One example of an enum is the days of the week, as shown here. An enum is ordered by the way you declare the constants. This means that Sunday is considered the first day of the week and Saturday is the last day of the week. The enum type is used to declare a limited set of constants, and sometimes there is a natural order to the listing, as in the case of days of the week. Some other examples of possible enum declarations might be the months in the year, January, February, March, etc. The directions in a compass, east, north, west, south. A set of sizes, extra_small, small, medium, large, extra_large. Underneath the covers, the enum type is a special type of class which contains fields to support the constants, but we'll get into that in a later discussion. You don't have to understand all the internals of an enum to derive the benefits of using this type. Once you get used to how this type works, you may find many places to use an enum. They simplify your code and make it more readable in many ways. I've already created a project called enum project and have the usual main class and main method. Now, to start, creating an enum is like creating a new class. A few videos ago, I made a mistake and clicked the wrong folder and ended up with the wrong package name. So don't click the LPA folder. Rather, right-click on the SRC folder and click New, Java Class, but pause here. You can see that enum is one of the options we can select in addition to class or record, and we do want to pick that. And we'll call this enum div.lpa.dayoftheweek. Like a class, a new source file is created with the name dayoftheweek.java, and we have the enum type, name, and body created for us. And like other types, the enum at this level can use either the public access modifier or none at all. The enum constant names can be anything you want them to be. In this example, I'll create an enum of the short names for days of the week. The important thing to notice here is that we're coding these labels all in uppercase, which is the convention for constants. And this is not really a statement, meaning we don't have to end it with a semicolon here. So that's the first enum type. They are very simple to set up and quite useful to use in code. Next, we want to see what we can do with this in the main method of the main class. Going back to that method, the first thing we can do is create a variable with this type, the enum type we've created, days of the week, and we can assign this a value. This value can be any one of the constant labels in the enum. And then I'll print it out. Here, I've created a variable called weekday and assigned it the enum value, that's the abbreviation for Tuesday. And I've passed that variable directly to the system.out.println statement. Now, let's see what happens when I run this code. And you can see the output. It printed out the label for Tuesday. And we can use two methods on this simple enum type, the first to print out the label and the second method to give us the ordinal value or order of this constant in the enum collection itself. I'll do that now with this weekday. System.out.printf, opening parentheses, double quotes, name is %s, comma, ordinal value equals %d%n, comma. Weekday.name, opening and closing parentheses, comma, weekday.ordinal, opening and closing parentheses, semicolon. And running that, we get the additional line of output, that name, from the name method is TUES, and the ordinal value is 2. Now, like arrays and lists, enums start with an ordinal value of 0. The constant with the identifier sun would return a 0. This means, in Java, it's the first element in this list. We'll look at that shortly, but this statement means that Tuesday is not really the second day of the week, it's the third, because Java starts counting at 0. Now I want to create a method that returns a random day of the week. Public static day of the week, get random day, opening and closing parentheses, opening curly brace. I'll create a new instance of random, call the nextInt method on it with 7, and then I'll assign to an int variable. I'll also call the values method on the enum and assign it to the var type. And then I'll return the random element in the array. The first thing to notice here is this creation of a new random instance. And we've used this class in previous videos, but in this case we're not assigning the instance to a local variable. We're passing a 7 as the bounding integer to nextInt. This means we don't want anything greater than or equal to 7, the random number should be between 0 and 6. And that's because the values of our weekdays are 0 through 6, with Sunday being 0 and 6 being Saturday. And we'll call the nextInt method from that new instance of random, which will give us that random number. So enum types have a method named values, which returns an array of all the enum constant values. And here, we return the result of that method to a variable we'll call all days, and we'll use the var type here. Now, what I want you to notice is the IntelliJ hint telling us that we got an array of day of the week back from that method. If you don't see the hint on your computer, watch the Introduction to Autoboxing and Unboxing video about 4 videos back in this section where I showed how to activate the setting. So now, because we have an array, we know we can use the random number as the index and return the value at the randomly selected position. Then we have a method to return a random day of the week. Let's test this out, say for 10 times. We'll wrap that last system.out.printf statement in the main method in a for loop. I'll loop from 0 to 9. Call the method getRandomDay and assign the result to the variable weekday. Closing curly brace. In this code, we're going to loop 10 times, and each time we call the getRandomDay method. We don't know what day we'll get back since it's random. And then we print the information about the day, its name and ordinal value. And running that, your output is going to be different, of course, but you can see the weekday is changing and its ordinal value is shown. And hopefully you've got every case there for each weekday. Another thing you can do is test if your variable is equal to one of the constants using the equals operator. I'll add that code next in the for loop. If weekday equals Friday, I'll print out a message. In this code, we test if the randomly generated weekday is a Friday, matching it to the enum constant, fi, and if it is, we print found a Friday. This demonstrates the readability benefits of using an enum. It's very easy to see that this code is testing if the day is a Friday. I'll run this a few times so you can see the randomly generated results. Okay, those are some of the basics of the enum type. In the next video, I want to talk about using enums as the expression in a switch statement, which we haven't covered yet. We'll also add an extra custom method to an enum, so I'll see you in that next video. In the last video, I showed you the simplest form of the enum type, which lists constant labels in a specified order. And we walked through how to create and declare a variable of an enum type. In this video, we're going to continue exploring the enum type, continuing with the enum project from the last video. I'll start with another method called switchDayOfTheWeek, which takes a day of the week parameter. This will print out information about the day that's passed. You can use an enum as the expression in a switch statement. This is one of the types we didn't cover in the previous switch videos, so I want to show this to you now. I'll create a method called switchDayOfWeek, which prints out the full name of the day of the week and the number of the day of the week we expect. What I mean by that is that Sunday should be printed out as day 1, not day 0. So I'll set up the method first. Public static void switchDayOfWeek, opening parentheses, day of the week, weekday, closing parentheses, opening curly brace. Int weekday integer equals weekday.ordinal, opening and closing parentheses, plus 1 semicolon, closing curly brace. In this code, the method parameter is weekday, and that's got our enum type, day of the week. An enum type is like any class type and can be used as a method parameter or return type. And the first thing we do is get the ordinal value and add 1, so that's going to be weekday 1 through 7. Now, I'll add an enhanced switch. Switch, opening parentheses, weekday, closing parentheses, opening curly brace. For Wednesday, I'll print out Wednesday. And for Saturday, I'll print out Saturday. Closing curly brace. Now look carefully at this code. We can switch using the enum type itself in the switch expression in the parentheses. This means we can use the variable that has the type day of the week. We learned that we could use the switch statement on a string, int, char, byte or short. But now we're seeing the switch statement for the first time with an enum type. And look at the case labels. These are the constants we specified in the enum, so that's kind of neat. For Wednesday and Saturday, we'll print that out. And now, let's add some default code for the rest of the labels. For the default case, I'll use chart to extract the first letter, then I'll add the rest of weekday as lowercase, and then I'll print it out along with its integer. This code is a little messy, but it lets us revisit some of the string methods. The more you use these methods, the more they will become second nature to you. First, we get the name of the weekday from the enum, and we'll get the first character using chart with 0. After that, we'll concatenate all the remaining characters after the first character. You can see we get that using substring passing at 1. This gets all the letters, starting at the second letter through to the end of the string. Then we chain the to lowercase method to the result of that. This is going to take the enum constant name and basically change it to upper camel case. Then it will append day to that to get the full weekday name. Now I'll call this method from the main method. I'll comment out the system.out.printf statement, the 2 lines after the first statement in the for loop, including that if statement. And then I'll insert the call to my new method here. Switch day of week, opening parentheses, weekday, closing parentheses, semicolon. Okay, and running this. Again, your results will be different, but you should see that your weekdays are all properly named. And you can see that day 1 is Sunday and Saturday is day 7. If we run that code a couple of times, we should eventually see the output for each day of the week. There's one other enum feature I want to show you, which could have been an option in the Bill's Burger challenge if you remember that challenge. To do this, let's create a new enum and call it topping. This time I want to right-click the LPA folder and create the enum there. If you select a folder that is part of a package, as LPA is, then the package name is assumed and you just type the class name, or enum in this case. If I type the package name now, we will end up doubling up on the package name, which I did earlier in this section of the course. The bottom line is if you click the SRC folder and want to put the class in a package, qualify the class with the package. If you click a package folder, don't enter the package. As you can see now, I didn't type the package and IntelliJ has placed the enum in the dev.lpa package. Right, I'm going to add some condiment types. Mustard, comma. Pickles, comma. Bacon, comma. Cheddar, comma. Tomato. Here, we have a list of things which might be toppings on a burger. Now, in our case here, order's not really important for this set of constants. But what's interesting about an enum is that underneath, it's really just a class, and each of the constants is an instance of that class. We can add fields, methods, and even constructors to the enum type. Before you add any methods or code in the enum, you have to include a semicolon after the list of values. So the semicolon is required if you're customizing this type any further, which I'll do now, adding a method. Public, double, get price, opening and closing parentheses, opening curly brace. Return 0.5, semicolon, closing curly brace. Here, we've got an enum with our own custom method available to be used. And we could even include a switch statement in this method that switches on the enum instance itself. We can use that to return a different price for different condiments. I'll delete 0.5 and add switch and use this. I'll add bacon as a case with 1.5, cheddar with 1.0, and default 0.0. I'll close the switch and end the line with a semicolon. This is one way to return a different price for different toppings. Another option would be to create a field on this enum called price and use constructors for each label. But these are more advanced features, and I'll cover them a bit later in the course. For now, understanding that an enum can provide us with a list of constants to use in our code with public methods available for each constant can provide us with quite a bit of functionality. Now, let me show you how to loop through this enum and get the price for each condiment. I'm going to use a for loop, putting this code in the main method. In the enhanced for loop, I'll loop through the values one at a time and print out the name and price. Our loop variable has the type of the enum, which is topping, that's the enum type, and the type of that loop variable. This is followed by the colon, and next we can pass in the array we want to loop through. And for this code, we want to loop through all the constants in the enum. This method, values, returns an array of all the enum constants, so we can just put the call to that method as the second component of the loop. And for each element, which we call topping, we print out the enum constant name. Finally, you can see we can print out the result of the getPrice method on each enum value. This is our custom method. And if we run that, we can see the prices of each condiment, and we can confirm that bacon is 1.5 and cheddar is 1. In general, you can use enums for a long time without ever adding your own custom method, as we did here. I just wanted to show this to you so that you're aware the enum is much more than just a list of constant values. You can see, with a small amount of additional code, you can include additional information or functionality for each constant. In this video, and the previous one, we introduced you to the enum type and what you can do with it. The enum is a special type of collection where it's usually a well-known limited set of constants that can be used. When we review date-time processing in Java, we'll learn about several enums that Java provides for days of the week and months of the year. This is the last video in our list sections of the course. After this, we'll be starting a new section on abstraction, another very important object-oriented concept. This will include abstract classes and interfaces. The interface type gives us a lot of functionality that will lead us to more advanced topics like generics and Lambda expressions. Let's move on to that next section. In this video, we're going to start talking about interfaces. So an interface, in Java terms, specifies methods that a particular class that implements the interface must implement. Now, the interface itself that you're creating is abstract, and that means that there's no actual code for any of the methods. You only supply the actual method names and the parameters. The actual code still goes in the actual class that you're creating. But the idea is to use an interface to provide a common behavior that can be used by several classes by having them all implement the same interface. So it's really a way to standardize the way a particular set of classes is used. So looking at an example, if we have a look at a simple class that I created called Gearbox, you can see that there's a private Boolean field there called clutches in, and there's a simple public method there called operate clutch, which is sent a parameter called in or out. And if the string value is set to the value in, then the clutches in Boolean field is actually set to true, otherwise it's set to false. So that's just one way of implementing a particular method to decide whether the clutch is in a Gearbox class, but that's probably not the best way of doing it. It's a little bit untidy. So if we wanted to actually do something different, we might decide that we wanted to actually change this here to a Boolean, like so, Boolean in or out, and then we could do something like this clutches in equals in or out. And that's certainly valid code and it does work, but the problem would be then that the actual signature, in other words, this component of the public method has been changed. And if you've got some other code that is reliant on the fact that this first parameter was a string, as it originally was, and we've changed it to a Boolean code, it means we've broken that other code in the sense that that then has to be changed. That code has to be changed as well. And if you're using a very popular framework, or your code is used in a lot of other places, this could be a serious problem. And it's not something that becomes immediately aware if other programs are actually using your Gearbox class, this class here, an example. The problem actually is that although we've created this Gearbox class, we haven't really made a sort of a commitment, if you will, that it will not be changed. In other words, we haven't sort of said that once we create this particular public method, we aren't going to change it. So what that interface is just that. It's actually a commitment, a contract, if you will, that the method signatures and that those variables in the interface, constants if you define any, will not change. So consequently, you can create an interface and use it, and you'll know that provided you stick to what's in that interface, the code isn't going to change and you're not going to be breaking code anywhere. So let's actually go ahead and create an interface and talk more about how it actually works. We're now going to create an interface to define the behavior of a telephone. So I'm going to come up here to my package as normal, click on New. I'm actually going to select class, but then I'm going to come down here and select interface. So I'm going to actually type the interface name, and by convention, you normally type I as the first letter, capital I, for the fact that it's an interface. So we're going to say I telephone, which means it's an interface named telephone. And you notice that there's a slight variation. Gearbox, the class has got public class gearbox, but an interface uses the word interface instead of class. So then what we actually do is we want to define just the methods, in this case, that we're going to be, or that are going to be used in this interface, that a class that implements this interface needs to actually implement. So let's move ahead and actually do that. So I'm going to type public void power on. That would be a function of a telephone to power it on. Public void dial. We're going to dial. We're going to send the parameter phone number. And notice how I'm not actually creating classes. I'm creating what's called the signature. So this is the parameters, the name, the return type, and any parameters, but we're not actually defining the actual code itself. That still goes into the class that inherits this interface. So we're just defining the actual methods that form this interface. So answer would be another one. We'll try another one. Public boolean call phone. We want to return a status to see whether we were successful or not. And int phone number would be the parameter. Let's do another one to determine whether the phone's ringing. Is ringing. So that's a simple interface. So again, all we've done here is we've said for a class that it is going to implement them from this interface, these are the methods that it has to implement. So you don't write code in the interface as such. You still write that in the class, which you're about to see, but we've just defined here the contract. In other words, the contract and the actual parameters, the return types that are valid for each method that overall will make this a valid class effectively. And notice also that public actually appears, and it actually says it's redundant for interface methods. And that actually makes sense if you think about it. And that's because we're actually implementing the interface in a class. So the interface exists to define the methods that must be implemented. So in other words, private or public is really useless in essence, because you're going to be doing that in the actual class. So you could actually, if you wanted to, remove this altogether, because we don't actually need those that access modifier effectively. So that's quite valid to do that as well. So now that we've actually done that, how would we go about implementing this interface? In other words, how do we go about defining a class and saying our class is going to be using this interface? Well, to do that, we're going to create a new class first. I'm going to create a new class called desk phone. And this will be a regular class, so I'll just call it desk phone. And the way you actually get it to use the interface is you use the implements keyword. So you type implements. Now type in I and it should automatically find that other interface. You can see the iTelephone interface it's found for us. So we've done that now. As soon as we've actually typed that in, we're getting a red error. And the error actually is class desk phone must either be declared abstract or implement the abstract method power on, and it's actually those other methods as well. So what it's actually saying is we need to start implementing some of these things in order for this to become a valid class. So there's a couple of ways forward. You can actually do this automatically. You can create the basic methods. You can create stubs for these methods, which means you can create empty methods that implement these if you want, or you can type them manually. So I'm going to actually type a few. So I'm going to type my number for starters, which will be the phone number. And let's do another one. Private boolean is ringing. Is ringing. So to go ahead and actually create them, we can actually go up and do, notice here, implement methods. We haven't actually used that before, but if we actually click on that, it automatically went into the interface for iTelephone, and it's found all these methods and says, do you want to implement these? So I'm going to click on, yes, I'm just going to leave the options selected for all of them. Click on OK, and you notice it's now overrode each one of those functions, and suddenly the class is now quite happy because we've actually done them all. And just to confirm, if we delete, say, the second one, we'll get an error again because not all the methods have been implemented. So again, what we're trying to do here is we're trying to say that in order to be a valid class, we're saying that for a telephone class that is in our application, these are the 5 methods that must be implemented with the appropriate parameters and where appropriate with the appropriate return types, be it void or an actual type. And at that point, we could then go away and actually create some code if we wanted to. We could do something simple, like for example, with a desktop phone, there's probably no on button. It's probably always on. So we could type something in there. No action taken. Desk phone does not have a power button. For the dial, now ringing. So we're creating the functionality for this particular type of phone. For answer, we want to check first to see whether it was ringing. So we put if is ringing. Answering the desk phone. And we'll set is ringing to false because we've answered it. Pretty simple. And say for call phone, if phone number is equal to my number, is ringing equals true, else is ringing equals false. Or return is ringing. Just a very simple concocted example here just to show the concept of the interface. And lastly, is ringing, we're going to actually return the variable is ringing to see whether that's true or false. So although the interface relies on all these methods, even if you don't want to use it, so for example, with the desktop phone, we might have decided that we're not going to actually have a power on button, we still need to implement it. So the implementation can be simple, in other words, overriding that function as actually just putting an error message to say not supported or not needed for this type of telephone, if that makes sense. So you can't sort of decide with an interface that you only want to implement some of the methods. In this case, if you're implementing this interface, you have to actually implement all the methods. That's part and parcel of the contract of ensuring that that's actually implemented. So now let's go ahead and create an instance of the desktop class. So we can do that by going into our main. So we can go ahead and type I, telephone, and let's say Tim's phone. And we can put Tim's phone equals new, desk phone, 1, 2, 3, 4, 5, 6 being the phone number. Now the point I want to make here, now we've actually got an error there. I didn't create a constructor, so I'll go ahead and actually create that constructor because we'll actually use that, so it'll actually be handy to use. And the constructor will actually just store the number. So we'll do constructor, we'll accept the actual number and actually store that in our variable, in our field. And back to main again, so that's okay. And let's just call some of the functions. So Tim's phone dot power on, Tim's phone dot call phone. Let's just call the phone number with the same number. And Tim's phone dot answer. Now the point I want to make here is you can define the actual type to be the type of the interface. But what we couldn't do, we can't actually do a equals new iTelephone. That's not actually valid. And actually even a topic might help. Topic correctly might help. It's not actually valid to do that because by doing that, you notice automatically what IntelliJ did was it overrode it all to create a class within the implementation, which we don't obviously want. So I'm going to undo that. And if you think about it for a minute, it actually makes sense why you can't do that. I'll just take back to how it was. And the reason that it makes sense is we've defined in the interface, but the actual class implementation, in this case desk phone, is the specific functionality for a certain type of telephone. So the interface is there at an abstract level to tell you what methods are valid and have to be actually overridden in an actual class. So that's why you can't actually instantiate it using the iTelephone interface. You have to actually use the actual class that has overridden that functionality. So we could have actually also done this. We could have changed this to desk phone. That's certainly valid as well, and that will work. And I'll actually show you later on why you might actually need to do that in certain circumstances. But it is also valid to do it as I've done there, to actually use the data type of type iTelephone in this example in your definition, provided you use the appropriate class that has implemented the interface in our case, it was desk phone. All right, so I'm going to end the video there. In the next video, we're going to actually continue on where we're at. We're going to actually implement a mobile phone class, and then we're actually going to go back to some of the code that we've done previously in the course, specifically with the linked list, and talk about an alternative way of doing that using an interface. So I'll see you in the next video. In the previous video, we started work on interfaces, and we came up with a base example of a desk phone. And we obviously implemented the interface, as you can see in the code. So pretty basic. So what we're going to do is continue on with this now. I'm actually going to come up with another example, and we're going to create a mobile phone class that also implements the iTelephone interface. So I'm going to create new Java class and do mobile phone. And what I'm going to do is actually grab some of the desktop phone code. I'm going to grab it from that point onwards and copy that there, and then just paste that in just to save us a bit of time. I'm going to paste it in like that. So we've essentially at this stage got the exact same functionality. We need to just make a few little changes so that it obviously works. So with the mobile phone, what we're going to do is we're going to add another field. We're going to add a Boolean to see whether it's on, because obviously you can turn a mobile phone on. Generally you do turn it on or off, as opposed to a desktop phone would normally be on all the time. So Boolean is on. Set that to false initially, so it's not going to be on. But in the power on section, we're going to set that to is on equals true. And we're going to change that, the actual message, but the other one actually said no action taken. For this one, we're going to set it up so it actually says mobile phone powered up. We're also going to change the public constructor. So we need to do that obviously because that's still got the old code there. So we're going to set that up and just make that the mobile phone name instead, like so. We'll actually also look at the dial, and with the dial, we'll set it up so that it has to actually be on the phone before we can actually dial, and if it's not on, we're going to show a message. So we're going to put if is on, now ringing, and we'll change this instead of on desk phone to put on mobile phone. Then we'll change that and put an else, phone is switched off. Like so. So that's for the dial. And we also will change the answer method as well. And also we'll change the call phone. So with answer, the only thing we need to do there is we'll actually change the message. So it says mobile phone like so. And the call phone method, we'll change that. We'll check to see whether it's our number, but then we'll also check to see whether it is on. So we put and is on. Like so. So it has to both be on and be our phone number in order to actually call. And we could do something else. We could maybe put melody playing. So it's obviously a different type of ringtone because it's a mobile phone. And I think that should actually be it. So at this point, then we can go back to our main class and our main method, and we can do something similar. So we can actually do something we did before. We can set this up now to put Tim's phone, the same variable, equals new mobile phone 24565, like so. We can initially try it with Tim's phone.call and with the number 24565 to make sure it's valid, and Tim's phone.answer. Now, I purposely have left out a line here which will be Tim's phone.power on. Leaving that out off, I should say for now. Leaving that out for the moment because we should be able to see what happens if we haven't actually got it started. Can run this. And ring, no action taken. Desk phone does not have, that's got those initial messages. And what happened was there with the call message, call phone, we put is ringing equals false, but we didn't actually print a message. So if we go back to mobile phone and the call phone, we actually had this successfully testing to see whether the phone was on, but we didn't actually have a message. So we'll change it there and we'll put a message also to indicate that mobile phone not on or number different. So, and now if we go back and run that again, we should actually see that message from the mobile phone class. Mobile phone not on or number different. Now, the other point I want to make here is if we go back to the main class again, notice how I was able to set a new instance of mobile phone that's a completely different class, but it still worked. Now, normally if we had come up here and we actually had assigned that to be the type of desk phone, then this reassignment wouldn't have worked. So if we had done that, desk phone, we'd actually get an error here, And that's because they're incompatible types. As you can see, one is obviously a desk phone class, the other one is a mobile phone class. But because we didn't do that, we actually changed it to, so the type was the iTelephone interface. We're able to change it and to actually create a new instance of what is essentially a different object, different class, and it still actually works, which is pretty cool. And that's because they both implement the same interface. And again, we didn't actually we didn't call the power on method, and so correctly it came up and said the mobile phone number was not on, or the number was different. So if I add that code back, like so, and if we run it again, melody ring answering the mobile phone. So that's all working nicely, as you can see. And again, just to be clear, it's a good idea to actually put the fact that it's an interface by putting the capital I before the name of the interface. And that really does make it be abundantly clear that this is actually an interface. But the other thing is to point out is if you actually have a look over here in the left-hand side, and I'll just zoom it up a little bit so you can see it. You notice how the other classes have got a C with a blue circle, but the interface is in green with an I. So that does actually tell you that it's actually an interface at a glance. You can see that. So do look out for those types of things with IntelliJ. Whenever you see some data, some sort of presentation, like a variable type or some pop-up window or something like that, IntelliJ will often tell you at a glance what it's for. In this case, you can see that there's an I there for interface. Okay, so moving on now from this example, what we're going to do is we're going to open the code from the playlist, which was in our linked list challenge from lecture 64. Now that code is available in this video, so you can go to the resources section of this video and you can download that source code. It's also, that's probably the best place to grab it. And you can do that and unzip it and actually run it. And what we're going to do is we're going to actually change a few things. We're going to take a list instead of a linked list and just make a few other changes and show you how easy it is to actually use the power of interfaces. So I'm going to actually close this down now. Close project, and what I'm going to do is you can see here I've actually created another one. I've got interfaces.linkedList. So this is the linked list challenge that we did recently in the previous section of this course, and what I'm doing now, I've just copied basically the code out of that into a new folder called interfaces.linkedList, and I'm just going to open that up so that the changes we make won't affect that other code in case you're still working on it or you want to have that version of the code there. So if I now go into my programs, I go into interfaces.linkedList. I'm just going to choose, or go into the linked list challenge subfolder and choose now. That should open that up for us. And this code again should be pretty familiar to you if you've actually been through the linked list challenge. And again, if you haven't, that's fine. There's no problems there. Now, the reason I've opened this code up is just to show you how the Java libraries make extensive use of interfaces. And the one that we used recently was the list interface. So what we're going to do is go and open the add to playlist method in the album class. And I want to actually show you how we can make a change and for it not to actually break anything. So we're going to go to our album. And what we're looking for is the add to playlist, the one that's got the track number and also the list. Now, at the moment, you've got linked list there, as we talked about. Now, because we're using interfaces, we can change that to list, and it still actually works quite nicely. And it's just asking for the import, so I'll import that. But you notice how the code is all still compatible. And if we change that a little bit, we go back now to the main method where it's actually calling this code and make a change. We can run this code virtually without changing anything else. And that's because the Java libraries are making extensive usage of interfaces. And if they weren't doing that, we'd find that a lot of this code would break. So if we go back to our main method now, the main method actually, the one we want to change is the print list first, because that's got a hard-coded linked list in there. So we're just going to make that just a generic list. And also the play method. That's also using a linked list. We change that so it's just a list as well. And also we need to change the declaration of the playlist to be a list instead of a linked list. Make that just a list, like so. And lastly, if we go to the playlist where we actually set up the playlist, that's this one here. We're using a linked list there, but we could actually literally just change that as well. We could change it to a list. List. So we changed the entire type. And actually that would need to be an array list. So we're changing it from an array list. And of course it was a linked list. If we do that, and there's one thing I didn't change, which was in album. We go back there and have a look at that. We need to change this reference as well, which was a linked list. Change that to list as well, because we had an overloaded method for add to playlist. Go back there again and the errors should have disappeared. And you can see we've done all of that and it's still going to work. And that's because the Java libraries use interfaces extensively. So we can do something like play next song. I'm playing Holy Man. To replay the current song, to go to next song, previous song. So the bottom line here, the thing that I'm wanting to point out is the Java libraries do make extensive usage of interfaces, and because they've done that, we're able to change out the entire implementation from what was a linked list to an array list very simply. And we've actually we've done that with a minimal amount of changes, which is pretty awesome. So that's one of the reasons why you'd want to be using an interface. It just makes it a heck of a lot easier to make your code work. And in this case, the Java libraries have set it up so you can use array lists, linked lists, and so forth, and make those really interchangeable. Now you can even use another type, and the reason that this works is that the contract that's defined by the list interface, and just to be clear, if we go into the list interface and have a look, and notice how list is a public interface, because of that contract with these methods that are actually in the list or been specified in the interface, so long as you create a class that implements these methods and actually creates real methods, creates the code, in other words, that create that functionality, things are going to actually work fine. And we're able to, as you can see in this example, we were quite easily able to change this and make this a generic list. But then in the main method, when we actually set it up, we created an array list. Well, I think that was already set for an array list, but we made this generic here. But the playlist, which was originally a linked list, we changed that to an array list. And because the array list, which implements the base list interface, is still supporting all the methods, it has to have implemented those methods. Everything still works nicely. So that's really the power of an interface. And if Java are using that a lot internally in their code, you know that it's a good way to actually code in those scenarios. And just to give you another example, we could use another type of list here. We could change this instead to a vector. Vector is another type of list, and we do that, and the code still works and it's not broken. So it's very normal when you're creating lists in your code to define the basic type to be of type list. And then when you actually create or you actually initialize the variable, that's when you actually specify the actual type. In this case, a vector or a linked list or an array list. So it's probably a good habit to get into just to make your lists, use it just a generic list as the type, as I mentioned there, and then you just specify the actual type that you want in your program when you initialize it. Now, in terms of actually deciding whether to implement an interface or inherit from a base class, sometimes it can be a little bit difficult to decide which one to do. In other words, should you create a class and extend from that? In other words, inherit from that class, or should you use an interface? So one example would have been that we could have had, in our example with the telephone, we could have had that class and extended it to create a desk phone or a mobile phone class, or both of them. But in this particular case, it probably wouldn't have been a good approach. So the way to decide that generally is to really consider the relationship of the final class to the object that it's extending or implementing. So in other words, with our telephone example, both devices have a telephone. So the desk phone doesn't have anything else, but the mobile phone is not just a phone despite its name, because of course a modern mobile phone has more computing power than a desktop computer of only 15 years ago, and really can do far more than make or receive phone calls. So it's more accurate to say that a mobile phone is actually a computer that has a phone interface. So you could say that a desk phone can telephone and a mobile phone can telephone, which indicates that they should both implement a phone interface rather than extending a phone class, if that makes sense. The other thing that's important to understand is that a class can only inherit from one superclass, unlike other languages like C++, for argument's sake, where you can do that. But you can actually implement from many interfaces. This is something that's actually quite powerful. So you can actually implement from many interfaces. As I mentioned, that some languages allow multiple inheritance by allowing a class to inherit from several base classes. But in Java, multiple inheritance is only available by implementing several interfaces. If you want more details on this, consider the animal class that we created on the lectures in the inheritance section. Now, not all animals can walk, so we cannot put a walk method in the animal base class, but we could define, say, a walk interface though. So if that was the case, we could then consider birds. They can walk, and most of them can also fly. So we can create a fly interface as well. A dog would extend animal and implement walk. A bird would extend animal and implement both walk and fly, if that makes sense. So in this case, a dog is an animal and a bird is an animal, so they both inherit from the animal class. But a dog can walk, so it implements walk, and a bird can both walk and fly, so that would implement from both interfaces. So I hope that's clarified. There's an important distinction there. And again, the way you decide is just to really look at or really consider the relationship of the final class to the object that you're extending or implementing. Okay, so I'm going to end the video here. In the next video, it's time for a challenge. So we'll do a challenge on interfaces. So I'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a star freelancer.